Welcome to this 10-hour plus Java Masterclass video. In this video, you'll get a comprehensive introduction to Java programming straight from our complete premium course. We'll be starting with the absolute basics, covering topics like setting up your development environment, understanding data types and variables, handling user input, working with strings, control statements, loops, arrays, and even building your first methods. Along the way, we'll tackle hands-on coding projects to get you comfortable with the fundamentals of Java. These lessons are just a small part of what you'll find in our full premium course, where we dive much deeper into Java. So even though this is a 10-hour video, it's really just a fifth of our entire premium course. So in the complete course, you will learn everything from object-oriented programming, file handling, and GUI development with JavaFX to creating web applications using Spring Boot. Plus, you'll get access to tons of supplementary materials like handouts, cheat sheets, quizzes, and exercises, all designed to help you solidify your skills and become a confident Java developer. You can find the link to the full course in the description below. So if you enjoy these lessons and want to learn more about Java, then make sure to check it out. Good luck on your journey, and let's get started with over 10 hours of hands-on Java programming. Welcome to the first day of our Java Masterclass. Today we'll be getting started with Java, one of the most popular programming languages in the world. We'll begin with an introduction to Java, its features, and what makes it so powerful. Then we'll take a quick look at JDoodle, the tool that we will use to write and run our Java code. You will write your first program, the classic Hello World, and learn how to display text on the screen. Next, we will break down the predefined code that Java provides, look at some common errors you might encounter, and even learn how to use GenAI to find and fix those errors. We'll finish the day by covering some key concepts like the difference between print and println, comments, and escape sequences, as well as an introduction to numbers and basic math in Java. By the end of today, you'll have written your first program and gained a solid foundation in the basics of Java. So let's get started. Welcome to this presentation about the introduction to Java, and in this presentation we're going to look at the history of Java as well as why it is such a great language and why it makes sense to learn it. So let's get started. Java was developed by James Gosling and his team at Sun Microsystems in 1995. It was initially designed for interactive television, but was too advanced for the digital cable television industry at the time. However, its portability, robustness, and simplicity made it ideal for web development and enterprise applications. Java has an English-like syntax, which makes it the perfect language for beginners who can learn Java in two phases. Begin with core Java and then progress to advanced Java. So Java has a simple learning curve, and if you possess the foundational knowledge of C and C++, it won't take long for you to master Java. But even without these foundations, it's going to be quite a good journey, so don't worry about it. Before diving into coding in Java, it's important to understand its features and why it's widely used in the industry. Java's features make it a top choice for programmers. Features of Java are the simplicity. So Java's syntax is easy to understand, much like learning to ride a bicycle with basic, clear principles. This simplicity helps beginners start coding without being overwhelmed. Java uses object-oriented programming, also known as OOP, which offers a structured and modular approach to coding. It's like having a blueprint for a house, and once you have it, you can build many houses, so many objects, with different properties, enhancing code reusability and development efficiency. And if you don't understand these words, don't worry about them. We're going to go into them in depth throughout this course, so you're going to get a very good sense of them and will master them in no time. Another important point is that Java is platform independent. And that means that Java programs can run on any device with a JVM, which stands for Java Virtual Machine, making it a WORA, or a Write Once, Run Anywhere language. It's like using a USB drive with a presentation file that works on any computer, regardless of the operating system, if it's a Mac, a Linux, or a Windows PC. And the next point is that it's secure. So Java provides robust security features, including automatic memory management, exception handling, and access control. These features help create secure applications, protecting them from threats like viruses and hacking. much like features in online banking protecting financial data. In order to use Java and to have an as easy as possible start into using Java, we're going to use JDoodle. And JDoodle is an online work environment that allows you to write and test Java code directly in your web browser. This is particularly useful for beginners who want to start learning Java without having to install any software on their computers. And here are some key features and benefits of JDoodle. The first one being that there is no installation required. You can start coding immediately without needing to install Java or any work environment on your computer. Just visit the JDoodle website and you're ready to go. And we're going to do that in the next video. And then the second one is that it is user-friendly with its interface. So the interface is simple and easy to navigate, making it ideal for beginners. You have a text editor where you write your code and buttons to compile and run your program. And then you also have instant feedback. So after writing your code, you can compile and run it with a single click. The output is displayed directly on the screen, allowing you to see the results of your code immediately. And then the next one being that it's free to use. So JDoodle offers a free tier that is sufficient for most beginner programming tasks. There are also paid options for more advanced features if you need them in the future, but for our purposes, this will be good enough. Now, obviously, we're also going to use some proper coding software later on, which is called an IDE, but more on that later. So let's jump over to JDoodle in the next video and write our first code. Welcome back. In this video, we're going to look into JDoodle in order to understand what we're going to use in the next videos. So in the next few videos, I think until the day after tomorrow, so until day 3, we are going to use the Java compiler directly in your web browser. The cool thing is you don't have to install any software in order to get started. And that's what I wanted to happen, because sometimes getting started and then running into any kind of installation problems is really annoying. And I wanted to make it as easy as possible for you. So go to this website, jdoodle.com/online-java-compiler. Okay, so this is the URL that you can find up here. You can also Google for it and you will find it. And you will find this Java icon up here and it says Online Java Compiler IDE. I'm going to go deeper into what an IDE is later on once we are installing an IDE, but just spoken out, it means Integrated Development Environment, which just means that this is a software that allows you to code and makes it easier for you to code. Okay, so once you're on this website, you will see that there is a predefined code already, as well as there is this JDroid AI, which we are not going to use because it is only with 5 credits to start with. And I want you to use this tool for free, and 5 credits is fine. But once you want to use it properly, you would have to pay. And I don't want you to have any paid software to get started with. So I'm going to close the JDroid AI. And if you want to reopen it, you can just click here. Okay, so the next thing that I want to do is to zoom in because the code is way too small. And while I could just scroll in and zoom in to make the text bigger, that's a way to do it. But we could also change our settings. Okay, so I'm just gonna say, got it. I understand that this website uses cookies. And then what I want to go into are the IDE settings. Now you can only change your settings once you are signed in. So you need to sign in or create an account here and log in into JDoodle in order to change your settings. In order to run the code, however, you can see you can run it without registering. So there is an error because I accidentally entered an A, but if I have no error in my code and I run it, you can see that it does something. Okay, there's this play button, and we're going to go into what this play button does in a second. So again, if you don't want to register, it's fine. I personally like to have more capabilities, such as making some settings and saving the file and so forth. So I'm just going to log in real quick. Once I'm signed in, I can go to the settings and change the font size because, as I said, I think it's a little too small. Let's test 18. And I think 18 is significantly more readable. So now we can actually read what's going on here. And it's just the width of the text to fit still into the screen, which I like. All right. So there is some green text and there are some purple pieces of text, as well as some black and some blue and red, and all of that has a certain meaning in coding. And we're going to go over that later on. But for now, what you can read through is what you can see up here. And these are some instructions, and they are green, and green usually means that it's a comment. So here we're talking about a comment that will not have an impact on our program. Okay, it's just for us as a programmer to read it. We're going to go over comments a little more later on. But what it says is that you can execute code in 88 languages on this tool, and we are currently in the Java IDE. So we can click this orange button to execute the code, this one here, in order to check whether the code works. And I would recommend that you try that to see if you get an output here where it says sum of x plus y equals 35. And it's because 10 plus 25 is 35. So you don't need to understand the code down here. We're going to start a lot earlier or a lot simpler. Okay. As it also says, try the menu buttons on the left, save your file, share code with friends, open your saved projects, and so forth. Or you can even change the language. So what I'm going to do is I'm going to get rid of the code up here, just comment. And I'm also going to get rid of everything up to this point here. And everything that is inside of these curly brackets is what I'm going to focus on. Okay, I'm going to go over what these keywords mean and what they do later on. But for now, I just want to focus on what we're going to put inside of these curly brackets, because that's going to be the code that we currently can impact and that we can change in order to execute something that we have control over. Okay, and what we're going to start with is going to be a very simple statement, and that is to display something on the screen that we just have seen as well with the default code that we had there. But before we go into that, let's have a quick overview of what we are going to try to build. And that will be a little presentation in the next video. So see you there. Welcome to the presentation where we're going to go over what we want to do next and what we want to build as our first little project. And in order to see that our project works, we are going to display something. And how can we display text on the screen? Well, in Java, you can show text on your screen using system.out.println. And this is a command that displays the text you give it and then moves to a new line. And here's a simple example. So system.out.println, and then within your parentheses and double quotes, you can enclose the text that you want to display. So the system.out.println is a special instruction in Java that tells the computer to show something on the console or on the screen. So these parentheses, they are important because you need to enclose the text that you want to show on the screen inside these parentheses. But you also need to use double quotes. So you start with a quote sign, then you enter the text that you want to display, and you end with a quote sign, and then you close with parentheses again. Now, what's also really important in Java, as well as in most other programming languages, is this semicolon. So this semicolon ends the instruction. So when you write system.out.println, opening brackets, quotation, hello, comma, world, exclamation mark, quotes, parentheses, semicolon, the computer will show hello world on the screen and then move to the next line. Another example, if you want to, for example, display good morning, you would do exactly the same statement, except for what you put inside of your parentheses and within the quotes. So here it would be good morning. And what's really important is also not to forget the exclamation mark. So what's going on here is that we are using syntax. And syntax is like a special set of rules for writing instructions that the computer can understand. Just like how you follow rules when writing sentences in English. There are certain rules that you need to follow in order for other people to be able to understand you well. And that's the same with coding, but you need to be very specific because the computer only understands a specific way of you telling it your instructions. Okay? So, in summary, to display any text in Java, use the system.out.println command. Put your text inside the double quotes with parentheses and end the instruction with a semicolon. And this is an absolutely fundamental part of Java syntax. So let's go ahead and try exactly that in our JDoodle application in the web browser. So see you in the next video. All right, so now let's actually use what we just learned and write the code out. And the first thing that I'm going to do, however, is I'm going to make the text even bigger, because now I'm not as wide in a sense that I don't have all of the comments that I had before. And I'm also going to turn on the dark mode because I really like it not being so bright. You see the colors change a little bit, but I don't think it's a big problem. We can even go further also with the font size. Well, 25 seems to be the biggest font size that I can select, but that's good enough, I think. So as I said earlier, we need to add our code within those curly brackets. Okay. So that means in my case, in line 5, and obviously I could get rid of the first 2 lines as well. I could really put it into the 3rd line here. Now you see that I'm using an indentation here, using the tab button in order to make the code a little more readable. You can see that there are indentations here. There are actually 2 indentations here, and that is based on how this IDE works. But in the other IDE that we're going to use, we're going to have 1 indentation button click will be enough. So 1 tab button click, you can try it out. But what I'm going to focus on now is to actually print something on the screen. So let's get started by using system.out.println and then parentheses, quotations. And you can see that when I open my bracket, my parentheses, I get the closing bracket straight away as well. The same goes for the quote. So you can see the IDE, so this software is taking care of that part for me. I don't have to type it out manually myself. And then I'm entering the text that I want to display. So I'm going to say hello, world, and exclamation mark. Now, one important thing that I mustn't forget, as I said, is this semicolon here at the end. If I don't have that, I'm going to run into problems. Okay, so it's really important to have that semicolon here, otherwise my code would not work. And we're going to try out a few errors that we can run into in the next videos. But let's now click on this run button here, this play button at the top, and that will then execute my code. And it says hello, world. So it says output. So what we just did is we created a software that displayed something on the screen. Now, in this case, it's really just the output that is displayed inside of this little console, inside of this area right here. But it is where we're going to do most of our work because we don't have the visual features yet in the sense of a graphical user interface, which means something where we can drag stuff around or press buttons or anything like that. That is something that we're going to build later on. But for now, we're always going to just use the output from our console in order to understand the basics of the Java programming language. And that is just a common approach in learning it, because all of the cooler looking stuff would take way too long to understand and would make it significantly more complicated. Now you can see that in this input output, there are a few things that you can change. So one being the JDK, so the Java Development Kit. And you can see that there are a few versions that we can select in order to run our code. And once the latest version will come out, which will be JDK 2020 0.0, which should come out, I think, in a month or so. But I still decided to record this course already because there's not really that much of a change with every single new version coming out, at least not for the basics. Okay, we're still talking about the absolute basics, and only when we are getting to the more advanced topics later on, that's when new versions introduce new features that might actually have an impact on parts of the course. So no matter what version you will see here, what we're going to learn in the first, I would say 15 days or so, even longer, will have no changes required whatsoever. Okay, so this course will still be up to date in that regard. Okay, so then I have this input arguments that would go way too far at this point, and this stdin inputs, I would say this is way too much for the current point of your experience with the Java programming language. What you really should focus on is just what we just did here. And this was our system.out.println or print line. This ln stands for line, so it's a short version. So print a line saying hello world, and then a semicolon, and then it executes whatever comes after. So if I were to copy this line here and now paste it underneath here, then it would say hello world once again. So let me change that, and let me click on not now. So if I changed world to my name, and you should try the same, hello Dennis, and I run it, JDoodle executes it, and it says hello world, and then it says hello Dennis. And I'm going to say hello student. Okay, and let me run it again, and we will see it says hello student. Now, what's really important is that we don't forget the semicolon at the end, and that we follow the syntax, that it is written exactly the same as it is here. Now, in the next video, I'm going to go a little more into what all of this other code is, but in order to understand these keywords that we're using here, you need to go a lot further into the course, and we're going to go into what classes are and so forth after roughly 2 weeks of this course. So for day 14 or 13, something like that. Okay, so thanks for watching and see you in the next video. All right, so in this video, we're going to go over everything that we haven't built ourselves. So everything except for those 2 lines. Well, we're going to look into the hello world line as well, but what we want to focus on are these lines here, as well as these closing brackets. And what's important is that you don't need to fully understand all of that at this point. We're going to go into it step by step, and it will make a lot more sense once we looked into what methods are, once we looked into what classes are, into what access modifiers are, also what parameters and return types are, because that's what is going on in the screen. There are a lot of keywords that you don't need to understand right now, but in case you still want to know what's going on and to get a general idea as to what this code does, let's look into it, okay? So therefore, I have this little presentation where we're going to break down what's going on. So the sample code that appeared when we opened the JDoodle page was a little overwhelming at first, right? And we'll now go over each of these pieces. Now, think of a class as a big box where we keep our instructions. It's like the robot's instruction manual. We give this box a name like my class. Now, this is not an exact explanation of what a class is. We're going to go into classes a lot more, and they have more capabilities than what I just said. But in this particular context, let's just keep it at that. Now we have this thing called the main method. So inside of our big box, our class, we have a specific place where the robot, so the computer, starts reading the instructions. And this place is called the main method, like the first page on the instruction manual. Now, this is the code that we had at the end, except for that we had another system out print line statement. But overall, you can see that we have public class my class, then we have public static void main with a string and args. And now let's look at what those do. So if we break this down, we can see that in the first line, we have public class my class, and public just means that anyone can see this. It indicates that this part of the code can be used by anyone. Now, who is anyone and how can they use it? That's something for later. And this class keyword is used to define a new class. Okay, so we're just defining it by using this class keyword. Now, this my class name that you can see here, this is the my class name, is something that was defined for us or can be defined by us. And this is just the name of the class. And then you have these curly brackets that start here and they end down here. So everything inside of these curly brackets is part of the class. Now, if we look at the main method, which is this whole part here, all right, and the content of the main method as well, we have again this public keyword. So it's public static void main in parentheses string. Then we have these squared brackets, args, and again, closing parentheses. And then we have these curly brackets again. So here, public, that means that anyone can see this. So any other class could use this method. So we don't have more classes yet, so don't worry about that. Then we have the static keyword, and this just means that this method belongs to the class and not to any specific object of the class. Now, what that means is also way beyond the starting point of this course, so don't worry about that either. It's just another keyword that we need to use in this context because otherwise our program wouldn't work. And then we have this void keyword, which just means that this method does not return any value. And you can think of methods like something where you can have an input, then something inside of this method happens, and then this method can return an output. And we're going to build our own really powerful methods later on, but for now, it's not something we need to consider. And then we have this main keyword, and this name is the name of the method. Now, the main method is the starting point or the entry point of any Java program. And in this case, it's just the name of the method. So of this box where you can have an input and an output, right? So the input is what is inside of these parentheses. And here we have a string and squared brackets, which just means that this is an array. So this is used for the command line arguments, and it allows the method to receive strings as parameters. So we can give it an input. And if we look at our IDE and we run it, you can see that you can have input arguments. So this is where this thing comes in. So here we could enter something that would then be considered from here or for here. Okay, so we could put or add an input, so to speak. But again, don't worry if it goes over your head. And then we have the curly braces again. So we open curly braces and close curly braces, and everything that is inside of these curly braces is part of our main method. So the content of the main method, so the code that will be executed in the moment that the main method is called. So the main method is called at the moment when we run our program. Okay. And then we have our print commands, and we use this predefined code called system.out.println, and then within parentheses and quotations, that's where we have our hello world. So this is a predefined command that we can use in order to print something onto the console. And the text that we want to display is inside of these parentheses as well as these quotations. And we need to make sure that we end this whole statement with the semicolon. So this is the end of the instruction. We're saying, okay, for this line, the instruction is over. There is no more instruction for this particular line. We can add more instructions by adding another line, which we did in our little project here, right? So we added another line. Okay, so by following these steps, you can understand the basic structure of a Java program and how to display text on the screen. And with that, I would say, let's go over to the next video where we're going to introduce a few errors that we're going to implement so that we can see how we can get around solving errors if we ever run into them. Now, at this point, obviously, it will not be an in-depth instruction into how to use debugging or how to use error handling, but it will still give you an idea as to which kind of errors you can run into very commonly. Okay, so see you in the next video. So in this video, we're going to look into common errors. Okay, so common printing errors specifically. And let's start with the first one being misspelling system out print line. So the error could be that we write something like system without E, and then we would run into an error. So let's try this out. Let's go over to our program here. And by accident, we forget, for example, this E here. And then we try to execute that. And once we run it, we will get an error. So it says my class Java 3 error package system does not exist. System out print line hello world. So it says in line 3 basically. So this is what this 3 means here. In line 3 we have an error, and it says that this package called systm does not exist. So what we're trying to access with system is a package. All right, good to know, right? So this is where we have our first error. So this is a misspelling error that we could run into, or we could by accident not have ln here, but just n. So we get an other error here. It will say also in line 3, my class Java 3 error can't find symbol system out print n hello world. So it couldn't find the symbol method called print n string. So location variable out of type print stream. Well, quite complicated, whatever it says here. And we're going to go into how we can find a solution to errors. But in this video, I just want to show you those errors, okay? In order to see how we can fix those, we're going to go over into a different video. Okay, so that's misspelling errors. Let's go over to forgetting the semicolon. Let's try that out. So let's say we forget the semicolon here at the end. So this statement isn't finished. So this instruction isn't finished at this point. And we get this error called error semicolon expected system out println. And it says here, this is where this little arrow indicates that it's expecting a semicolon. Okay, that's quite an easy one, all right? So we know, okay, we need to finish our statement with a semicolon. Now, another error we can run into is to have a mismatched parentheses or quotes error. So let's try that out. For example, let's say we forget our second quote. You can already see that the string here, well, you don't know what a string yet is, but you can see that this text here suddenly isn't yellow anymore or this green or yellow, but it's this vanilla color, okay? So if you run it, it will say my class Java 3 error unclosed string literal. So what is a string literal? Well, we're going to go into that as well. So it just says, okay, in this, it started here. So this is where the quotation started, but then it never finished or it never closed. So that's another common error that we can run into. And these errors, they can happen quite often, right? So this is not something that will only happen in this very simple example. It's very likely that it will happen in more complex examples. But the good thing is that the IDEs that we're going to use later, so the software that we're going to use later, will let us know about this error while we are coding. So it's really, really useful and powerful, but especially for you as an absolute beginner, I think it's still very good to see it without all of this assistance. Okay, let's fix it back to the state where it worked, and we will see hello world works. Beautiful. So then incorrect main method declaration. And let's say we get rid of these squared brackets here. Then we're going to run into another error, main method not found in class my class. Please define the main method as, and it even says this is how the main method should look like. And interestingly enough, you see in my presentation, I had this way of writing it. So string, curly brackets, args. But in JDoodle, you could see it was written like this and it worked as well. So either way is fine, but just for you to be aware that it's not an error on my part with the presentation that we had earlier. Now let's look at case sensitivity. So Java is case sensitive when you are working with the code itself, not with, for example, your string literal. So the content that yet we are passing inside of the quotations and parentheses. So let's generate that error by, for example, writing system with a lower s. Okay, so if we do that, we get another error where it says error package system does not exist. So again, a package error. So if you don't have the right name for this package, we're going to run into a package error here. So let's fix that. And then finally, misplacing or missing braces. So the braces, they're really important. They're opening a section and they're closing a section. So if we don't have, for example, the right amount of brackets, so here we don't have a closing bracket for my class in this case, even though it looks like we don't have a closing bracket for the main method, it will not execute correctly either. We're going to run into an error. It says on line 6, error reached end of file while parsing. And this indicates that there is something missing. So while parsing, so while trying to execute the code, it ran into an error. And that's because we don't have these closing curly brackets. So I just wanted to show you the most common errors that we can run into in this very simple example. And in the next video, we're going to look into how to fix those. By the way, if you have too many of those curly brackets, you will run into an error as well. So here it says my class Java 6 error class interface enum or record expected closing curly bracket. Okay, so yeah, something wrong here as well. Anyways, that's it for this video. Now you have a few ideas as to the errors that you can run into, and that's it for this video. See you in the next one. All right, now that we know how to generate errors, let's have a look at how we can search for the specific errors that we are creating, and let's search for a solution. Because if we have no experience and no idea what these errors mean, we just need some help, right? And there are amazing tools out there. And one of the best tools that just recently came out is any Gen AI. So you could take ChatGPT, you could take Copilot, you could take any Gen AI that you prefer, okay? So let's look at how this works. So you need to copy the error message when it appears. Then You can ask ChatGPT for help. So for example, you can just paste that error message in ChatGPT for assistance and tell it, I'm trying to write some code. This is my code. This is the error that I'm getting. And then once ChatGPT gives you a solution, or any other Gen AI, such as Copilot or Gemini or Claude or whatever you're using, you should try to understand the solution as well as the error, okay? Because once you understand it, this will help you to avoid it in the future. And then you need to implement the solution. So whatever Gen AI gave you a solution, take that, apply that to your code. So change your code accordingly. And once you've done that, verify that the fix actually works. So run your program again to ensure that the error is fixed. So let's try that. All right, let's go over and let's just create an error by getting rid of, let's say, using non-capitalized S here, system out println. Let's run it. Let's get this error like so. Let's copy it. So right click, copy, and then let's go over to, for example, in my case, Bing. So I'm going to Bing because I can use the Copilot without having to register. That's pretty much the only reason. Otherwise, I would use ChatGPT or Max AI or any other tool that I prefer for Gen AI. So you can just go ahead. I'm learning to code Java, and along the way, I ran into this error. Please explain it to me and help me fix it. Okay, so then within a few seconds, I should get a result. So it says, certainly, let's break down the error message and find a solution. So the error message you're encountering is package system does not exist. This occurs when you try to use system out println hello world in your Java code. Here's what's happening. So it says capitalization matters, and we saw that, right? So it's basically because we haven't used system with a capital S. So in Java, class names, including packages, are case sensitive. When you write system out println, the compiler interprets it as an attempt to access a package named system with a lowercase s. However, what you actually want is to use the system class with an uppercase s from the java.lang package. So while I agree with the answer, as a beginner, I think that these words that it's using are very hard to understand. Okay, so what we can do is we can say, explain it again, but please as if I'm 13 years old. Okay, and then it goes again. Okay, so it tries to make it more simple. And also, whenever you come across a word that you don't understand, so for example, it says packages. What are packages, right? We have not seen any packages yet. Or when you are looking at compiler interprets, what does that mean? Well, basically, let's go ahead and just use that. Please explain what compiler interprets means in simple words. Okay, and then it just goes ahead and gives me a really good answer. So first of all, a compiler. So imagine a translator who takes a whole book written in one language and converts it into another language. A compiler does something similar for computer programs. It takes the entire program you wrote in a high-level language like Java. You see, Java is a high-level language, and translates it all at once into a special code that computers understand, like zeros and ones. So it's like translating the whole book before you read it. And then interpreter. So now think of an interpreter as a language guide who travels with you. When you read a sentence, the guide translates it for you right away. Similarly, an interpreter translates your program line by line as it runs. So it doesn't need to read the whole book up front. It helps you understand each sentence as you go. Okay, so I would really recommend that you use this approach in order to get a better understanding of given words that are used that you don't understand. Because sometimes you think you understand it, but you're not sure, then I would recommend using it. Okay, so what's the solution here? So it explains what the package is, it explains what system tool is, capital letters matter, that's good. Fixing the code. We should write system out println hello world. Okay, so let's copy this code. Let's go over to our project here and we can paste it in here So let me replace it here. Let's run it again, and we will see that we have a solution. Okay, so it works again. Our code works in this case. Now, coming back to using GenAI, I would really recommend going over, well, using this technique, for example, please explain me like I'm 13 or like I'm 9 or something like that. Then it will give you a really significantly better idea. So let's look at packages. Imagine you're organizing your toys. You have different types of toys like cars, dolls, and building blocks. In Java, we also organize things into groups called packages. Each package contains related stuff. For example, the Java Lang package is like a special box that holds some basic tools we can use in our Java programs. So the systems tool, okay, so if we look at the code just real quick, okay, let me just jump to the code here. So we don't see that system is part of the Java Lang package. That's due to the IDE that we're using. Once we're using a proper IDE, we will be able to see that a lot easier. But coming back, we can see that the system tool is inside of Java Lang, inside of this package. There's a special tool called system. It's like a magic wand that can do cool things. One of its tricks is to help us show messages on the screen. When we want to say something in our program, we use this tool. All right, so that's cool. Good to know that system contains this information. System contains a lot more, but as a beginner, that's really good to understand that the system tool helps us to say something on the screen or display something on the screen. And then, well, capital letters matter. We got that. And then it says how to fix the code. This way, we're using the right magic wand system tool to show our message, hello world. So without using the capital S, it doesn't know that we want to use this magic wand system. It just doesn't know this underscore S system. And that's why we run into this error. Okay, so what's also really important is that whenever you're using GenAI, don't just copy and paste mindlessly. It's really important that you understand what you're doing, because while it might write code for you very quickly, it can also lead to a bunch of errors or problems along the road where debugging, so basically making sure that the code works properly, will take longer than writing the code yourself. Now, obviously, at the beginner, it might not be the case, but once you get a little bit of experience, that will be the case. Okay, so that's it for this video, I'd say, and see you in the next video. So in the first presentation about Java, I didn't go too much into the features that it has. So I just gave you a general idea. And in this video, I want to go a little deeper and show you some additional features that are really useful about Java. So number one is that Java is open source, meaning it is free to use. So developers can use this free platform to create apps, encouraging widespread use and collaboration. It is fully documented, so Java's extensive documentation provides step-by-step guides and solutions to common problems, helping developers understand and use the language effectively. And documentation is basically just an explanation of how things work and how the code works and how the general structure of the code is supposed to be and how it is built. And this is really key because especially when you are working with some new programming language, sometimes the programming language isn't as fully documented. And when you are building something unique or new, you might run into problems. Then another one is versatility. So Java is versatile and can be used across various domains, including web development, mobile applications, enterprise solutions, cloud computing, and IoT, or Internet of Things. And there is strong community support. So Java has an active and supportive community, making it easy to find help, share your knowledge, and solve problems together. And the thing about a strong community is also that these courses exist. Because in programming languages that don't have such a strong community, there might not even be good tutorials out there. And this is really difficult to get started with then. But that's not the case with Java. So Java has been around for a while. It is extensively used by so many different people, by millions of people actually. And that makes it such a great programming language to learn. And congratulations for deciding to learn programming. Okay, so that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at print as well as escape sequences. So let's look at the print first. So we have this print line, hello world, but there is another way of writing something onto the console. So I'm going to copy this line and I'm going to get rid of this ln. So there is this print method. So this println is also a method. So this print method is a way of displaying something on the console. So giving it as an output. So basically writing the text out. So if we do that, let's just quickly run it and see what's going to happen. And what you will find is that it says hello world. And then in a new line, it says hello world again. But what if both of them were just a print statement and not a printed line statement? So let me run that again. And we will see that it says hello world, hello world. So one after the other. So what is the difference between print line and print? Well, print line generates a line break. So it basically creates a line break after its text. But does it also create a line break before its text? Let's try it out. So let me put another print line statement in between and let's run it. And you will see that it says hello world and then again hello world, and then it generates this line break. So that's what this ln stands for. It creates a new line, so to speak. So you see that this text was just written out. This println was also just written out. And afterwards, there was this line break. And then this piece of code was written out or executed. So this hello world was written out. So this print is just another way of displaying something onto the console without this line break. How can we create a line break inside of a given statement? Because sometimes we have a longer text and maybe we don't want to use a separate print line statement each time. Well, therefore, we can use something called an escape sequence. Okay, an escape sequence is backslash and then a character. So for example, n. So with backslash n, I'm creating a new line. So a line break. It's like pressing the enter key when you're writing in your text editor. Okay, so what this will now do is it will say hello, comma, empty space, new line. So there will be a line break, empty space, world. So let's run it and we will see that it says hello, comma, then there's actually an empty space here. You can see that once you hover like this, you can see there's one empty space. And then before this world, there's also an empty space. All right. And it's a line break, obviously. So this is what this backslash n does for us. So what is going on here? Well, as I said, we have an escape character. Escape character or escape sequence is the name here. Sequence with backslash n. Now, what is going on with this gray text that I created here? Well, this is a single line comment. So with this double forward slash, I'm creating a comment. This comment is for me as a coder to understand the code better. So I can document my code this way or make it more obvious as to what is happening inside of my code. So this is very useful if you're working together with other people or just for yourself once you come back to your code after a while, and it's significantly easier if you have these documentations or these comments to understand what's going on in your code. Now, with this simple code, it's not that complicated, right? But once you have big projects, it's a very different story and you're happy about every comment that you wrote. So let's write this, run this again, and you will see that the statement that I added here, this grayed out statement, is not considered in the output. So this line 3 is actually not going to be executed or interpreted by our compiler. And we saw what a compiler and interpretation is in one of the other videos, basically saying that our program will not execute this line of code. This will not be considered as part of the code base. It's really just for us inside of the code file as a developer when we are editing the code to see what's going on. Okay, so now you learned a few things. You saw print line versus print. You saw the escape sequence with backslash n, which generates a new line. And I would say that's good enough for this video. Well, maybe you can actually try one more thing, and that is to have another print statement here. And I'm adding the tabs in here. So let's say we have a hello world, and then we have another text here, welcome, for example. So let's run this and we will see that it says hello world, and this welcome comes straight after. So there's no empty space, no line break, no nothing. And that's what this print does for us. Okay, so print just prints it at the next possible character spot, so to speak. All right, so that's it for this video. See you in the next one. In this video, I want to show you basic math and numbers with print statements, okay? So let's go ahead and use a bunch of print line statements each time. So I'm going to use print ln, and I'm going to get rid of the content here. And when we are working with numbers, we don't have to use the quotations. So for example, I can use this statement here saying number, okay? So here I'm going to create another line where I'm going to display a number, and I'm not going to use those quotes. So let's say I'm using 42 as a number. So let me run that, and you will see that it says number, and then in the next line it says 42. So this 42 is internally not considered as a string, so as a text, but it is considered as an integer, so as a number. And this leads into having different data types in programming. We're going to look into data types in the next day, I think, tomorrow, and it's going to be very important. But for now, I just wanted to show you very basic math that you can do inside of your little compiler IDE here in the browser. So I have 42, right? Now I can also do some basic math here. So let's say I want to do addition. I can do that here. I can say 2 plus 3, for example. And if I execute this, it will display 5. So it will not display 2 plus 3 because this is not a string, as I said, right? These are numbers. So if I were to make them a string, like so, now it's a string, a literal, so a text. Now it will just say 2 plus 3. So addition, 2 plus 3. So it doesn't do the actual addition. So in order to actually do the addition, I need to get rid of those quotations, because now this is considered a mathematical operation. It does the mathematical operation and it prints the statement in a new line, because we already had a ln here. So basically there's a line break after this piece of code, and then it displays whatever the result of 2 plus 3 is. Now I can go ahead and do the same thing again with, let's say, subtraction. And I can say, for example, 5 minus 2. So this would do the trick with subtraction. We can just run it and it will display 3. So 5 minus 2 is 3. Now the same works also for multiplication. So 2 times 3 would be 6, for example, and obviously also for division. So multiplication here. And now let me add another one. This one will be division. And in order to do division, we use the slash sign. So 2 divided by 3 is probably not such a good option here, because this will result in 0. Now, I don't want to go too deep into this because we aren't at the point yet where we're looking at data types, but this will be something we are going to dive deeper into. Obviously, if I take whole numbers that can be divided by themselves with resulting in a natural whole number, then it works obviously, and it will display 2 correctly here. Okay, but more on that tomorrow. So it's really important that you keep going, that you learn more, and I hope you enjoyed it so far. Please let me know in the Q&A. And with that, I'd say see you in the next video. And that wraps up our first day. Today you learned the basics of Java, wrote your first Hello World program, and got familiar with JDoodle. We also covered how to fix common errors, and you got a taste of Java's basic print functions and math operations. Tomorrow we will dive into variables and data types, which are the core building blocks of any programming language. You will learn how to store and manipulate data in Java. All right, it will be a great day, so see you tomorrow. Welcome back. Today, we'll be focusing on variables and data types, the core building blocks of any program. First, we'll explore what variables are and how to name them properly. Then we'll dive into data types, both primitive and non-primitive, and why selecting the right type is crucial for your program's performance. We will also touch on type conversion, transforming one data type into another. After that, we'll work through a hands-on exercise involving numbers and shapes, and wrap up with a quick quiz to review the day's material. By the end, you will know how to use variables effectively in Java and choose the right data types for your needs. So let's get started. All right, so today we're going to look into data types and variables, and therefore we need to understand what variables are and understand what different data types there are and what they are. So let's get started. All right, so first of all, what is a variable? A variable is a container for storing data values, and you can think of it as a box where you can put information such as a number or a character. And in Java, each variable must be declared with a data type that defines the kind of data it can hold. In order to declare a variable, you need to specify the data type followed by the variable name. This tells Java to set aside a portion of memory to store the value of that data type. So for example, int my number. And then we have a semicolon in order to finish the statement. With this, we are creating a variable with the data type int, and the name of it is my number. So this is a very simple declaration of a variable. That's again the name of what's going on here. Now you can initialize variables as well. So by initializing, I mean a start value. So assigning a start value that will be inside of that spot in the memory, so inside of the variable, for later usage. Initialization is a process of assigning a value to a variable for the first time. So if you assign a different value later on, that's not called initialization anymore. So in this case, we could say int my number equals 10 semicolon. And here we are declaring and initializing the variable in the same line. However, in the line after, with, for example, my number equals 20 semicolon, we are reassigning a value. So here we're not declaring and neither initializing, but we're just assigning a different value to that variable called my number. And don't worry about it, we're going to go deeper into this with a bunch of different variables, bunch of different data types. So if that is a little too much to wrap your head around straight away, don't worry about it. We are going to have plenty of time to get a feel for it. Now there is something that you need to consider as well, and that is how you name your variables. So why is it so important to name your variables accordingly or properly? Well, naming your variables clearly and consistently is important because it makes your code easier to read and understand. Good variable names help you and other developers understand what the variable is used for without needing to look at the rest of the code. There are some rules for naming variables, and these rules are dependent on the programming language that you're working with. So in Java, the specific rules for naming variables are, and in Java that is that we start with a letter, a $sign or an underscore sign. So they must begin with a letter A to Z, a $sign or an underscore, and they cannot start with a number. Variable names are case sensitive. So that means that my variable with a capital V is going to be a different variable than my variable without the capital V, just with a lowercase v. So they will be different. That's really important to understand. So then there are no spaces or special characters allowed in variable names. The only accepted special characters are the $sign and the underscore, as stated in rule number 1. And you mustn't use Java keywords. So you cannot use int, class, public, and so forth as variable names, as they are predefined in Java already as having a special role to play. So that's something you need to consider, and you might wonder, okay, I don't know all of these keywords yet. How do I know if I can use it or not? Well, that's where the IDE, so the software, the tool that we're going to use in order to develop, is really going to be very handy, and it will help you out with that. So best practices are to be descriptive, using names that clearly describe the variable's purpose. For example, H is better than the name of A, whatever A could be later on. If you want to store the age of someone, just call the variable H. The second rule is to use camel case. So start with a lowercase letter and capitalize the first letter of each subsequent word. So we had this earlier with my number. My was written with a lowercase m, and number was starting with an uppercase N. And the third rule is to keep it short and readable. So variable names should be concise, but they should be descriptive. However, we should avoid overly long names that are too descriptive sometimes. Now, some common mistakes with names in Java would be to start with a number, because identifiers cannot begin with a digit. They must start with a letter, underscore, or $sign, right? Then using spaces. So you cannot use spaces. You need to use camel case or underscores instead. Okay, so underscores are okay inside of the name of a variable as well. And some companies even use that, but usually you just use the default camel case. And then the third mistake that people make, especially beginners, are that they use special characters, except for obviously the $sign and the underscore. Variable names or identifiers, which is just a different way to say variable name, cannot include special characters like the hashtag sign or @ sign or percentage sign, right? So that's pretty much it, what we need to consider for variable naming. Now we're going to look into data types later on, but for now we're good to go. So see you in the next video. Welcome back. In this video, we're going to use JDoodle again, and we're going to use it in order to get a feeling for declaring and initializing variables. So these might be two words that you're usually not using, so let's use them. So the first thing that I'm going to do is I'm going to create a variable of type int. So you can see here that int is directly turning green in the IDE that I'm using here, which indicates that it is a Java specific word. Okay, so I cannot use my variable int, as you can see here. I could use it int2 or int name or something like that, but I cannot just use it int. And then I am giving this int variable a name. So the variable of type int, I'm giving it a name, which could be, for example, age. So age is the name of this variable. And with this, I am declaring. So I need to add the semicolon here. With this, I'm declaring the variable age of type int. So it has the name and it has the type. Now I can also assign a value straight away, or I can assign a value later. So I could assign a value like this, for example. I'm 36, so I could assign a value like this. So now let me show you how we can declare a variable and initialize the variable. And that is by using int, and here, for example, weight. And here I'm going to directly assign a value, and that is 74. Because I'm 74 kilograms heavy, I'm going to add the weight as 74. And I'm using the semicolon again. So what I'm doing with this equal sign here is I'm saying that this is the value that I want to assign at the memory slot that is declared with the name of weight. So inside of the memory of our machine, in this case of my PC, there will be a little slot which will contain the variable name, weight, and it will contain the value that I'm assigning to it. And it will be of the type that I'm declaring here. So in this line here, what I'm doing is I'm declaring and initializing the variable all at once within the same line. Okay, so again, declaring a variable, and here assigning a value, and here I am declaring and initializing. Now you might wonder, what is all of this stuff here? Well, these are comments. So they are single line comments. So this comment is going to be only for this particular line. It will not be executed when the code is executed. So this will not impact our code at all. It's just for us as a visual cue or as a little help. And this makes us understand it better. Okay, what the code does, for example. So in this case, I'm not even using camel case, which is also fine. So this variable is descriptive enough with just the name of age. However, I could have called it my age. Okay, so my age, like so. And if I do that, obviously this here also needs to be called my age, because otherwise my code will crash. So here I'm going to use my age equals 36 as well. Okay. So this here is now camel case. It starts with a lower letter, and every single new word starts with an upper letter. I can do the same thing with my weight. So I'm going to do that right here. And suddenly I have camel case here as well. Okay. So there are other types of cases as well. For example, there's snake case. So int my weight, for example, would be snake case. Snake case is used in programming languages such as Python, for example, and camel case is used in Java, in C# and in other programming languages. Now, this is something that depends on some major rules that you might have at the company. So the naming conventions might be specific to the company that you're working for, but usually they just follow the default naming conventions of the programming language that is used. All right, so that's it for this video. See you in the next one. All right, so in the last video, we created a variable of the type int. So the data type was int, or an integer. Now I've prepared a little presentation here to give you a better idea about data types, okay? And we're going to have a bunch of exercises and also demos that will give you a better feeling for the different data types, because this is really the fundamentals that are necessary to get anything done in Java and in any programming language with that. So what are data types? Well, data types are fundamental concepts in programming. They specify the type of data that can be stored in a variable and the operations that can be performed on that data. Think of data types as a way to classify different types of information, such as numbers, characters, and true or false values. In Java, data types are divided into two main categories: primitive data types and reference data types. Now, primitive data types are the most basic data types available in Java. They are predefined by the language and named by a reserved keyword. We saw one of them already, and that was int. But you can see that there are plenty of data types like byte, short, int, long, float, double, char, boolean. So these here are primitive data types, and you don't need to worry about them too much at this point in the presentation. But just to give you a general idea, the data types, they can hold different types of data. Now you might say, we've seen int, but why do we need short or byte if int is already holding numbers? Well, the thing is, there are different data types that take different amounts of space in the memory. So a int, for example, takes 32-bit of data in your memory. A short only takes 16. A byte only takes 8. So if you want to build something that is really super performant and you know that a number will only hold a very small value, then you could always optimize the code with the right data type. Now, you see all of these data types, and we're going to use them in practice, also in the demos, and this will give you a significantly better feeling for them than just having them here on the screen. So you don't need to memorize it for now. We're going to use them a lot, and then you will get a feeling for it. It's just to give you a general idea that there are different data types that are the primitive data types. Some of them are for whole numbers, and it's byte for small whole numbers, short for medium-sized whole numbers, int for big whole numbers, and long for very long whole numbers, okay? And with whole numbers, I mean numbers that are not with a decimal point afterwards, so they don't have a floating point value. On the other hand, there are two floating point data types, and one of them is the float data type, which is great for small floating point values, and double, which is great for big or more in-depth floating point values. And then there's the char data type, which only holds one character. That's what this char is an abbreviation for. So char for character. And then we have booleans, which can be either true or false. So a boolean can only hold two values, either true or false. Now there are other data types as well, as I said earlier, and they are called reference data types. And they are there to reference objects. And examples would be classes, interfaces, and arrays. And then the one that is most simple out of those reference data types is string. And we're going to use strings quite often because they are rather simple. So out of the reference types that you see here, you don't need to understand those at this point of the course. However, string is something we're going to use in today's examples already. And we're going to go into a lot of depth with it because they are very important as they hold text, right? Classes, interfaces, and arrays are topics for later days when we are really feeling confident with the primitive data types and string, and also already know a lot more about programming in general. So how about we just go over to the next video and get a feeling for those different data types with a demo. See you there. Welcome back. In this video, we're going to look at the data types, specifically the whole numbers, and get a better feeling for them, and also understand what their range is, because range is something that you need to consider when you are writing optimized code, so to speak. And let's get started by just creating a very simple variable that will store the age. And in this case, I'm going to store the age of a human. And a human usually doesn't get older than, let's say, 127 years old. Why do I say 127? Because that's the limitation of byte. So let's look at this. All right, so there are these different data types that can hold whole numbers: byte, short, int, and long. Okay, we saw all of those in the presentation. Now, byte is the smallest one, and a byte is 8-bit. So 1 byte is 8 bits. And how many numbers or how much information can a byte store? Well, 8 bits of information. How much is 8 bits of information? Well, it's binary, right? So you have 8 digits in a binary number. So 8 slots, of which each individual slot can either be a 1 or a 0. So I don't know how well you learned binary at school, but to simplify it in this case, what we can do is we can just say 2 to the power of 8. What's that? That's 256. And then we divide that by 2, and then we know the limitations of a byte. So let me show you this in practice. So let's create a byte with the age, and let's assign a value of 128. Now 128 is half of 256. Okay, so let's run it, and we will run into an error because 256 divided by 2 is 128. But if you start counting at half of it negatively, and you go all the way to 128, you will have in total 257 numbers, because there is this magical number in between that is the 0. So if we consider the 0 as a number as well, then from minus 128 all the way to 128, so positive 128, you're going to have a total of 257 numbers. So why is this so important? Well, let's go over it step by step. So you can see that if I use 128, I'm running into an error where it says incompatible types. Possible lossy conversion from int to byte, where byte age equals 128. So if I were to use 127 as the age, I will not run into an error. My code will execute flawlessly, no errors, nothing. Okay? And that is because, well, let me just show you. Let's use the calculator here. 2 to the power of 8 is 256. Divided by 2 is 128. So how Java handles it is it says it goes from minus 128 all the way to plus 127. So I can assign a value of 127 and I can assign a value of 100 or minus 128 and any number in between. And that is for the byte data type. If I were to store minus 129, for example, then it would run into an error as well. So it again says incompatible types, possible lossy conversion. So we're going to see what a conversion is later on, and we're going to convert numbers ourselves into different data types. But this is just to give you an idea as to the limitations of, or the range of data types. Okay, so in this case, byte is great to use human ages, but it's not great to use the age of our planet, for example, or the age of a country. That is a limitation where byte as a data type would not be good to use because it can only store 256 values. Okay, so I'm going to enter my own age in here, 36. Now let's look at short. Okay, so short has 16-bit or requires 16-bit of storage. Now we can just go ahead and do the same calculation. Now, obviously, you can also look this up, right? But if you just take 2 to the power of 16, you will see it's 65,536. So if you divide that by 2, then you know that this is the maximum negative number that you can have, and the maximum positive number that you can have is one less. So it's 32,767 is what you can have as a limit for a short data type. So a good value for short would be the year. Okay, we are in the year of 2024 right now. And again, I need to finish the statement with a semicolon as I did here. So this number is totally fine. The short will not hit its limits with 2024. However, if you want your software to still work in 100,000 years, for example, this might not be a good idea to use a short as a data type because then it could not store anything past 32,767. We can try it out, right? So let's run the software with this number and we will see that there is no problem. Our code executes, no errors. Now let's use a number that is too big for a short and let's run it and we will run into an error. And it's the same error that we get. It says incompatible types, possible lossy conversion from int to short. So again, it says int, and that is because usually when you are using whole numbers, you are going to use int. That's just default by now. In the past, that wasn't the case because there was just not enough storage available. But nowadays we have such powerful machines that it doesn't really matter. So using this byte and short and all of that stuff is really not that much of an issue anymore because we just have too much memory. Or, well, we have so much that it doesn't really matter if you use an int or a short or a byte. An int will be good enough in terms of performance, right? So an int is 32 bits, and that means that we can have a very big number. So let's take 2 to the power of 32. And we can see we can go all the way to 2 billion as the value. So divided by 2, you can see 2,147,483,647 positive is how far we can go, and negatively we can go in the other way. So here again, the year we need to limit it. So with ints, we can go ahead and enter a very long int. Now let's take the population as a variable here. So population, and let's call this one population USA. And I don't know what the population is exactly. So let's say 330 million, for example, would be the population of the USA. And this number is fine. This will work. This will not crash our software. However, if we were to create a variable that is population world, then let's say it's 8 billion, we will run into limitations because this will now crash our code. If we run our program, we will see that we get an error at line 12 and not at line 11. So you see here, my class Java 12 error, integer number too large. So it even tells me what's going on. The integer number is too large. So what can I do about that? Well, I can use the final data type for long numbers in Java or big numbers in Java, and that is the long data type, and that's 64 bits. Now, if I take that, now there is one more thing that we need to do when we are using long as the data type, and that is that we enter L here at the end of the value. So this is 8 billion, and I need to add this L, which tells the compiler, so tells Java, so to speak, that we are talking about a long number. So now it will store a long data type number inside of our long data type variable called population world. So if we run this again, we will see that it will now work. So if I run this without the L at the end, I will run into an error. And it's interesting, the error that I'm getting is very interesting. So let's look over it and we will see it says integer number too large. But I called it long, right? Why is it not accepting my big number here? Well, that's because this number here by default is considered an integer number. So if it's that big, it's still considered as an integer number that cannot be stored inside of an integer, so it doesn't work. So it's a very weird error, but in order to get around it, you just need to use this L. And this L stands for long. So that's it for the whole number data types. In the next video, we're going to look at the floating point data types, and it will be a lot easier there. So see you in the next video. All right, so in this video, we're going to look at the other numbers, and that's the floating point numbers. Okay, so sometimes you just need more precision than just to have a whole number. Sometimes you need decimal points. And if you do, then there are two data types that you can use. One of them is float, and the other one is double. Float only requires 32 bits of storage space or memory space, and a double requires 64 bits. So let's look at those two in the demo. So first of all, what are those two? Well, it's float and double. All right. So these are the two data types for floating point numbers. So anything that has a dot and then another digit afterwards. Okay. So e.g. 3.1. So let's create a float here. So now when we enter float, we can see that it turns green as well, which means that this is a Java specific keyword and it is directly interpreted as that. So now let's say we want to store the temperature, and the temperature is 25.1 degrees Celsius, at least in my room right now. So this by itself would not work yet. And why is that? Well, let's quickly run it and see what we're gonna get. And it says incompatible types, possible lossy conversion from double to float temperature 25.1. So we saw that before, right? We saw that with the long and the int and so forth, where we tried to use a number that was not considered the type that we were using. So that is because whenever you are using the float data type, you need to add an f at the end of the value. So this f indicates that this number here is now a float. Okay, so because by default, that's just the case in Java, it would be considered a double. Even though we're saying that the type of our variable is of type float, internally, any floating point number that doesn't have an f is considered a double value. So we're trying to store a double value inside of a float variable, and that doesn't work. That's why we need this f in order to say that this is not a double value, but in fact a float value. Okay? Because so it's like with these children IQ test games with like 1-year-old or 2-year-old or whatever old they have to be in order to make these, well, very simple shape games where they either need to put they put the circle in the circle hole, or they put the square in the square hole, and so forth. And you have to consider that a float, for example, is the square hole and the double is the rounded hole. And us now trying to put the round item into a squared hole doesn't work. Okay, that's the general idea how you could consider this. So now if we are using double, which is a 64 bits data type, or a data type that requires as much space, and float requires 32 bits. Okay, so the double is simply a more precise float. So it can have more digits and it can store a bigger and more precise value basically. So you would use doubles for something like pi. All right, so if you want to store pi, then you would use that, and I think 256. I'm not sure. Wait a second. It's 265. Yeah. So that could be the extent of which you can store pi. So you would use a double for pi or anything that needs a certain precision. For example, if you're working with an interest rate and it needs to be very specific and very precise, that's important. Or if you have a bank account, then your bank account, for example, usually would be fine with a float. However, if you have a very big number on the front side, so before the dot, that can also be limiting on the float side. So let's just run this and see if we're getting an error here. Okay, and we see we don't get an error. Now, let's assume the temperature has risen dramatically. Okay, so now let's run it again and still no error. Let's make it even more dramatic. So I have a very long number here, as you can see. And if I run that, then it says the floating point number is too large, so float cannot store this long number. Okay, now if I were to take this same number and I tried to store it in my double, and I were to reduce the number for the float, we will see that it can be stored. So this just gives you an idea, okay? It just is a very big number that you can store inside of a double, okay? Good. So that's pretty much what this is all about. Usually you would just use double, all right? Floats are rarely used or not as often used. It obviously depends on the application. A float requires less space, so it makes sense to use floats in optimized applications, especially, for example, for physics in video games. You usually see them being floats because every bit of memory that is required by the graphics card in order to calculate the physics of a video game, or the RAM in order to calculate the physics of a video game, is going to be too much. The more you can save on that front, the better. That's why usually physics are stored in float values when doing game development. Okay. Okay, so I'd say this is enough of an introduction into float and double and the floating point numbers. And let's go over to the next topic, which is going to be char. So see you there. All right, welcome back. In this video, we're going to look at another data type, and that is char. So it's also one of those primitive data types, and it is there to store characters, and specifically one character at a time. So one char can only store one character. It cannot store multiple characters. So let's have a look in JDoodle for that. So therefore, I'm going to use this char keyword, which is again turning green, which means that we are talking about a Java specific keyword. And then I give this character a name. So my char, for example, could be my character. And then when I want to assign a value to it, I need to use the single quotes. Okay, so I cannot use the double quotes that we have seen before when we were printing something using the console, but we need to use the single quotes. So for example, I could store the capital A as the character inside of this char variable. Okay, and I can store any of the ASCII table characters. Now, what is the ASCII table? Well, it's this table right here. It's basically the table here that is a standard that was defined. So the American Standard Code for Information Interchange. And here are the numbers that are stored accordingly for any given decimal number in the background. So you can see it has 127 values plus the 0, so 128 values. All right, and well, yeah, basically our capital A will internally have the decimal number of 65. Okay, so this is not something you need to memorize. It doesn't matter. It's really just about to give you an idea that there are numbers associated in the background for any given character that we can store inside of a char data type variable, and those numbers, they are defined inside of the ASCII table. All right, but you don't need to memorize the ASCII table either. The only thing that you need to know after this video is that you can use this char keyword in order to store characters. Okay, single characters. And we're going to see how we can use multiple characters. So a word, for example, or an entire sentence, and store that in a variable. We're going to see that later. Okay, so that would be the char data type. Now we can print it out as well using system.out.println and then print our character. Now you see that we can use the name of the character. So I don't have to use single quote A in order to display the character. I can just use the variable name in order to display something onto the console or reuse whatever is stored inside of this my char. As always, however, we mustn't forget the semicolon, right? So now let's run this again, and we will see that it just displays A. Now, if I were to overwrite it, so let's say I update my character, so my char, and I update it with the character B, then I display my char again. What will happen is that it will display A, and then it will display B. You see, A, then B. So what we did is we declared and initialized a variable my char of type char. We then printed that out onto the console, and then we updated or reassigned a value to my char. So we changed the value that is stored inside of my char, and we printed it out again. So you see it executes the code here. The compiler executes the code sequentially, so line by line. Okay, so that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at the final primitive data type, and that is the Boolean. And Booleans allow us to store a value that is either true or false. So you can imagine it like an answer to a question that can be a yes or no question, or you can only answer with yes or no. So let's go ahead and create a Boolean variable. So for example, we can use this Boolean keyword. Again, it turns green, which is an indication that it's a Java specific keyword. And then we give it a name. And the naming convention here is that it should be named something like is available, or has permission, or can edit, or should display. So these were just some examples as to how you should call this variable. You could also just take this example here, is Java cool? And the answer will be true. All right, so this gives you one of the answer possibilities. So true is one of the two values that you can assign to a Boolean, and the other one is false. Okay, so these are just the two different types of values that you can assign to a Boolean. So here I'm going to say Boolean is cool, and let's say Boolean is available would be false, for example, or Boolean has access is going to be false as well. So this would be, for example, a Boolean to check if somebody should have access to the admin rights on a given website or on a given backend or something like that. Okay, so this is how it works. And so this is how you declare and initialize a Boolean. Now you can override it as well. So let's say certain conditions were met and suddenly is available is going to be true. So you can override it or reassign a value, but only with the two different possible variants. So it's either true or false. Okay, and now we can display it. So again here, system.out.print line or println, and I can say is available, for example, and with a semicolon, never forget that. And if you run that, it will now say true. So there we are, we get true as the output. Okay, so this is just to give you another tool that you will need to have, and Booleans are really important as they are helpful when it comes to using if statements, which is something that we're going to cover in the next days as well. Really, really important topic. But for now, I'd say this is good enough. Let's look at another data type in the next video. Okay, so now let's look at the last data type for today, which is not going to be a primitive data type, but a reference data type. And we're going to see what a reference data type is in depth later on. For now, it's a little too deep, I would say. The only thing that you need to understand is the data type itself, which is string. And string is a data type that is so crucial and so important because it allows us to store text. So we saw how we can store one simple character, one individual character, but now we're going to see how we can store many different characters and reuse those. So the idea behind variables is really to be able to reuse the value that we stored earlier somewhere. All right, so let's say we have this string called greeting, and we assign hello Java to it, or hello comma Java. And now this greeting variable, we can use that any moment. So we can just go ahead and use it in here, for example, in our system out println statement, and we can run that and it will say hello Java. There we are, hello Java. Now the thing is, we can store super long text in here. So we could go and store multiple sentences and so forth in this one variable. What's important is that the value that we are assigning is surrounded by the quotations. So we are opening with a quotation mark and we're closing with a quotation mark. So this here is a string literal. So basically it is a text. It's a literal text that is considered as a string inside of a Java program. And what we're doing with this is we're saying, okay, this is the text that I want to make available inside of this variable called greeting. And whenever I use this variable, give me this value here. So whatever is assigned inside of greeting. So what we're doing here is basically using the variable saying, hey, you have at this spot somewhere in your memory, you have stored this variable called greeting. Now I'm interested in the value that is assigned to that variable. And that is what this hello Java is going to be. Now we could go ahead and have a bunch of other code. So here another string, my name, and that would be, for example, Dennis. And then we have another system.out.println statement here with greeting, and it will still say hello Java. Because basically every time that we are using the name for the variable, we are just accessing the value that is assigned to it. So that's pretty much what we're doing with the variables. That's pretty much how strings work. So you can assign text to it, and it can be a simple word, it can be an entire sentence, a paragraph, and so forth. You can even store very long strings. So I once built a little software where I even stored an entire image inside of a string variable. Now you might wonder, how is that possible? Well, the thing is, you can convert an image into text, and that text, and I don't mean like LLMs are building an image out of text. I mean that it's really a bunch of weird characters that a human cannot understand, but it's just a converted version of the image into text that can then be rebuilt into an image once you use that text and convert it back. So yeah, I once used that and stored that in a database, and the database wasn't ready for that because it didn't expect for me or anyone to store images as text, as very, very long strings that needed a lot of space as well inside of a string, right? And on the database. So they were expecting images to be just stored on a on a storage, on a normal hard drive. But this was really to test the server, because I was using this separate tool that was really exactly there in order to figure these things out and make sure that the server wouldn't crash. So I got it crashing with that. So that was hilarious. Okay, so that's a little side story, but just to give you an idea what you can store inside of strings. So very long information can be stored in there. So that would be it for this video. Now you have an idea about strings, and we're going to use strings a lot. We're going to use variables a lot. So don't worry about it. You will get a very good feeling for it throughout the course in the next few days anyways. So see you next video. All right, so in this video, I just want to show you a different way of declaring variables, because we have seen how to declare a variable, right? We created it like this: int num equals so-and-so. So the declaration is what happened up to this point. However, you can declare multiple variables at once. So within one line, you can say, let's say int num1, num2, num3, and then add the semicolon to say, okay, that's it for creating integers. So this is just a way to declare multiple variables at once. And you can then later on use those in order to assign values. Okay, so you could go ahead and assign any kind of value. So initialize those variables with values, because at the point of declaration, they don't have any value assigned to them, and we can afterwards assign values to them. So this is just something that I wanted to show you. This works the same way for strings and all other data types. So you can go ahead and say name1, and then name2, and name3, and then assign a value to name1. So let's say Dennis, and then we have name2 being Francis, and name3 being Jenny. And then we can use system.out.println in order to display any of the given names. Okay, so let's just run this and see what's up. And we're going to say, see, it just says Dennis. Okay, so it printed out the first name. Okay, so that's it for this video. I just wanted to quickly show you that you can declare multiple variables within the same line at once. However, if you want to use them, you need to make sure that you initialize them. So, well, if I were to go ahead and, let's say, create another name here, name4, and then never initialized or assigned a value to name4, then this will cause a crash, because name4 is an empty variable, and it says might not have been initialized. So that's something to consider when you are creating variables in one line without initializing them straight away. But now you know how it works. Okay, so that's it for this video. All right, so in this video, we're going to look at some basic arithmetic operations with variables. All right, so therefore, let's go over here and create a int a that will have the value of 5, and int b that will have the value of 10. And I'm using these very simplistic names because I really want to just do simplistic things. We could obviously call them number 1 and number 2 and so forth, but a and b is good enough for this example. So then I'm going to have a sum, which will be the sum of a and b. So what I can do is I can add these two variables together. So this will give me the sum of a plus b. And now what I can do is I can print that out. So system.out.println, and I can just say sum. And this will now give me 15. So if we run that, we'll see that the response will be 15. There we are. Now, you can also, and that's something we haven't seen yet, you can also combine a variable with some other text. So before, when we were using print line statements, we were always just using strings, right? So either we were printing out a string or a character or something like that. We can also print out variables. So we can print out int variables of different types, right? Not just int, also long, short, double, all of them. We can print them out directly, but we can also combine a string literal, so a text, with a variable. So we could say something like the sum is, and then plus sum. So here you see this part here is the string, and then I use this plus sign, which is not going to do arithmetic calculations here between this number and the string, but it will just say, okay, after this string here, I'm just going to use this here like a text as well. So it's just going to give me 15 as a response, because it did that already, right? When it printed out this sum for us, this 15, it to a degree did that already. So we can see here the sum is 15. So this is very simple string concatenation. We're going to go a lot more into string manipulation, where we're going to see how we can change strings up so that they display information a lot better, and it's going to be pretty cool. So a lot more on that, I believe, tomorrow. It's too much for today, but the general idea here really is that you can do what we can see here. You can have a text, and then you can display the value of a variable. Okay, so now let's just do the same thing with the difference. So let's say int difference between a and b. So we can just say b minus a, and let's see what that will be. So I'm just gonna say something like the difference is, and use the difference variable here, the name, and let me run that, and we can see the difference is 5. So the difference between the two values is 5. All right, and now you can do the same thing with multiplication. So the product, for example, int product is a times b, and then we can print that out. The product is, and then we use the product name here, product. Now let's run this, and we will see it says 50. So 5 times 10 is 50. And finally, we have the quotient, or quotient, int quotient equals a divided by b. And I think that would give us 0. So I'm going to say b divided by a, because that leads to a whole number. And we're going to go over why a divided by b gives us 0, even though 5 divided by 10 is not 0. We're going to go into that a little more later. But for now, let's divide b by a and use the quotient like so, and run it again. And we will get the quotient. Good. So that is to give you an idea. And the interesting thing is, we could have along the way updated a or b. So we could have said a is going to be 10 at this point. Okay. So if we run this again, we will get 10 times 10, which is 100. So here we are overwriting or updating the value of a. So let me run this, and you will see that it says, well, the print statement here, the product, interesting enough, it is not going to be 10 by 10. So that's something, right? So I did the update after I did the calculation for the product, and then I displayed the product. So you see it runs sequentially. So in order to get 10 times 10, I have to put this in front of this int product. So here, let me run it again, and now I will receive the product of 100. So product is 100, and the quotient is 1, because 10 divided by 10 is 1. And finally, we can generate more complex expressions. Okay, so it's not always just a times b or b divided by a. We can also say b divided by a plus b minus 5 plus a, or something like that. Okay, so we can have more complex statements, and this one would be expression. I just give it a different name, and the expression's result is, and we could call it result, maybe that would be a better name, but we see the expression's result is 16. Okay, so just did the entire calculation. So it said 1 plus, I think b is 10, so 1 plus 10 minus 5, is 6 plus 10 is 16. Okay, so that's it for this video. See you in the next one. All right, so in this video, we're going to look at typecasting, and typecasting is just a way for us to convert from one data type into another, because sometimes you just need that. Sometimes you get, let's say, an int, but you need it as a double, or you get a double, but you need it as an int. And in that case, you need to do something called typecasting. So let's look at that. So typecasting is essential for assigning values or performing operations involving different data types. There's also another way of conversion that is called widening conversion, which is implicit casting. So this occurs automatically when we are assigning a smaller data type to a larger data type. No data loss occurs in this case. So let's say we're converting from an integer into a double. We're not losing any data because the double can store more information than the integer. Or we're converting from a byte into an int can store more information than the byte, so there will be no data lost, so we can just do that implicitly, so we don't need to actively change anything around it. And then there is narrowing conversion. So this is called explicit casting, and it requires an explicit conversion using parentheses. This may result in data loss if the value exceeds the range of the target data type. So let's say we want to store a double value, which could be 3.1, and we want to store that inside of an int, then the int will only store 3. It will not store 3.1. And even if we have 3.9, for example, it will still only store 3 because it doesn't round up or down. It just cuts off whatever comes after. Therefore, let's go ahead and get rid of our code from before and let's simplify things. So first I have this numInt, which is a number of type int. And then I'm going to create a double, which I'm going to call numDouble. And this one will be assigned the value of numInt. So here what we're doing is implicit casting from int to double. All right. So this is an int and we're casting it into becoming a double value. So internally, this means that out of 10, now we're making 10.0. Okay, so this will now be 10.0. We can see that by doing the following. So let's print it out. System.print or out.println. We're gonna print out numInt. And then let's do the same thing with numDouble down here. So this one will be numDouble. And if you run that, we will see one will say 10 and the other one will say 10.0. So this here is an int and this here is a double. So what we did here is we implicitly casted or converted from an int data type into a double data type. Okay, so this is a double, numInt is of type int. So now there is also something called narrowing conversion, which is explicit casting. So let's look at that. Here comes explicit casting. Now this will be, let's say we have a double, numDouble2, and then this will be 10.5, for example. And now we want to make an int out of it. So numInt2, which will be int in brackets, in parentheses, and then the value that we want to assign to it. So numDouble2. So this here is explicit casting from double to int. And this is not lossless. So this will be with loss. What are we going to lose? We're going to lose this 10.5. So now let's print out double2 like so. And let's comment this line out as well here. We won't need that anymore. So let's just display numDouble2 and we will see that it is 10.5. Now let's display numInt2 and we will see that it is 10. So we're losing additional precision. And 10.5 usually would be rounded up, as I said earlier, right? It would be rounded up to 11, but it doesn't happen because it just cuts off whatever comes after, okay? And now this also explains why the following will result in 0. So let's say int result equals 1 divided by 2. 1 divided by 2 is 0.5, but an int cannot store 0.5. It can store 0, comma, nothing. So whatever, or dot, nothing. So whatever comes after the floating point will be cut off. So result, if we now print that out, so here, result, we're going to see that it just prints out 0. Okay, so there's no precision left here. Now you could say, hey, we can just make it a double. All right, let's try it. Let's make this a double. Result, 1 divided by 2. That should give us 0.5, right? But it doesn't. And why? That is because what's happening here is on the right-hand side. That's what is relevant. So this here results in an int response. So let me give you 2 examples. Let me do this twice here. So result, and I'm going to override result with 1.0 and 2.0. So here, result is going to be 1 divided by 2, but 1.0 divided by 2.0. Okay, so here we are adding precision. So we're doing the following. We're dividing a double by a double. Now let's run it again, and we will see that result will be 0.0 for the int division, even though we're storing it in a double. And it will be 0.5 for the double division because we're dividing doubles by each other. Okay, so this here is explicit casting. We are converting from one type into another type. So we're converting the double variable into an int variable by adding the data type that we want to cast it into in parentheses in front of the variable name, while assigning the value to a variable of that data type. So of, in this case, int as the data type. What we're doing here is just to give you an idea as to what is happening internally and how numbers are treated. So if I were to use f and f here, suddenly these would be floats that are divided by each other. So not doubles. Okay, you can play around with this to get a better feel for it. Okay, so that was explicit casting here. That was to give you an idea as to what's happening internally with numbers when you are dividing and stuff. And here we had the simplest form, and that is implicit casting. And this works if we are converting from the smaller data type into a bigger data type that can store all of the range of the smaller data type. So the double can store all of the range of the int. That's why it doesn't struggle storing whatever int we're giving to it. All right, and with that, I'd say enough for typecasting. See you in the next video. All right, and that was the day. So today we covered the basics of variables and data types, learned how to name variables correctly, explored primitive and non-primitive types, and practiced converting between data types. You also completed a fun exercise, and I hope the quiz helped reinforce what you've learned. Tomorrow, we'll get started handling user input and work with operators and expressions. This will help us build more interactive programs and perform calculations. So, see you tomorrow. All right, welcome back. So today we are going to take the next big step by introducing user input and how we can handle it effectively in Java. We'll start by learning how to take input from the user using the scanner class, and we'll see how this applies to both text and numbers. After that, we'll go into operators and expressions, including arithmetic, unary, relational, and logical operators, which will allow us to perform calculations and make comparisons in our programs. We'll also touch on strings, how to create and manipulate them, perform comparisons, and use key string methods. By the end of today, you'll know how to handle user input, perform basic calculations, and work with strings efficiently. So we'll wrap up with a quiz and a simple exercise, which will be a trade profit calculator to put everything we've learned into practice. All right, so let's get started. Welcome to day 3. So today we're going to focus on operators and strings. And we've seen strings a little bit already. They were just a variable type that we could use, or data type that we could use in order to store text. But there's a lot to learn about strings, and we can manipulate them quite well. So the first thing is that we so far have only had output. So we only had code that allowed us to display something onto the console or in the output. However, what we want to be able to do is also handle user inputs. So in Java, handling user input is a fundamental task you will frequently encounter. The scanner class, part of the Java util package that we've seen before with systemout.println, is a simple way to read user input from the console. And this chapter will guide you through using the scanner class to handle different types of inputs, such as strings, integers, and floating point numbers. For now, remember that scanner is just a class available in the JavaUtil package. And we will discuss classes in detail in later sections. So don't worry about what classes are yet. Just understand that these classes currently just allow us to use certain features of Java. In order to use the scanner class, we need to import it. And we're going to see how that works. So a package is a way to group related classes together. Think of it as a folder on your computer where you store similar files. The JavaUtil package is like a toolbox that comes with Java, full of helpful tools for many common tasks, such as handling dates and times, doing math, and managing groups of objects. To use the scanner class, you first need to import it to your program. And you do that by stating this current line of code where you say import JavaUtil scanner. And we're going to see that in a bit. By using import JavaUtil scanner, at the top of your program, you can use a scanner class to read different types of input from the user. After importing the class, you need to create an instance of that scanner object. And this object will read input from the system in stream, which represents the standard input. So usually it's just the keyboard. And we're going to use just that. This quick look at the JavaUtil package and the scanner class shows you how you can start handling user input in your Java programs. And we're going to learn a lot more about these different tools later on. So how about we just go over to JDoodle and use the scanner class directly and use user input, which means that we will be able to interact with the software that we're building. So finally, we're at the point where we can do that. Before that, we could only consume the data. Now we can actually send data in as well. So see you in the next video. Welcome back. In this video, we're going to take care of user input. So we're going to build a software that accepts user input and then does something with that user input. All right. So in order to get user input, we need to import this scanner class that I introduced to you in the last presentation. And in order to get that, we need to enter import JavaUtil.scanner and then a semicolon at the end. So this line is step number 1, really important. Then step number 2 is to create a scanner object. And we create a scanner object like we did a string. So we created a string also before, right? Where we said string, then the name of the variable, and the same happens here. So scanner, and then the name of the variable. And I'm just going to call this one scanner. It's going to be a new scanner. And here I need to enter system.in. So this line here, there's a lot going on here. And basically we are creating an object of type scanner. Now, what is an object? What is type scanner? That's too much at this point of the course. So don't worry about it. For now, just accept that this is the line of code that you need to enter whenever you want to get user input. However, later we're going to understand in depth what this new keyword means, what a class is, what an object of a class is, and so forth. But for now, I think it would just not really make sense for you to learn all of that already. You need to first get a feel for the programming language. So why are we still using the scanner? Well, because it's just more fun to also be able to interact with the software, which is why it's important to introduce it at least to the level where you can use it. So basically now I'm teaching you how you can ride a car, basically using the scanner. And later you're going to see how you can repair the car. And even later you will be able to build the entire car by yourself, so to speak. Okay. So here we're using the scanner, and then the first step is going to actually prompt the scanner to ask for user input. So here we can do scanner.nextLine. So we are using this scanner variable or object. We're using this variable in order to get the next line, which will indicate, okay, ask the user for a line of text so that the user can input something. However, whatever the user enters can be stored as well. And we're going to store that in a string that I'm going to call name because I want to ask the user for the name. And the fourth step is to close the scanner. Okay, scanner.close. So this is just good practice to have that as well, because otherwise your scanner will consistently be open and that will not be a clean close for your application. So the application will not close cleanly, and this is not good practice to leave it out. So you need to make sure that you have it here. Okay, so this was step number 1. This here is step number 2. Here we have step number 3, and this is step number 4. So now let's let the user know what the user is supposed to do. And we do that by using system.out.println. We've seen that multiple times before, and we're going to say enter your name. And we finish this with a semicolon. Then we get the name, so we store whatever the user entered, we store that in this variable, which means now we can use that variable, and that means the user input, in our code. So throughout the rest of our software, we can use it, right? In this case, I'm going to say system.out.println, and here I'm going to say welcome to the Java Club, and then outside of the quotations plus name, and then finish this whole statement with a semicolon after the closing parentheses. So this code that we have right here will now do the following. It will tell the user to enter their name, then we can enter something, and whatever we have entered will be displayed on the console after this statement here, welcome to the Java Club. All right, and now in order to run this and test this, we need to add this interactive right here. Once we've checked this interactive box, then we will be able to enter something. So enter your name, because otherwise you will see that if we make it not interactive and we run it, so let me run it again, and you will see that we get this exception in thread main and so forth. It just says, okay, there's an error. And that is because it is expecting something to be entered, but our software is not, well, this IDE that we're using, JDoodle, is making it uninteractive, which means that it will just go through the code entirely without us ever having the possibility to enter something. And that leads to this error because next line is expecting something to be entered, and it just says there was nothing entered. Which I mean is that here at this line, it expects that something would be entered, but nothing was entered. All right, so now let's add this interactivity here. So check this box. Then it will say, enter your name. And I'm just gonna say Dennis. And then it will say, welcome to the Java Club, Dennis. And now let's run this again. And it's gonna say, enter your name. And I'm gonna say Frankie. And it's gonna say, welcome to the Java Club, Frankie. So you see that we now have this little software that takes in user input and does something with it. Now, obviously at this early stage, it is not really fancy what it does because it really just takes the text and displays the text that we have entered. But that's already pretty cool. So now you know how to do that with strings. So using next line is allowing us to get a text input. However, if we wanted to use a number where we can take that number for calculations, for example, that's a different story, okay? And therefore we need to use not next line, but next, for example, int, if we want to use an integer. That's what we're going to do in the next video, okay? So for now, I hope you enjoyed this video, and I'll see you in the next video where we're going to go into number inputs. Okay, so in the last video, we saw how we can get user input, but it was always just a text. Now let's look at how we can also get a number. Why is this relevant? Well, it's relevant because of data types, right? We have seen that different data types behave differently, and we cannot just mix and match them as we want them, because we sometimes need to convert from one data type to another. And currently we don't know yet how we can convert from a string into a number. And while we do that, a lot of things can go wrong, and we don't have the tools yet in order to make sure that these things don't go wrong. So we're going to learn all of these things along the way, but for now, we're going to keep it simple. We're going to use a different piece of code, so a different method is the name of it, but a different piece of code that will allow us to take text in that is of type int. And the text that we enter has to be a number, because otherwise our program will crash. So let's look at that in action to get a feel for it. So therefore, I'm going to use the same code that we used last time with our enter your name code. And I'm going to now let the user know that the user should also enter their age. And therefore, I'm going to use this system print out statement here, I'm going to say enter your age. Now, this is nothing fancy, nothing new. This doesn't have anything to do with user input, right? But now let's get to the user input. And therefore, I'm going to use scanner again, dot next. And here I'm going to use next int and a semicolon at the end. So what this will do is it will ask the user for a whole number, or it will wait for a user input that is going to be a whole number. And we can store a whole number inside of a variable again. So here we stored this next line as text inside of a string. However, we cannot do that with next int because next int is going to give us an int. So it's expecting an int that we enter, but it's also going to give us an int that we can store as developers. So in this case, I need to use int as a data type. So here I'm saying int age equals scanner.nextInt. All right. So with this, I'm getting the user input with this line here that will be of type number. So now we have two user inputs that we're waiting for. And I'm just going to comment these two lines out. Okay, so you see, this is also how we can use comments. I'm going to comment them out because I don't want to use those for now. And I want to only use the code that comes after. So this means that this code will not be executed by our compiler. So by our online Java compiler IDE, JDoodle. So they will not have an impact on our software basically. So now let's go ahead and not use the name anymore because this would cause an error because we don't have the name variable anymore. So I also need to comment this line out or change it. What I'm going to say is your age is, and then I'm going to display the age. So we're going to say, so your age is, and then plus age. So whatever we entered as the number. So let's run this to see this in action. So enter your age. And if I now enter something that is not a whole number, so let's say I say something like SDFG and I press enter, then my software will crash. And it says exception in thread main Java util input mismatch exception. So whenever you get an error, you get an exception because it is out of what is expected. So it is exceptional. So we get this exception which just says, okay, there's something wrong here. It tried to get an int, but it got a something else. So SDFG is of type string. It's not an int. And that's why we have a input mismatch. Okay, so how can we fix that? Let's run it again, but this time actually enter a number. And let's enter something like 36. So it says, so your age is 36. And I should have written correctly, your age is 36. So then let's enter a floating point value, okay? 36.1, because well, maybe it's 0.15, let's say, or 2, okay? So if I enter this, it will also run into an error. It will also be an input mismatch exception that I'm getting. Why is that? That is because, again, I'm not entering a whole number. And an int is always a whole number. So we saw the code works flawlessly if we are entering a whole number. Everything else is not great. So an int can go all the way to a very big number. So if I exceed this number, it will also say, okay, what you're trying to enter is, well, it seems more like a string because it's way too long to be stored inside of an int. I can go up to 2 billion as a number, right? For integers, we've seen that before. So 2 million, okay, 2 zeros are missing. So this is still fine. Everything from 2.15 billion is going to be too much. So it's out of the int range, right? But overall, you can see you can now enter numbers and ages. So now you could go in the next step and use numbers in order to calculate something. So let's try this real quick. Let's ask for a number A and the number B, and let's build the sum of the two. Okay, so pause the video and try that real quick. Okay, so I'm going to very quickly do that here. So I need to copy this code. Actually, I need to copy this piece here, and I'm going to put it like this. So enter number A and enter number B. And I'm going to store them as A and B, and then I'm going to display the result. So the result is, and I'm going to say whatever a plus b is. So a plus b. And maybe we do the calculation outside. So we build the sum of a plus b, and then we store or we display the sum here. So now we're asking the user for input twice. Okay, enter number A, let's say 15, and enter number B, 33, and it says the result is 48. So with that, we've very simply created a calculator. Super simple calculator. It's an adder. It can only add. It doesn't do anything else than addition, but it is a calculator nonetheless. Okay, so that's it for using scanners and next ints. There will be a few exercises about that as well, so you get a better feel for it, but you get the general gist, right? So you need to have this line here to import a scanner. You need to create a scanner object, so you have to have this line, whatever importing and creating an object is. We're going to go deeper into it later. Then you need to, well, let the user know what they are supposed to do. That's optional, but I would say recommended. Then you can either get an int or a text. So if you want to get a whole number, you use next int after the scanner dot. If you want to have a text, you use next line after the dot. And then you can store that in the right data type. So you can store a number inside of an int data type, and you can store a text inside of a string data type. Good. So that's it for this video. See you in the next one. Welcome back. In this video, I want to show you a little thing that you need to consider when you are working with NextInt, and that will be relevant for our next project that we're going to build for the exercise. So one thing that you need to understand is that when you enter an int and you hit the enter key, the enter key is also considered as an input. Now, I prepared this little example to show you what I mean. So I have this code here where I use the scanner in order to get the age, and after that I get the name. So I'm asking for the age, get the age, ask for the name, get the name, and then I want to display the name. So let me just run this and show you what happens. So when I am asked for the age, I'm entering something, let's say 36, and then I'm asked for my name and I enter Dennis. You will see that the software, what it does is it says your name is Dennis, but this Dennis is in a new line. And why is that? Well, because it stored the enter key after I entered 36. So it stored it in the buffer. So the input buffer, the scanner's input buffer, holds this enter key and uses it for the next time that I enter something. How I can now avoid this is by adding a scanner next line directly after I get the input for the integer. So here, this here is just to consume the next line slash the enter. Okay, so let's run this again and see what I mean. So now if I enter the age again, then I enter my name. You see it says your name is Dennis, and all in one line. So the enter key was not added here, or this new line was not added before my entry of the string. So this might seem a little confusing, but that's just how the system works, right? This is how scanners work. So whenever we are pressing enter, it is in the buffer. So it's basically like stored in there for the next time that we enter something. So when we enter something here, it is still stored if I don't have this line that consumes it. So this line of code consumes the enter key that I press after the next int. I'm not sure why it is designed this way, but it is what it is. So this is really just another line that we consume it with. So basically we're consuming this enter key and we're not storing it anywhere. So we're not adding a string enter key or something like that in here in order to store it, because we don't need it. However, we're still consuming it. Okay, so that's what this next line does. So if you didn't understand fully what I just said, just memorize it as, okay, with this piece of code, we enable that the next time that we use next line, we don't have the entry that we are entering in the line after. So it doesn't make it line jump. Okay, so that's it for this video. See you in the next one. All right, so we had this little exercise of creating this calorie counter pro tool, and let's build it. So the first thing that I'm going to do is I'm going to prepare everything so that we can get user input, okay, before I do anything else. And that is to import Java util.scanner. Then I'm going to create a scanner variable. So I'm going to say scanner equals new scanner. And here it will be system.in. And then I'm creating all of the variables that I need. So I need to have the different foods. So string food1, food2, food3. And I need the calories for each of those. So calories 1, calories 2, and calories 3. And then I also want to store the total calories. And I'm going to set that to 0 for now. Okay, so then I also want to make sure that I'm closing the scanner before I forget it. So I'm going to do that at the end, scanner.close. And now we can go ahead and welcome the user. So system.out.println, welcome to the calorie counter pro. And also I'm going to call this class this way. You don't have to do that, but it's just a nice way. So you see classes start with a capital letter and they stay camel case. So I'm going to call this class calories counter pro. Good. So the next thing that we need to do is we need to get the user input for what the first food was and how much calories it was. So system, or let's say we copy this, enter food1, or enter the name of the first food. So enter the name of food1, for example. And then we use our scanner to store that in food1, okay? So scanner.next line, so whatever the user entered, we're going to store that in this variable that we created, the string food1. And then we ask the user for the calories that it has. So enter the calories for, and then plus food1. So whatever the name was that the user has entered. And then we're going to prompt the user for these calories. So calories 1 is going to be scanner.nextInt. And I'm going to use scanner.nextAlign to consume the enter key that we enter once we entered the food item. Okay. And now we just need to do the same thing a few more times. So we just do this again, but this time for food 2. So we need to rename this variable here as well, and that variable, and that variable. And then we need to do this another time for our third food. So food 3, okay. And now we can go ahead and calculate the total calories. So total calories is going to be calories 1 plus calories 2 plus calories 3. And now we can display those. So we can give general details about all of the different calories. So system.out.println, let's say your calorie intake, and then we can say whatever food 1 was in terms of calories. So just summarizing what the user has entered. So we can say 1 was food 1, and it was this amount of calories, and we add that it was calories. So I have this empty space after, or here before calories, and here after this dash, and also here after this 1, so that they're not too closely together. So I'm going to copy this line and do it 2 more times. 1 for food 2, and here, by the way, 1, 2, 3. Here it's 3, here it's 3, and that would be the calories intake step by step. And now let's do the same thing. Your calories intake total was, and then we display the total calories plus total calories. All right. So let me zoom out a little bit so you can see more of the code. So this is what was the total. And now let's use system.out.println to also thank the user for using our software. Thank you for using calorie counter pro, calories counter pro. You could call it however you want. So there we are. At this point, we should be able to test this and see if we run into any types of errors. Make sure that interactive is activated, and it says I missed a semicolon somewhere in line 11. Okay, so there we are. Yes, I did indeed. Very good. Now let's run it again. Let's see if I have any more errors. It seems like no. Enter the name of food one. So I just had an apple. Let's say the apple was 60 calories. Then I have a banana here. So I might eat that as well. Banana. And the banana should be at around 130 calories. Oh, for a banana. So I have this somewhere still in there. So we can check that out in a second. So that's 130. And then enter the name of food 3. And food 3 is going to be my tea, even though it's a beverage. So I'm going to say black tea, good old English breakfast tea. Enter the calories, and I believe it's 0. Or it should be 0, but let's say it's 1. So it says your calories intake: 1, apple 60 calories, 2, a banana 130, 3, black tea 1 calories. Your calories intake total was 191. Thank you for using Calorie Counter Pro. Now we could obviously add a few empty lines in between as well, so it looks a little nicer and puts it into separate lines as well. All right, then I, by the way, also ran it once again because I had this weird error with a banana, so I must have entered a somewhere in between. But you can see that the software seems to work flawlessly. So now we have this really nice looking little calories counter, and you can modify that to whatever you want, right? And this is still the beginning, so we're going to build a lot cooler software, but I think this is a great start. Thank you very much for following the course and trying to build this, and see you in the next video. All right, so now that we know how to use user input with text and numbers, let's have a look at how we can use operators. And operators are special symbols that perform specific operations on one or more operands and return a result. They are essential for manipulating data and performing calculations in a program. Now, in this context, we also need to understand expressions. And expressions are combinations of variables, operators, and values that evaluate to a single value. They are used to perform operations and compute values within a program. For example, a plus b is an expression where a and b are variables and plus is an operator. And then there are arithmetic operators. Arithmetic operators are used to perform basic mathematical operations, such as addition, subtraction, multiplication, division, and modules. They work with numeric data types to perform calculations. Then there are unary operators, and unary operators operate on a single operand to perform operations like incrementing or decrementing a value or changing the sign of the value. And then there are relational operators, and relational operators are used to compare two values or expressions, such as checking if one value is greater than, less than, equal to, or not equal to another value. These comparisons return a Boolean result. And then we have logical operators, and logical operators are used to combine multiple Boolean expressions and return a Boolean result. They are used to evaluate logical conditions and make decisions in a program, and are crucial for if statements. So we're going to see that. And then there are short-circuit logical operators. Short-circuit logical operators evaluate the second operand only if necessary. This means if the first operand is sufficient to determine the result, the second operand is not evaluated. This improves performance and avoids unnecessary operations. We're going to see all of these in action throughout the next few videos. However, there is one more, and that is the assignment operator, and we've been using it already. So it sets the variable on the left to the value on the right, either creating or updating it. There is the addition assignment, which adds the value on the right to the current value of the left, and then updates the left variable with the result. So we're going to see that in action as well, because it is a little abstract in this explanation, but once you see it in action, it will make a lot more sense. And the same goes for the subtraction assignment. So it works the same way, only that it works for subtracting. So it subtracts the value on the right from the current value of the left variable and then updates the left variable with the result. So if we take that, let's say a is a value of 10 and we say minus equal 5, then a will suddenly be 5 because 10 minus 5 equals 5. All right. So then there is the multiplication assignment. It works in a similar fashion. So it says whatever a is, multiply that with 5 and store that in a. So if a were 2 and we multiply 2 with 5, that's 10, and then a suddenly becomes 10. So that's multiplication assignment. The same works with division assignments, only that it's the division instead of multiplication. And then there is the modulus assignment, and it finds the remainder when the left variable is divided by the value on the right and then updates the left variable with this remainder. So let's say a is 7 and 7 divided by 5 is 1 and it leaves the remainder of 2, so a becomes 2. But as I said, we're going to see these things in action. It will make a lot more sense. So that's it for this video. See you in the next one, where we're going to start with the practice. Welcome back. In this video, we're going to look at the arithmetic operators once again, and we have seen them before, but this time I want to focus on one that we haven't touched on yet, and that is the modulo operator. I talked about it very briefly in the presentation, but now let's dive deeper. So I have this little code here prepared where num1 is 5, num2 is 8, and I have this int result. So 3 integer variables, and now we can do the following arithmetic operations, right? We can do addition, subtraction, multiplication, and division. And addition happens through the plus sign, subtraction minus sign, multiplication with the star or with the asterisk, and then we have division with the forward slash, really important, not the backward slash. So now if we run this, we will see that the addition of 5 plus 8 is 13, of 5 minus 8 is minus 3, multiplication is 40, and division result is 0. And we know why that is, because, well, we're storing an int, and 5 divided by 8 is not 0, but if we cut off everything that comes after the floating point, then it is in fact 0. So 0 point something as an integer is always 0. All right, so now let's look at something called modulo. So there is this arithmetic operator that is the modulo operator. So in order to do that, we need to use the percentage sign. So result will be num1 percent num2. So what it will do is it will give us the remainder. So now let's just print that out as well. So here, modulo result, and this one here is the modulo operator, percentage sign. And we will see that we get 5. So why is it 5? Well, 5 divided by 8 is 0, remainder 5. If we were to do it the other way around, so let's say 8 divided by 5 is 1, remainder 3. So let's actually check this out. Let's try it. Run it again. So 8 divided by 5 is 1, remainder 3. So modulo will return 3 for us. And the modulo operator is quite important because it allows you to do things that other arithmetic calculations just can't. All right. So getting the remainder in such a simple fashion is brilliant. All right. So that was really the focus of this video. So I would recommend that you play around with this modulo operator a little bit with different values. So you can also use the scanner in order to get user input with next int in order to then try out different calculations and see what modulo will return to you. So just the remainder, division, and whatever is left is what we get as the result of a modulo operation. So that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at the unary operator as well as the decrement and increment operators. So the unary operator allows us to set a value positive or negative. So this is the unary plus that we have here. So a is positive 5, and we can go ahead and let's say use minus a in order to make a negative. So we are multiplying whatever a is with minus. So that's like in math, if you are multiplying minus with minus, you're going to get plus. So you're going to get a positive value. But in this case, as a is a positive value, we are getting -5. So we can check that out by sending that to our console in order to see what's up. So let's display negative, and we should see that we get -5 here. There we are. So that's the unary operator. So the unary plus and the unary minus. Now there is also the increment operator. So what is the increment operator? Well, it allows us to increase the value of a variable by 1. So here, let's say we are taking a, which was 5. So let me get rid of this plus. A is 5. And then what we're doing is we're incrementing a, and we're storing that in b, right? So a plus plus. What we're doing here is we are incrementing a by 1. So that's what this plus plus does. So you're taking the variable name and you are adding 1 to it. That's what this plus plus does for us. So we can print this out. So let's take this here and let's display b, and let's display a as well, or let's do it the other way around so we can see it better. And let me comment this out as well. So when we run this, we will see that a is 6 and b is 5. And now you might wonder, why is that? Didn't we just increment a by 1? Well, yes, but what we are using here, to be more precise, is the post increment. So we are incrementing a after using it. So we're using and assigning a to b, which makes b 5. And then we are incrementing a after the fact. So we're adding 1 to a after the fact. So this here is the increment operator, but more precise, post increment. Okay? So during execution, what happens is we create this variable b, and then we initialize the variable b with a. A is 5. And then after that, we are adding 1 to a. So a becomes 6, which is now going to display 6 for a and 5 for b. Now we could display this a little better, saying a is plus a and b is plus b. And let's add an equal sign here, or an empty space here as well. It will make it a little more readable. So a is 6, b is 5. So that's the post increment. So if there is a post increment, is there also a pre increment? Well, yes, there is. So now let's do the same thing, but we're using the plus before the a. So we're saying plus plus a. So this here is the pre-increment. So let's look at what this will give us. And let me add a system statement here. System out println pre-increment. Let's run this. And we'll still see, and I forgot a semicolon somewhere. That's why I'm really looking forward to tomorrow, where we're going to install a proper IDE on our PC. And on top, what we can't do is we can't create two variables with the same name. So what I'm doing is I'm assigning b as being plus plus a instead of int b, because with int b, I'm declaring a new variable, but I already declared the same variable with the same name. So I can't do it again. So this time I can still use b as the variable, but I cannot say int b, because that would try to create a new variable with the same name that already exists. And that created an error as well. So let's run this again. And we'll see that a is 6, b is 5, pre-increment. So now a is 7 and b is 7. So what happened is that at this point here, a was 6 and b was 5, right? Now what we're doing is we're saying b should be whatever a was, but one more already. So a at this point was 6, right? Here a is 6, and here already in this line. So during the assignment, so the reassignment of the variable b, a is becoming 7. So a is 7, we're assigning that to b, which is now why we can get a as 7 and b as 7 in these two lines of 16 and 17. Okay, so that's the pre-increment. Usually what you will see is the post-increment most of the time, but sometimes if you ever see the pre-increment, you will know. Now, this works for negative values as well. So this does not only work for pluses, but also for minuses. So let's look at the decrement. All right. So here I'm going to use b equals a minus minus. And let's print the same stuff out. And let me actually take this here and call this pre-increment. decrement, and this is the decrement operator. This is the pre-decrement operator, and let's use that here. So this is the pre-decrement, and now let's do the same for post-decrement, and I didn't want to run it. Let's do this for post-decrement, where I'm adding the minus minus after the A. So this is the post-decrement. So let's run this and get a feel for it. All right. So it says A is 6 for the pre-decrement, and we're assigning B 6 as well. So here you see A used to be 7 before, right? Then we had this pre-decrement, which means we reduced A by 1, and we assigned that value, which is 6, to B, which is why we had A and B being 6. And now what we're doing is we're using the post decrement, where A is 5 and B is 6. So A is turning 5 after this line of code. But while we are using A to assign it to B, it still is 6. So only after that, so the post keyword, only post that is when we are decrementing A, or we're reducing A by 1. And then the next line, so this is the line where we're actually using this. At that point, we're saying, okay, A is 5 and B is 6. Okay? So now you might wonder, why do we even care about this pre-decrement, decrement? What are you talking about, Dennis? Well, the thing is, this will be very important when we are using if statements, and also in other occasions where you really just need to, let's say, go through a list of items and you need to go through them one by one. And that's where these post and pre-decrements will be extremely handy. All right. So that would be the unary operator, the increment operator, and the decrement operator. So that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at relational operators, and they're super important for the next day and for if statements and so forth, because what they allow us to do is to compare two values and see if they are equal, if they are bigger or higher or lower. So let's get started. Therefore, I have this int A and int B, both of them being 5, and I'm going to have a Boolean result, which will be the comparison here, where I'm using the equal operator. So I'm using double equal signs in order to compare two variables. So I'm saying A equal B. And with that, what I'm doing, and also I put that into brackets in order to make this a closed comparison or a closed check here. So I'm checking, is A the same as B? Does it have the same content, so to speak? And if that's the same, then the result will be true. If that's not the same, then result will be false. So let's print it out to check it out in action. And let's see what result is. And it should give us true, because A is equal B in this case, because 5 equals 5. Okay, so we get true as the result. So now if we were to make A 6 and B stays 5, we will get false, because 6 is not equal 5. So we're not comparing the slot in the memory, so not checking if the variable is literally the same. We're checking if the variable's end or content or the saved value is the same. All right, so we're comparing those two with this Boolean setting here. So this here is the equal operator. So now we also have the not equal operator. So not equal operator. Now what it does is it does pretty much the same thing. So I'm going to again use Boolean result. However, I'm not going to create a new result variable. I'm just going to keep it at that. So reusing the variable and assigning a new value, but this time I'm using the not equal operator, which is exclamation mark equal sign. So we're saying, is whatever value we have for A not equal the same as the value for B? If that is true, so if this entire statement is true, then result will be true. So that means that if A and B are not equal, then result will be true. However, if A and B are equal, then result will be false. Okay, so it's a little bit something where you need to wrap your head around. And it says not equal. Well, yes, but that's because it's comparing those two and checking if they're not equal. And if that's the case, then it's true. Okay, so let's run this. and we will see that one says false and the other says true. So the first one here says false because 6 is not equal 5, and the second one says true because 6 is not equal 5. So that's what this not equal operator does for us. So the equal operator is double equal sign, the not equal operator is exclamation mark equal sign. There are some other comparisons that we can make. We can compare if one is greater than the other. So we can say result is equal to A greater B. So what this will do is it will check if the value for A is a greater value than the value for B. Now let's print this out and let's actually add a statement here as well, and we can see it's true. Why is it true? Well, it says 6 is greater than 5, true. Well, yeah, I guess 6 is greater than 5, right? So that's what the greater than operator, and that's just using the arrow sign. It's just next to the shift key, at least on my keyboard. I'm not sure if you have the same layout. All right, so then that is our greater than operators. If you have a greater than operator, you also need to have a less than operator, and that's the other way around. So here I wrote it incorrectly. It's like this. Okay, this is the greater than operator. So the left hand side is opening arrow showing towards the right. That's the greater than operator. And the one that where the arrow shows to the left, that's the less than operator. And I think the left is like this for you, whatever. So now we need to do it like this. So A less than B, and let's see if that is true. So it should be the opposite of whatever that was, right? So let's run it and it should say false. So there we are. And then we also have two more which are connected to equal, greater, as well as equal, less. So let's look at those. Less than or equal operator. So that would be like so. So less than and equal sign, and that will give us true if A is either less than B or is equal B. Okay, so let me actually put that at the top where it's a little more readable for now, because we need to see what A and B is. That makes it a little easier, I would say. And let's also add a little text here, because now at this point it gets a little overwhelming with all of the different trues and falses. So I'm gonna say less than or equal result. So in this case, what we're saying is 6 less than or equal 5? And it is not. So this statement should be false. And I must have forgotten an but before we can run this, we need to make sure that we declare the result variable before we are using it. So I use result, but I only declared it here. So let's move that around as well. So we're declaring the result variable as whatever this statement will give us, and then we're displaying it, okay? So now let's run this, and we will see less than or equal false. So 6 is not less than or equal 5. However, if we put that to 6, then suddenly it will be true. So less than or equal true. So now let's say 5 for A and 6 for B. That will also give us true. Less than or equal true. So that is the less than or equal operator. And if we have that, then we should also have a greater than or equal operator. So greater than or equal operator is just the other way around. So greater than or equal. And here we need to get rid of this Boolean keyword because we're not defining the same variable again. We're just using the same variable. So we're not declaring it once again. We're just reassigning a value. So if one of them is true, the other has to be false, right? Not necessarily with these two, okay? So less than or equal is true, greater than or equal is false. There's one niche case where both of them are true. Can you think of it? Well, it's the case where A and B are the same. So if A and B are 6, then less than or equal will return true, as well as greater than or equal will return true, because 6 is equal 6. That's why in both cases, this true statement is the case. Okay, so that would be relational operators. We've looked at all 6 of them. Let's go over them step by step again. The equal operator is what we looked at first, where we are comparing the values of two variables to each other. If they are the same, the whole statement becomes true, and we're storing that inside of a variable, and then we're displaying the variable's value. Then the not equal operator, where we're using an exclamation mark equal sign, and we're checking whether the two values of the two variables that we're comparing to each other are both not the same value, and we're displaying it. Then we have the greater than, where we're checking is A greater B. Then we have the less than operator, where we're checking A is less than B. And then we had the combination of equal as well as greater than and less than. So we looked at less than first, then we looked at greater than. So that would be it for this video. See you in the next one. All right, so there are a few more operators that we need to look at as they are used sometimes. So it's important to know how they are working. So we have seen the assignment operator equal. All right, so if I have a variable here int a and I use this equal sign, then I can assign a value. So the equal sign is this assignment operator. However, there are compound operators as well, which allow us to do the following. So a plus equal 3, what that will be is a is equal to a plus 3. So whatever a was before, add 3 to it and store that in a. So that's what this little piece of code does. So it's just a faster way of writing this part here. So what this internally does is it just says, okay, a is 5, now add 3 to 5 and store the value of that 8 inside of a. After this compound assignment, which in this case is the addition assignment, we are getting a value of 8. So let's check that out. Let's use system.out.println in order to get a, and then we use that again, and we say after addition assignment plus a, and now let's run this, and we will see that 5 it was before. Now after the addition assignment, it's 8. All right, that's exactly what I was saying. So basically it is just a shorter way of writing this. This now works for the other mathematical operations. Okay, so we can do the same thing with the subtraction assignment. So subtraction assignment, where I'm just saying a is minus equal 2, for example. And what that will do is that will subtract 2 from 8 and will store 6 in a. Okay, so subtraction assignment. So if we run that now, we will see that now it is 6. Okay, so 8 minus 2 equals 6. So that's what these compound assignments do. Quite simple actually, but still it's important to have seen them and know how they work. Now, this also works for the multiplication as well as division. So we can also say a star equal sign 2, and that will lead to 12, right? So after multiplication assignment, so that should lead to 12. So 6 times 2 is 12. And now if we go ahead and divide that, we can go ahead and do that as well. So a is slash equal 3, and that should give us 4. So there we are after, well, I didn't change the name. This one was division assignment. Now there is one more operator that we have seen that we can use here as well, and that is the modulo operator. Now, if you use the modulo operator or the modulus assignment, then let's say we are using this like so, so divided by 3, so like so, after modulo assignment, then we're going to calculate 4 divided by 3, and we're going to get 1 because that's the remainder. All right, 4 divided by 3 is 1 with the remainder of 1 as well. Okay, so that's pretty much it for compound operators. You have seen the different variants, and that's it. That's good enough for now. So see you in the next video. Great work today. So we have learned how to handle user input, explored operators and expressions, and worked with strings from basic operations to comparisons. Tomorrow, we'll focus entirely on strings and get deeper into how to manipulate and compare them in various ways. I hope you're ready for a deeper understanding of strings and how powerful they can be in your program. So, see you tomorrow. Quick reminder, what you're watching here is just a small portion of our complete premium Java Masterclass. In the full course, you'll get deep into every aspect of Java, from beginner topics to advanced concepts, and have access to extra materials like cheat sheets and quizzes, and hands-on projects as well. You can find the link to enroll in the description below. So if you're serious about mastering Java, make sure to check it out. Welcome back. Today's focus is all about strings, a crucial part of Java programming. We'll start with the basics, how to create and concatenate strings. Then move on to exploring string methods like length, char add, and how to perform comparisons using equals, compare to, and other methods. You'll also learn about substring, replacing characters, and formatting strings with numbers. After that, we'll touch on operator precedence to ensure you're comfortable with the order of operations in Java. By the end of the day, you will have a deep understanding of how to manipulate and compare strings efficiently. We'll wrap up with a practical exercise, a simple interest calculator to apply what you've learned. So let's get started. Welcome back. In this video, we're going to go over a presentation about strings real quickly. And then after that, we're going to go into a demo where we're going to use what we are covering in this presentation. And then you will get a better feeling as to how these things work. So let's get started. What are strings? Well, in Java, a string represents a sequence of characters. And strings are used to store text and are widely used in almost every Java application. Unlike in some other programming languages, strings in Java are immutable, which means that once a string is created, it cannot be changed. Now we have seen that we can create a variable of type string and we can replace the value of it later on, which would make it mutable, right? But under the hood, it's not mutable. So we're going to see what that really means later on. Okay, then in order to create a string, there are several ways to do that. So one is to just use string literals, as we have done. A string literal is just a text that is surrounded by quotes. And we have used that in order to assign a value into a string variable. However, there is another way of doing it, and that is to use the new keyword. We have seen the new keyword when we were using the scanner before, and this is just a different way of creating a string. Now, in order to understand this in depth, we need to understand some higher concepts first, so don't worry about that for now. We're just going to implement it and see how it works, but diving deeper into it, we will only do after we have understood what classes and objects are in more depth. Now, there are multiple string operations that we can do, and one of them is the concatenation. And this is the process of joining two or more strings together. And you can concatenate strings using the plus operator. Concatenation can also be performed between strings and numbers. And in this case, the number is automatically converted into a string. And we have used that before, right? We have used concatenation, but I wanted to go over it in a little more depth in today's videos. So then you can also find out the number of characters in a string using a method called length. So methods are blocks of code that perform a specific task. For example, a display message method can print a welcome message on the screen. And you can then use this method later on in your code to run the same code again and again. So you don't have to write the entire code again. You just need to call, so to speak, this method. We're going to see what that means once we are covering methods in depth. But for now, you just need to understand that there's this little piece of code that we can use in order to get the length of a string. And we have used methods before. For example, we used our println method. So we used system.out.println, and their println is a method as well. So we're going to see how to make our own methods later, and then you will get a very good feeling for it. So there is also a way to get a character at a specific index. So you can get a character by using the char add method. And this will give us the char, so the individual character at a given position. Now, it's important to understand that indexing works where indices start at 0. So we don't start counting at 1, but we start counting at 0. So the first character within a string, within a text, so to speak, is at index 0. But more on that in practice or in the demo, and then you will get a very good feeling for it as well. So you see, I'm using this word feeling a lot. It's really about seeing things in action, then using them a little bit yourself, and then you will feel confident about them and you will know how to use them very easily in your daily programming. All right, so that's it for this video. See you in the next one, where we're going to see all of these things in action. All right, so let's go ahead and use strings quite a bit. So the first thing that we are going to create is a string variable. And we have seen that before, right? We can just go ahead and use a string literal, which is something that is within quotes, right? So that's why I'm using these air quotes. So this here, whatever is inside of these quotes or these quote signs, is going to be a string literal. So if I say good morning here, then this part here is a string literal. So I am storing a string literal inside of this variable of type string. Okay. So now what we can do is obviously we can print it out. So system.out.println, and we can use this variable very easily. So we just need to make sure that we are writing it correctly. And now once we are using it, we will see it says good morning on the console. There we are. So that's one way of creating a string variable. There is another one. We can go ahead and assign a value using the new keyword. So we are saying, for example, new string, and this one will be good night. Okay, this is just a different way of creating a variable. However, internally in this line, the same thing as here happens. All right. So that means that the moment that I create a new string with this way, internally, this piece of code is executed. So it says new string and then good morning within the brackets and quotations. So as I said, a string is immutable, or a string variable is immutable. That doesn't mean that we cannot overwrite the string in this case. So I could change the string content and say something like bad night, for example, right? So this here, what happens internally is that basically it creates a new entry for that piece of string. And this one here is made ready for the garbage collection. So I am overwriting it, and the garbage collector, which is an internal mechanism in Java, is just waiting for objects. So for, in this case, variables that are not used. And if they are never referenced or used, so if no other piece of code is saying, hey, I need you, then the garbage collector knows I can clean that up. I can get rid of it, and it will eliminate it from the memory, freeing it up so that the storage can be used for something else, or the memory can be used for something else. So that's what is going on here. So it is immutable, but we can overwrite it. And then there are some string operations that we have seen. We have seen concatenations or concatenation. We can have a variable first name, and let's say it's John, and we can have a variable last name, and that would be Doe. And we need to make sure that we don't use a capitalized letter here. And then we can put them together. So string full name would be first name plus last name. So this here is string concatenation. Now, there are other ways of string concatenation, and we've seen them when we were using numbers. So we can also have an age here. So let's say the age is 30. And now what we can do is we can create a bio. So some additional details about a given person. So in this case, about our friend John Doe. So we can say something like I am plus full name plus and plus age plus years old. Okay, so this statement here, this is also concatenation. And what happens internally is that age, which is an integer, is converted into a string so that this statement can work, because otherwise we would be mixing integers and strings, so two different data types that don't fit together. So internally, what Java is doing for us is it just converts age into a string. So instead of it being 30, it will become 30, like so, surrounded by quotations. So it converts it. Conversion happens here. So I'm going to comment this out, And that's what happens here when we are storing it inside of a string. So there's a lot of stuff going on under the hood without us seeing it, but that's really the beauty of it, because we don't need to actively think about it and take care of it. So now let's print it out, system.out.println bio. And now let's run this, and it should give us this longer introduction or bio of this John Doe person. So I am John Doe and am 30 years old. So you see John Doe is put together without empty spaces. So if we were to make it nicer, we would have to add a space in between first and last name. So I'm using that here as well. Each time that I'm adding a variable, I'm giving an additional empty space inside of my string literal so that it looks nicer when written out. So that would be just a different way to create strings as well as string concatenation. So in the next video, we're going to look at the length of a string and a method that allows us to get a specific character inside of a string. So see you there. Welcome back. So in this video, we're going to look at how we can find out the length of a string, so how many characters it has, and how we can get a specific character at a specific position. So let's go ahead and do that. And therefore, I'm going to create a string, which I'm going to call quote, and the quote will be to be or not to be. Okay, so very simple quote. So now, how many characters are there? Well, the thing is, you have to consider the empty characters here as well, or these empty spaces here as well. So how can I get the length? Well, I can store the length in a variable, and in order to get it, I just use the variable name dot and then the length method. So I can use that because we are talking of a string. So string is a class such as the system class as well, right? You can see that here, it's red. So string is a class, system is a class, and system has this method called println, right? And we are now using the method of string called length. So this will now give us the length of the string quote. So whatever this string literal has in terms of characters, so the amount of characters. So let's just use that in order to see how many characters there are inside it of to be or not to be. So there are 18 characters in this quote. Interestingly enough, if you ask ChatGPT or other LLMs about how long a given sentence is in terms of characters, it will not be able to do that, except it writes a little script first and then it executes that script in order to find out how many characters there are, because otherwise they're not smart enough. So LLMs just can't do it yet. Okay, so that is how you can get the length of a string. And now if you change the amount of words in here, so let's say the quote is May the 4th be with you. Now if we run that, we'll get a different number here. So it will just give us the length of 26. So there are 26 characters in total. So now how do I get a specific character or a character at a specific index? Well, therefore, I can use another method that is called char at. So a character at a given position. So let's say I want to get the first character. So I'm going to use first char, and this will be of type char. So char is one of those primitive data types that we have seen before. So if I want to get the first char, so first character, I can just say quote dot char at, and then I pass 0 to it. So what does passing mean and whatever? Well, that's something we're going to see once we're going to methods. For now, just think of the parentheses, a spot where you can put the number at which you want to have the character. So the index at which you want to have the character. So char at index is what we need to use. So here index, where index is the position of the character within the string. Okay. So in this case, I want to have the character that is at the very first spot of my string. So in this case, it's the M. So first char should be M. And if we were to access the 10th char, for example, we would use quote dot char at, and what would we enter? We would enter the 9 in here, okay? So it's not that we need to enter the 10 in here, because the 10th is the 10th entry. And how indexes work is they're going like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth, okay? So the first entry is 0. So the first index is 0. It's not 1. So that's why we need to enter 0 here. And for the 10th character, we need to enter 9. Because if you count it, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So 9 is 10th. So just reduce 1 from the intuitive number that you would have in mind, okay? So in this case, if we want to print this out now, we can just go ahead and say system.out.println, and we're gonna say the first character is, and then we use concatenation here, where we're gonna use the first char. And this will now give us the first character. Now, if we run this, we will see that it is M. So it starts with may the 4th be with you. And then if we want to have the 10th character, so the 10th character is 10th characters. So what would that be? That is 6, 7, 8, 9, 10. So it should be O, all right? So let's see. And it is in fact the lower cap O. So that's pretty much 2 methods that are added to your arsenal. So now you have an additional idea as to what you can do with strings. However, there is still a lot more that we can do with strings. So let's use it a little more. The thing is, right now, I'm just teaching you all of these little tools and giving them to you. But later on, we can use all of those tools in order to create really cool software. And it is a little arbitrary to understand, like, why would I use that? Well, the thing is, you need to use it in many situations. And one of them will be the little project that we're going to have at the end. So see you in the next video. All right, so there are multiple ways to compare strings. And we're going to look at how we can compare strings in all of those different ways. So the first comparison will be with a double equal sign. So double equal is going to compare the two variables, but not as you might expect. So let's get started and see how that works. So I have the string called, let's say, string 1, and I enter Java in here. And I have this other string called string 2, and I enter Java here as well. And then I have a third string, so string 3, and that one will be a new string that contains Java as content. All right. So how are they the same? Well, let's look at it. So I'm going to have this statement here, system.out.println, and I'm comparing str1 and str2 using the double equal sign. So what I'm going to do here is I'm going to say, in parentheses here, I'm going to say str1 equal str2. So this will result in a Boolean statement. So this will become true or false. We've seen that before, and now we're using it with strings. Okay, so now let's do the same thing where we are comparing string 1 with string 3 using that same method. So when we are printing them out, by the way, they will be the same, so to speak. So when we're printing, we can even do that here. We could go ahead and do it like so, where we are using a plus sign here and a plus sign there. And then the same with the str plus sign like this. Okay, and let me actually do the same thing here as well. So by the way, you can put that into a separate line, and this will still be one line. And we need to have the semicolon here as well. And here I'm comparing string 3, and here it has to be 3 and a semicolon here as well. So let's put that into a separate line. So now let's run this to see what's going to happen, because it's going to be very interesting. So we're comparing Java and Java using the equal sign, and we're comparing Java and Java using the equal sign. So double equal, and one gives us true and one gives us false. So what is going on here? Well, the thing is that these both are technically one variable. Why is that? Because when we are creating a variable like this, where we're just saying equal Java, for example, we are creating an entry in the memory with the text Java. Now, when we're creating another variable which has the identical text, so capitalized wise and so forth, has the same text, it's not creating a new entry for that text. It's just referring to the space in the memory where this text is stored. So instead of creating a new entry, just pointing to that spot. So that's what's going on between string 1 and string 2. String 3, however, we're forcing and we're saying, hey, create this new string and call it Java. So now it's actually creating a new entry in the memory. And that's why they are not the same. Because what we're actually doing here, we're comparing references. So references. So it's referring to that thing in the memory. It's not really holding the information itself. Okay? So in order to fully understand that in depth, we would have to use a proper IDE in order to know, okay, what's the pointer? Where does this variable here, string 1, point to, and where does variable 2 point to? But this is really just to show you that if you want to compare strings, this is a way to compare them, but not really the content of the two, but more like the direction that they are pointing to. Because the content is all the same for all three. All three of them just have a string called Java. But technically, there is something else going on. So how do we compare those without running into this problem? Well, that's why there is another method that allows us to compare the content of two variables. So to compare, to be precise, the content of two strings. And it's a string method again, similar to what we have seen before already with char, at, and length. All right, so let's look at that using the equals method in the next video. Welcome back. In this video, we're going to use the equals method that the string class offers in order to compare the value of two variables. So we have used a double equal sign in order to compare two variables. But what we actually did is we compared the references or the memory address. Okay, so in this case, we're going to now look at the content of the variable, not so much where it is stored or where it is referring to. So not the memory address as we did before, but actually the value. So how does that work? Well, let's use this again. And now let's use the equals method. So here I'm going to say using equals, and I'm actually going to compare the two variables. So I'm going to say str1 dot equals str2, or actually in this case it's str3. So now I'm going to do the same thing for 1 and 2, so equals str2. So we're comparing those as well, and we're checking if they are the same or not. So let's run this, and we will see that both of them are true. So with the double equal sign, 1 and 2 were true because they referred to the same address, so they had the same memory address. 1 versus 3, however, did not have the same address because with using this new string keyword, we created a new entry inside of the memory. And then when we are using equals, however, both are true. So 1 versus 2 is the same, and 1 versus 3 is also the same. How are they the same? They are the same in terms of the value that those variables hold, because each of those variables, string 1, string 2, and string 3, all hold the value of Java as a string. So that's why these both statements give us true. So string 1 equals string 2 is true, and string 1 equals string 3 is also true, because they hold the same value. Okay, so here comparing the value of variables. And that is pretty much the difference between those two variants. Now, there is another very interesting one, and that is, let's say we change that to Java without a capital J. Now, if we run this, we should get a false at the last statement here. Comparing string 1 and string 2 using equals, now it says false, because string 3 is not exactly the same. The value is not exactly the same. How can we now compare while ignoring whether something is capitalized or not, basically ignoring the case? Well, luckily enough, there is this method that does just that. So let's do the same thing here again, only that now instead of using equals, we're going to use equals ignore case. So there's this method called equals ignore case that we can use here. So I'm going to paste it in here. You can type it out. It's written like this: equals ignore with a capital I and case with a capital C. So now we're comparing string 1 to string 2, but we're ignoring whether there are any capitalizations or not. And the same goes for comparing string 1 to string 3. So now let's run this again, and we will see that comparing string 1 and string 2 using equal ignore case is true, and comparing string 1 and 3 using equal ignore case is also true, even though before, when we were using the equals method, it was false. So you can really see how this is just another way to compare whether something is the same. Because if somebody entered a text and they ignored the case, and somebody else entered the same text and they ignored the case, it's pretty much the same thing, right? At least in most cases. In some languages, it's not the same. For example, in German, there is a big difference whether you're writing a word capitalized or uncapitalized, because it can have a drastically different meaning if it's capitalized versus uncapitalized. But in English, it's not the case. So it is really something where this equals ignore case can be useful. All right, so that's just another tool that you have available to you. So here, comparing the variables or the value of variables while ignoring the case, or while ignoring case sensitivity. There we are. So thanks a lot for watching. And we have one more comparison to look at, but more on that in the next video. Welcome back. In this video, we're going to look at compare to, which is another method that string offers, so the string class offers, and it allows us to compare two strings with each other lexicographically. So this is a word that you usually won't use and usually don't hear, but basically it just means that it is comparing two variables and looking at the alphabetical order of the words. Okay, so A is less than B, for example. So A, B, C, D, E, and so forth. So A is less than B, B is less than C. So A is also less than C, and so forth. So let's have a look at that. So first of all, I'm going to have an animal1, and this should be a string, but a capitalized S here. So animal1 will be a cat, and then I'm gonna have two more animals. So animal2 will be a dog, and now let's see, animal 3 will be a cat as well. So I want to compare those. And what I'm going to do is I'm going to have this system.out.println statement where I'm comparing them, and I'm saying comparing animal 1 to animal 2 using compare to. Okay, so now I'm going to do that in the next line where I'm going to say animal1 dot compare to, and here I pass animal2. So animal1 compared to animal2. Now let's do the same thing for animal3. So let's compare animal1 with animal2 using the compare method. And then finally, let's have another one here where I'm going to compare animal2 to animal1 and 2 to 1. So the order actually matters. So let's have a look. Let's run this. So you see, we don't get a Boolean, but we get an int as a result here. So we're comparing animal 1 to animal 2. So a cat in comparison to a dog is -1. However, a cat in comparison to a cat is 0. And a dog in comparison to a cat is 1. So dogs are superior. At least that's what Java says with the compare to method. So what this just means is that you get a negative value as a result if one word or one string is lexicographically before, so alphabetically coming before. So cat comes before dog, so dog is greater lexicographically in that context. So now you might wonder, why is it -1? Could it also be -2 or -3? Well, let's compare a bat with a dog. So a bat would be a Batman. So I guess it's the flying thingy, right? The darkish thingy. So a bat versus a dog. Now you see the comparison is 2. So -2 actually. So there are 2 characters alphabetically apart between bat and dog. And the bat is 2 characters, or B is 2 characters before D. So that's why we get this -2 here. And if we're comparing bat to cat, which we do here, we're comparing animal 1 to animal 3, then you can see it is -1. So the bat is just 1 character below the cat. So B below C. All right. So you can play around with this and get all kinds of weird games around this, simplistic compare to method, but it's something that has its place. Okay. Now you know how to compare strings lexicographically as well. All right, that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at the substring method that allows us to cut apart a string and just take a portion of that string and store it in another string. So let's have a look at that. Therefore, I have this little phrase here which says programming in Java. And now what I can do is I can break it apart or take a portion of it. So I'm going to say word1 is going to be equal to phrase dot substring, and then I can enter numbers in here. So there are 2 different ways of doing it. So let's say I create a substring from the 5th character, so from index 5. So it will go index 0, index 1, index 2, index 3, index 4, index 5. So we should get amming in Java from this little portion here. So let's print it out, system.out.println with word1 is, and then plus word1 and semicolon at the end as usual. Let's run it and we will see word1 is amming in Java. So it took the phrase string and took everything from index 5. So index 5 is A. So that's where the whole rest of the string is starting, so to speak, and we're storing it inside of word1. Okay, now there is another way of doing it, and that is to add 2 values in here. So if you want it to start at one point and go all the way to another point, you can do the following. So let's say I want to have the word programming, and I know it's 11 letters long, so I can just say from 0 to 11 excluded. So index 11 will not be included, but we are still getting 11 characters because we are starting to count at 0, right? So 0, 1, 2, 3, 4, and so forth until 10 are 11 characters. So that's what we're getting here with programming. So word1 will be programming. And now I'm going to create another substring, which will be word2, and that will go on from index 14, actually from index 15. So if this is 11, this is 12, 13, then 14, and that's 15. So I want it to be from 15 onwards, and that would give me Java. So let's use that and print it out here as well. So word2 is word2, and let's run it, and we will see that we are in fact getting Java as our second word. So this way you can break down your sentences or your strings using substring. Now the thing is, in this case, we could have also just written, obviously, programming here as a string, right? As a string literal, but sometimes you don't know what you're getting. So you just want to cut it apart based on the string that is provided to you. For example, you don't know what a user would enter into your console if you provide the software to your user. However, you could still cut apart that string that the user enters using this method. Now, obviously, there could a few things go wrong. For example, if the string doesn't have 15 characters. So let's run this and we will try to access an entry that does not exist. So here it says string index out of bounds exception, which just says range 1511 out of bounds for length 11. So we are trying to access the 11th index, but even that already doesn't exist. So even here we are already getting an error. So if we had this empty space in here, now we have index 11. So now it will crash a moment later. So here it says out of bounds for length 12. So now it's trying to access it at another point. So at this point here, it's trying to access 15, but it just doesn't work because, well, the sentence isn't long enough or the string isn't long enough. Now, obviously, there are ways to modify your code so it doesn't crash if something like that happens, or you can limit what the user can enter and so forth, but more on that later in the course. For now, just understand that you can break down strings using the substring method. So that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at how we can replace a given character with another character inside of a string using the replace method. So let's have a look at this. So we have this phrase, the quick brown fox here, for example. And what I want to do is I want to create a new phrase here. So new phrase, which will be based on phrase. However, I'm going to replace the O with an A. Now I need to add a comma here. So also need to add a semicolon here. So what this will do is it will replace every single O inside of phrase, inside of this string, with an A. All right. And now let's display the original phrase was phrase. And now let's display the new phrase using the new phrase like so. Now let's run this. And we should see that the original phrase is the quick brown fox. And the new phrase is the quick brown fox. Brown fox. Yeah. So that is the replace method. Pretty simple. You just need to use single quotations or single quotes because what we're doing is we're replacing a char with another char. So in this case, it just goes through every single character and checks, is it an O? And if it is an O, then it replaces that portion with an A. And that's what happens. So if we had a quack brown fox, it would now become the quack brown fox. There we are. So that is the replace method. Now there is another really useful method, and that is if you want to change the case. So we're not talking about any legal cases here. We're just talking about the uppercase, lowercase. So let's modify this. So here I'm gonna have a replaced upper string. So string uppercase string, which will be phrase dot to uppercase. So what this will do is it will make every single letter inside of this phrase string, which we are using here, become capitalized. So if we now take this here, capitalized phrase, and we use our uppercase string like so, we should get an entire sentence here, capitalized phrase, the quack brown fox. Now it also works the other way around. If we use to lowercase, so here string, lowercase string, I'm going to use the default phrase to lowercase. So here I'm using the original phrase, the quack brown fox, and now I'm making every single character in it lowercase. And there's only one uppercase character in the entire sentence. However, I'm going to change that to a lower t as well. So here, lowercase phrase, and I'm going to use the lowercase string here. So let's run this, and we should see that it says though with a lower t, quack brown fox here for the lowercase phrase. So these are some very useful other methods that you can use when it comes to strings. So you see there are plenty of them, and you start to get a feeling for strings, I guess. And you also start to get a feeling for methods now that you have seen so many of them. So that's it for this video. See you in the next one. All right, so now let's look at string formatting because, well, while we're at strings, why not go deeper? So string formatting allows you to create strings that incorporate variables or expressions and present them in a specified format. This is useful for creating readable and well-structured output. So there is this method called format. So this method allows you to format strings using placeholders. These placeholders are replaced by the variables or expressions you provide, allowing you to construct complex strings with dynamic content. And the cool thing is we can format numbers using this. So number formatting involves controlling the appearance of numbers within strings, such as specifying the number of decimal places, adding commas for thousands, or applying other numerical formatting conventions to enhance readability and precision. So let's look at that in action. So let's assume we have this variable called string name or of type string that is with Alice as the name variable, and let's say Alice is 30 years old. And now I'd like to create a message that is based on Alice's name and her age. I could go ahead and say string format and then say something like hello, comma, and then the percentage sign S here, which will allow me to use a string at this position. You are percentage D years old. Now, after the string literal here, so after this part here, I need to add a comma, and at this point I can add the variables that I want to use for S and D. So S, as I said, is a string and D is an integer. So here I'm going to use name and age. So this will replace this S for whatever the name variable is, and this percentage D will take whatever age is and put that in here. So if we now take this message, and we need to make sure that we have a semicolon at the end. If we now take this message and display it, so system.out.println with the message, we're going to see what's up. So it's going to say, hello, Alice, you are 30 years old. So this, what we do here with this format method is string formatting. So we are formatting certain aspects of our string to follow our desired structure, where again, percentage S stands for strings and percentage D is for ints. So how can I now modify if I, let's say, have a floating point value and I want to modify that as well? So let's say we have this double, which is the price for something. So double price is equal to 1234.567. Okay. So now the precision here is higher than you would usually see a price. So if you see a price in dollars, usually you would see it's $1,234.56 or 57 cents, depending on whether you're rounding up or you're just cutting it off. Okay. So if we are displaying this 7, it's a little weird, right? If you look at the price and you see the 7 there, it would be confusing. So how can we format our string so that it doesn't display the price as it is here, but it displays it correctly with just 2 points after the decimal point? So, well, therefore we can do the following. So we can say formatted price, and that formatted price will be string.format. And here we're saying the price is, and then we use a dollar sign, percentage sign. So this dollar sign is for the amount of dollars, where this percentage sign is indicating, okay, string formatting is going on. So replace whatever I'm entering next with whatever you give me after this comma here. So I want to use this price here. And now I can define how many decimal points I want to have. So I can say 2F. This will leave us only with 2 digits after the floating point. All right. So let's display this formatted price. So system out the println formatted price, and let's run this. And we'll see the price is $1,234.57. So it even automatically rounded up for us. So if you have a result of a calculation and you want to display that, and the result is a very weirdish number or a super long decimal number, and you want to modify it that it only displays a certain amount of values after the floating point, that's what you can do here. So .2f limits it to 2 digits after the decimal point, and let's say 1 would limit it to 1 after the decimal point. So here $1,234.6. So this is really off. You wouldn't want that, but just for you to understand how this works. All right, and with that, I think we've worked enough with formatting strings. So that's it for this video. See you in the next one. And that wraps up another day. So today we took a deep dive into string manipulation and comparisons, learning how to work with strings in different scenarios. Tomorrow, we'll shift gears and talk about setting up your Java development environment. We'll move beyond JShell and online IDEs and explore how to install and work with an integrated development environment, an IDE, in this case, IntelliJ. So I'm telling you, you don't want to miss this. So come back tomorrow and get started with a very powerful tool, IntelliJ. Welcome back. Today, we're stepping away from theory and diving into setting up your Java development environment. We'll start with a brief introduction to IDEs, why they are important, and the benefits they offer when developing programs. We'll then walk through the installation of the JDK and an IDE, specifically in this case, the IntelliJ IDEA. You will learn about key IDE features like auto-completion and refactoring, which can save you time and make your coding more efficient. By the end of the day, you'll be able to create, run, and debug Java programs in IntelliJ. And we'll finish up with an exercise, a budget tracker plus, to practice what you've learned. So let's get into setting up your environment. All right, so today we're going to say bye-bye to JDoodle and hello IDEs that we can install on our PCs. So let's have a look at what an IDE is and understand them a little better, and then install one and also use it throughout the day. So before we can use an IDE, we need to install something called JDK, at least when we want to develop for Java. So the JDK, or Java Development Kit, is a crucial tool for anyone wanting to create and run Java programs. Think of it as a complete toolkit that provides everything you need to develop Java applications. It consists of several components, each serving a specific purpose to help you write, compile, and run Java code. So why do you need a JDK? Well, you need it to create Java programs, and the JDK provides the necessary tools to write the Java code. Now, you also need it to run Java programs. It includes everything needed to execute and test your Java programs on your computer. And then you need it also to find and fix errors. So the JDK comes with tools that help you identify and correct mistakes in your code, ensuring your program runs smoothly. Now, setting up the JDK is different depending on the operating system that you're using. So I will share the slides as well as the links to those installation files, and you can then follow these instructions. I will show you, however, how it's done on Windows while installing the tools with you. So then the next question really is, what is an IDE? Well, IDE stands for Integrated Development Environment, and it is a software application that provides tools to facilitate writing and testing code. And this in general saves you a lot of time and streamlines the development process. And what's also important is that when you're working with other people, an IDE standardizes the process of development for the entire team. And this is really crucial because otherwise it would be really a pain to work together, and IDEs really make your life so much easier. Now with the event of Gen AI, IDEs have become even more powerful, helping you to write your code significantly faster. Generally, just making your life a lot easier as a developer. Now let's look at a few popular IDEs out there. The one that we're going to use is IntelliJ IDEA. It's developed by JetBrains, and it's a powerful tool for Java and Kotlin development. It offers a smart editor, robust debugging tools, and a wide range of plugins. It's been around for over 20 years, making it a reliable choice for developers. And then there is Eclipse, and Eclipse is another mature IDE that is feature-rich and free to use for businesses. It's a great choice for companies with experienced developers or for those working on large-scale projects, offering comprehensive tools for Java development. Then there is Apache NetBeans, and NetBeans is a free IDE that provides useful features like code formatting and code folding. These tools help you organize and manage your code effectively, making your development process more streamlined. And then there's Visual Studio Code, or VS Code. It's a newer but very popular IDE. It's lightweight and highly flexible thanks to its extensive plugin support. And this makes it suitable for a variety of development needs. And finally, there is BlueJ. And BlueJ is perfect for beginners. It's simple and easy to use, though it doesn't have as many features as other IDEs. Despite its simplicity, it has a dedicated following among Java developers. Now, what are the main features of such an IDE? Well, first of all, a code editor. And a code editor highlights your code in various colors, known as syntax highlighting, making it easier to read and understand. And we have seen that in action already with the IDE that we used, the JDoodle tool. However, it was very limited in its capabilities, so it didn't even tell us when we were missing a semicolon, for example, or it didn't give us any recommendations as to how to name our variables. And that's what an IDE usually can do, or at least the one that we're going to use. Then there is syntax highlighting, and it displays code parts in different colors to spot mistakes and understand the structure of your software. And we saw that a little bit in JDoodle, but it will be a lot more advanced with IntelliJ. And then there's code completion. So code completion suggests possible completions for your code as you type, saving you time and reducing the likelihood of mistakes, because it just gives you really good names often, or it just completes an entire section, sometimes even helping you to build entire methods and, well, very often even entire classes, because it understands what you want to do. And then there's the compiler, and a compiler translates your Java code into a format the computer can understand and checks for errors, ensuring your program runs correctly. And the cool thing is that it already shows us errors while we are coding, so that we don't have to run our code before we see the errors. At least there are compile time errors, which are errors that the compiler can find while we are coding. But then there are also runtime errors. These are not so easy to find because they only happen once the software actually runs. However, finding compile time errors is already such a huge advancement in comparison to not having it, that is such an amazing feature, really. All right, I'd say that's good enough for this video. Let's go ahead and actually install the JDK as well as the IDEA, and then we can go ahead from there. So see you in the next video. Welcome back. In this video, we're going to install the JDK so that we can make sure that the IDE will work properly. And therefore, we can just search for download Java JDK, and then we will find this page at oracle.com, Java downloads. And let's go over here. So it says Java 22, Java 21, and Java 17 are available now. Now Java 22 is the available option at the moment of recording. However, next month, in my case, the next month, JDK 23 will come out. So the JDK version is connected to the Java version that is available right now. And very soon, the next version of Java will come out, Java 23. And it will probably have a few cool features, but it's really not that big of a deal. So even if you are watching this course and Java 30 is out, everything that you are watching all the way until the latest portions of the course will not be impacted by this. At least the basics won't be impacted at all, because the basics have been the same for the last 15 years. So nothing has changed there. All right. So that's why you shouldn't worry about that. However, let's just go ahead and install the available version to us. So I'm going to go over to Windows here because I have a Windows PC here, and I'm just going to download the x64 exe here, this one right here, JDK 22 directly on my PC here. So the x64 installer. I'm going to start running the exe. Then this window pops up and we can just go through the installation process. I'm going to leave the location default and get going with the installation process. So then once it's done, and the installation is finished, you can go ahead and close the JDK installation process. And next, what I'm going to do is I'm going to search here for edit system environment variables. Then just to make sure that everything was installed properly, you go to the advanced tab, environment variables, and right here, you need to create a Java variable. Once you're here, go over and click on this new button underneath your system variables. And here I'm going to enter Java underscore home, all capitalized. And then I'm entering the directory where my Java folder is. And it's under Java JDK 22. So this is where I have installed my JDK. So I just went over to this folder and now I'm going to select this path here and I'm going to enter it right here. And this is really dependent on where you installed it. So I hope you did install it on the default folder. Otherwise, you just have to select the JDK folder wherever you install it and press OK. Now we can click OK here as well on the environment variables, as well as now go over to enter CMD here at the search, or you can press the Windows key on your keyboard and search for CMD or command prompt. And the command prompt should open up. And here you can search for Java or enter Java empty space dash version. Okay, exactly like that. No further empty space after the minus sign or the dash here. And then you should see that the Java version now is in fact installed on my machine saying Java version 22. So that's perfect. So now I have this Java version installed on my PC and I'm good to go to write software directly on my PC. And I don't even need an IDE for that. And I will show you why that is or how that works in the next video, where we're going to write our own software in our text editor just to see how painful it is, because yeah, I'll tell you why there. Okay, so see you next video. Welcome back. So in this video, we are going to see how we can execute Java code without any other software than what we have installed. So with this JDK that we have installed, without a browser, well, we need a text editor, but that's it. So why do I want to show you this? Well, in order to show you how much better an IDE is. And in order to really appreciate it, first of all, we need to go through the pain of building or writing code manually without any help, without any IDE, without anything. We just need to do everything manually, so to speak. And this reminds me of a scene in a video game that I played a few years ago, and it's called Mafia 2. And in that game, there's this gangster who comes out of prison, and then he wants to become a good citizen, so he gets a job at a harbor or something like that. And his job is to bring like packages from one place to another, like just carry them over. They're very heavy and he just has to walk 50 meters or 100 meters. So let's say 300 yards or whatever, 300 feet or something like that. So this guy is going through this pain, but you are playing that guy. So you are carrying the packages, right? And or these cartonages, and they are heavy and it takes forever. So you're walking there for a few minutes. It feels like hours because it's such a boring game at that point. And at that point, you also like, screw this. I'm not going to do that again. I will become a gangster again. So this guy becomes a mafia gangster, whatever. So why am I telling you this? Well, I'm telling you this because I feel like writing code all manually without any IDE, without any support is a little bit like this guy carrying these boxes from A to B. And it's boring and it's not fun. So in this case, let's go ahead and make it fun. Therefore, let's go ahead and create a new document here. So a new text document, and let me actually do it here. New text document. And let's call this one Hello World. And let's make sure that the ending is in fact Java. All right. So we changed the file type. And now let's just make sure that we edit it with our editor. So right click edit. And now let's type in our code for Hello World. So we need to go ahead and create a public class main with opening and closing curly brackets. Then we have to have the main method. So public static void main. where we pass in a string array of args. Then we need to have our method, which we now can go ahead and enter some text in here. We can say something. Let me actually make it bigger so you see it better. So here we can go ahead and say system.out.println hello world, like so. And while I was typing this, so many things can go wrong. I could misspell a character. I could misspell anything. And let me rename this class to hello world. So the class is now going to be called hello world. So if I misspelled anything here, it could crash or it could not work, right? And I wouldn't even know. So now let's save this file with Control S or just close it. So now at this point, while we are in this folder, go up here and type cmd, and this will open the command prompt at the folder that we're at. In my case, it's tutorials Java-24 or 2024 projects. Okay. So while I'm in this folder, now I can go ahead and create my hello world project or class that I can then execute. Okay. So I need to enter javac and then the name of my file exactly. So capital H and capital W, at least that's the file name in my case. Press enter. And then you see this class file is created for me. And now at this point, I can now go ahead and just enter Java and then hello world without the .java, without the .class or anything. Press enter and we will see that my class hello world has been executed, in fact, and it says hello world. So it printed it out onto my console directly here. So into my command prompt, so to speak. So this is my console here. And you've seen it has been quite a task. Now, obviously I can go ahead and edit my Java file here. So open, edit, I can say hello world, but painful. Okay. Now save this and let's go through the same process again. Enter cmd and then here javac hello world.java, then java hello world, enter, and you see hello world but painful. Okay, so this is pretty much what you can do in order to write your own Java code and execute it without any IDE. You see, it's not that great. So let's now install an IDE in order to really appreciate what the IDE does for us. Okay, so thanks a lot for watching this video and see you in the next one. Welcome back. In this video, we're going to install IntelliJ IDE, which is an IDE that we're going to use throughout the course. It's really powerful. It has all the features that we need in order to write software very efficiently. And when you go to this website, jetbrains.com/idea/download, you'll come to this part where directly jumped to the section Windows for me because I have a Windows PC. If you want to install it for macOS, you just go over here and install the right version from here, and for Linux the same thing. However, we're not going to use this ultimate version. We are going to scroll down and install the community edition, which is free, built on open source. So we don't need to worry about paying anything or any trials or registering for the paid version or whatever. We can just get the free version, and they're committed to giving back to our wonderful community, which is why IntelliJ IDE Community Edition is completely free to use. So let's go ahead and select the exe file. Well, at least I'm using the exe file. If you are using an ARM CPU, then you would use the ARM64 version here, but I assume it would take that automatically for you. Anyways, you can just take the exe and let's go ahead and download the file. All right, so let's go ahead and download this exe file. And once it's downloaded, click on the exe and start the installation process. All right, and there we are. So welcome to the IDE. We can select the default folder, at least that's what I'm going to do. And it's 2.4 gigabytes that you're going to need on your hard drive for this to be fine. So you can create a desktop shortcut if you want. It will also update the path variable, which we already created, right? So I'm going to say that it will have associations with Java files. So once you click on the Java file, it will automatically open the IntelliJ software. You can also decide to check any other check marks here. I'm just going to leave it at that. I'm going to call it JetBrains and let's go ahead and install it. This installation process will then take a little while, and once it's done, we can click on Run IntelliJ IDEA Community Edition and click Finish. Then this user agreement pops up, so you can read through it, and once you are fine agreeing with it, you can click on Confirm and click on Continue. If you're not fine with it, then you might not be able to use it. So you can send anonymous statistics, and then once you're there, we can import settings, but I'm going to skip the import here, and there we are. So welcome to IntelliJ. All right, and there we are. So it says, welcome to IntelliJ. And at that point, I'd say, let's take a break and come back to this in the next video. Welcome back. In this video, we're going to create our first new project using IntelliJ. Now, once you open IntelliJ the first time, you will find this window here where it says, welcome to IntelliJ IDEA. And you can just click on New Project. However, you will find something really cool here at the bottom where it says, take a quick onboarding tour. And it is pretty cool if you will have at all some experience as a coder. If you have no experience whatsoever, this will be overwhelming because it shows you things that you have never heard of before, such as, for example, debugging, and it even generates a piece of code for you that has an error in it. So it really guides you through fixing that error. But I would say this is a little too early to go through. So what we're going to do for now is just customize a little bit before we create the project. So you see there is this projects tab as well as the customize, plugins and learn. And under customize, there you can change the appearance. I personally always prefer to use the dark theme. However, if you want to use a light theme, you can do so. I just personally really prefer the dark theme because it's less straining on the eyes. Then you can also change the font, so the text size of every little piece of text on this screen. And I'm gonna go with 16 because the text of the IDE should be big enough for you to read it well, all right? Even if you're watching it on a tablet. That's why I'm selecting 16. I tried 18, but then it doesn't fit into the screen anymore. So this screen is then really not fitting in anymore. So then you can change the key mapping if you want to, but that would also go too far. Now let's go ahead and actually create a project. So we go over to projects, we create a new project here, and you see this window pops up where it says new project, and it automatically selected Java here. So there are other ways of creating projects. So you could create a Kotlin project, a Groovy project, an empty project. However, I'm just going to go with the Java project, and I'm going to call this one Hello World. All right. So this Hello World project will be stored inside of this location, which I have selected. So you can click on this button here and select a different folder if you feel like it. Then there is this Git repository that you can create. We are not going to go into Git for now. And then the build system. So the build system, well, basically it means that there are different ways how the code that we are writing can be interpreted. And there are different builders that will interpret it for us. And IntelliJ is just the one that we're going to use because it is great. And as we're using IntelliJ's tool, so let's just also use their build system. Then when it comes to the JDK, it was automatically selected for me. So the JDK that we installed 2 videos ago, I think. And if it is not here, you can also download the JDK or add a folder where you have a JDK installed. But the default one that it found for you, if you followed the course so far, should be fine. So if it's 22 or 23 or whatever version it is. And then we can add sample code. We can also generate code with onboarding tips, but that comes back to what I said earlier about this really cool onboarding feature that they have, that it's a little overwhelming at the starting point. So I'm just going to go with the sample code for now. And there are some advanced settings that we can set up, like the module name, content root, and so forth. I'm not going to go over that because it's really not going to be too necessary to go into that this early into the course. So let's go ahead and create this project. And then what you will see is that the project is being built for us real quick. And then in my case, it says Microsoft Defender configuration. It has detected that there is real-time protection enabled. It might severely degrade IDE performance. So you can activate automatically if you don't want to manually each time accept the execution of a new project that you're building, which will make it easier for you. So then when we are on the screen, there are a few things that we will see. So on the left-hand side, we have a few tabs. So one of them is this project tab where we see all of the files that are in our project. So by default, there is this folder Hello World. This is the project folder for our project that we created. Then there's also automatically a source folder with a main file, which is our main class. And it even created a git ignore, which is just a file that we can use in order to say, okay, this piece of the code should be ignored if we upload something to Git. But again, we're not touching Git yet. Okay, so then there are a bunch of external libraries, and these external libraries, they are using our JDK 22. So that comes back to us having to install this JDK so that we can execute Java code and we can use methods and classes. So there are basically a bunch of libraries here, and I'm not gonna go too much into that. But for now, let's really focus on what we have here in the center, because that's where we're going to code. So I'm clicking on this project icon here on the left-hand side in order to have my entire main.java file as the main focus of my project. So in order to make this text a little bigger, I'm just gonna go over at the top here and change the settings. And here I'm going to search for font to make the text bigger. And here there's this font size that I'm gonna go over and change to, let's say 20. It's probably still not enough in my case. So 24 should be good enough. And now you should be able to see the code quite well. So we have our public class main, public static void main, and inside of it we have system out print line hello world. So this is nothing new. This is code that we have used in the past, but it was automatically generated for us. So let's run it real quick in order to see what's up. So then you can see that here at the bottom it just says hello world, which is the text that we have written right here. So if we change that and we change that to hello student, and we run it again, this text at the bottom should change and it says hello student. So there we are. Now we have our IDE ready to go. Now we can code along, and it is going to be faster than what we had with JDoodle. However, we needed to do all of this setup in order to get here. So with that out of the way, let's go over to the next video. All right, so now let's look at why using this IDE is so cool. And I will show you a few things. So first of all, one thing that I really love is the fact that you can hover over something and it will open up an explanation of what's going on. So for example, if I hover over system, or I click into system and hover over it, then it says the system class contains several useful class fields and methods. It cannot be instantiated, whatever that means, we're going to see that later. Among the facilities provided by the system class are standard input, standard output, and error output streams. So we have used the output as well as the input. And access to externally defined properties and environment variables, we have not touched on that yet. And a means of loading files and libraries, and a utility method for quickly copying a portion of an array. So then you can also see since when this existed. And you can see that it has existed since Java 1.0. So this class has been around forever, since the very beginning. And it's inside of java.lang. All right, so this is the package where this class system is residing in. Now, if you hover over out, you will find some additional information. It says the standard output stream. The stream is already open and ready to accept output data. Typically, the stream corresponds to displaying output or another output destination specified by the host environment or user. So you can obviously go deeper through it, but one of those out features or methods that we can use is println. And when you hover over it, you can see also println, print boolean, print char, and so forth. So you can see this println method accepts booleans, it accepts chars, char arrays, doubles, floats, int, longs, and so forth. Some of them we don't know yet, so we have not seen what a char array is, neither have we seen what an object is, but all of the other data types we know. And we have seen that because we did not only enter text in here, sometimes we just entered a number in here and it worked, or we just entered a variable in there or put a variable name in there, and the variable was of type boolean. So we just stored a boolean in a variable and used it in println, and it just used the method println that corresponds with the according data type. All right. So what does this println method do? Again, you can just hover over it and it just says print a string and then terminates the line, which just means that it creates a new line, so to speak. This method behaves as though it invokes print and then println. Okay, interesting. And params x, so it says, okay, you can put something in between the parentheses, which is a string, and it says x is the string to be printed. So it will print whatever we give it inside of the parentheses. And we've seen that, right? We played around with it quite a bit. So only because we're in an IDE now, in another, and not in JDoodle, doesn't mean that the code is changing. It only means that we have a bunch of really cool tools available to us that will make it a lot easier to code. Now, the cool thing is, for example, what very often happened when I was recording in JDoodle is that I forgot to use the semicolon or write the semicolon at the end of the statement. Now, here I can directly see that there is an error. I can see it up here where it says, okay, red exclamation mark or circle with an exclamation mark. I can see it over here where it says, hey, this is where the error is. And I can even see it over here where it says, okay, in this line, there is something wrong. So it even tells me what is expected. It says a semicolon is expected. And it even gives me the possibility to just click on this insert semicolon, and it will do that for me. So if I make a mistake in my code, it just tells me that there was a mistake and even gives me a recommendation as to how I can fix it. Sometimes there are multiple recommendations possible. It depends on the situation, but very often it's just one, and that makes it very easy. So now it's similar to the comparison to you having to write a very long text with your pen at school, for example, or you can write it out on a typing machine where the typing machine gives you recommendations if you type something wrong. Okay, so that's what happens here, only that it's a lot smarter and a lot more feature rich. Then we have coloring, right? So keywords like public and class, which are specific keywords of Java, they are colored in this orange color. Then whenever we're using a string, it is colored in green. Whenever we're using a comment, it is gray, at least in the dark mode. So here I can say, this is a simple console output. And we can see that this code will not be executed, so it doesn't do anything. There's nothing happening here, and it's grayed out. That's because it is a comment, okay? So when you want to know more about something, you can click here, and it will give you some replacement options. So in this case, it says replace with block comment. So for example, I could just replace this entire statement with a block comment. Now, what is a block comment? Well, a block comment is just a different way to comment. The only difference is that the block comment allows me to comment over multiple lines. And that's the difference to a single line comment. So this is a single line comment, and this here is a block comment, okay? So this is just an example as to what the IDE can give you recommendations on, and we're going to see a lot more of these when we're coding. So see you in the next video. Welcome back. In this video, I want to show you something else that is really powerful that comes with IntelliJ, and that is auto-completion. So let's have a look at what this means. So let me get rid of the code that we had before, and now let me just try to do the print out statement. Okay, the print line statement. So I just entered capital S and it already gives me system as an option. So there are many options of S classes that I could use, but I'm just going to use this system class. Then I enter a dot and it automatically comes up with out, for example, which is exactly what I was looking for. And then it gives me print ln or print. So I barely had to type anything and it just went ahead and gave me everything I wanted. So now I have the system out print line statement, and here I can write whatever I want. So give me some more tips, for example. All right. So there we are. This is auto-completion in action. All right. And now I want to show you something else, and that is how you can close the project in order to create a new project. So you can obviously just close the IDE. So you have this hamburger menu here at the top, which opens up this menu bar, and then you can select close project from here. So it's this one here, which will then close the project and will send you back to this screen where you can move to the existing projects that you have had already, that you built in the past. And you can go ahead and create a new project from here, or you can even open external projects that you have not built yourself, but you have downloaded, for example. So at this point, we could go ahead and create a new project, but that is something for the next video. So see you there. Welcome back. In this video, we're going to create a new project, but this time we're not going to add the sample code here. So let's call this one Magic Potion Calculator. Okay. So this will be a new project and I'm going to call it like that. And you see I'm using camel case, but I'm starting with a capital M here as well. And I'm using Java as well as IntelliJ, and the rest is deactivated. So let's go ahead and create this project. So what you will find is that this project doesn't have any Java files in it. And now at this point, let's go ahead and create our own class inside of this source folder. So right click in this src folder, the source folder, then select Java class and give this class a name. And I'm going to call this one Magic Potion Calculator, like so, and press enter. And this will then create the class for me. So then let me get rid of this project here. And you see that we have this public class Magic Potion Calculator with the curly brackets, and we didn't add anything else in here. So we don't have a main method in here, which is the starting point of our project, right? So we need that. So let's go ahead and add that public static void main, and then let's add the string arrays, or string with curly brackets, args, and string needs to be capitalized. So you see the IDE directly tells me, hey, there's something wrong. And once we have that, you see this run button suddenly appears. So now we can run our project from here, or we can press Shift F10, and all of these great options that we have available to just start running this application. So now what I want to have is a few variables that I need in order to calculate the potion power. So the strength of my potion. So I'm going to create a few integers. I'm going to call this one magic essence. Then I'm going to have another int, which will be dragon scales. So how many dragon scales am I putting in there? Let's say 2. And how many unicorn hair do I put in there as well? All right. So based on that, I'm going to have an int that will calculate the potion power. So potion power will be, and you see, I just press M and it already gives me magic essence. So I can just press either tab or enter and magic essence will be written out for me, multiplied with, let's say, the dragon scales. So I just enter D and it already knows, okay, either I want to create a double or I want to use dragon scales. So I'm going to press enter here or tab. And then I'm going to add unicorn hair to it as well. So you see, the IDE really makes my life so much easier. And now at this point, there's also something very interesting to see. And that is that the names of variables that I am using somewhere are white or in white color. And the ones that aren't are grayed out or are gray. So potion power is never used. So if you hover over it, it even says potion power is never used. So then it tells me remove local variable potion power. That's one of the options that it gives me, but I won't do that because I actually want to use it. So I'm going to use system.out.println, and I'm going to say the power of the potion and then plus potion power, like so. And at this point, we have our little software that is our potion power tool. So let's run it. It will calculate the potion power. And it says the power of the power. Well, the power of the potion is potion power. So we can either run it from here, we can run it from there, many different ways. So once we run it, we will see that we get the details here inside of our console. So you can toggle this run button in order to get rid of this run, and this will just hide it. Or you can also close Magic Potion Calculator, but then the run portion here will go out or go away entirely. So if we run this again, you see it starts to appear again and it's back where it was. All right. So that's pretty much it for this video. And now you will have an even better feel for what's going on with the IDE that we have installed. And I believe you start feeling why this is such a powerful tool to use. In this video, I want to show you another thing that is really useful, and that is how to rename things. So sometimes you need to rename either a class or a variable or something like that. And the problem is if you only rename it at one spot, but it is used somewhere else, you will run into problems. And that's where the IDE can help you really get around this. So I'm going to call this one renaming, and let's go ahead and create a project with sample code here. So let's say we have a bunch of variables in here. So I'm going to call, well, I'm just going to go over and get rid of this project here on the side. So system out is nice. So I'm going to have a variable. My var is 15. It will be an int, and my var2 is going to be 16 or something like that. And later on, I'm using my var inside of this project. So I'm just going to use it like so. All right. So now let's say I realize, oh yeah, well, my var is not really such a descriptive name. So what should it be? So should it be the age, or should it be something else? Like it has a name that is really useless. So now if I want to rename it, I can right click it and I can go over to refactor. I have to move my screen a little bit here on my app. So I go to refactor, and then there is this rename option here at the very top. And then I can just type in whatever name I want to use here. So let's say I renamed it to age. So you see here, age suddenly is also renamed here at the bottom right. So once I press enter, the age variable has now been renamed at all spots. So in this case, only 2 spots at the declaration as well as the first usage. But it's not always that simple that I can even see it on the same screen. Sometimes if I have variables that are used throughout multiple classes, multiple files, multiple different projects even, it's really very painful to do it manually. So it's a lot easier to just rename it directly with the IDE, and it makes sure that the variable names are changed properly. So now I want to rename the name of my class here as well. So the thing is, if I do that, so I refactor it, click on rename, and I call this one, let's say, best class ever, you will see that it also has changed here on the left-hand side in the source, so in the project hierarchy. So it also renamed the file, because this here is technically a file called bestclassever.java. So if I right click here and I go over to open in Explorer here, you will find that this is actually a file that exists on our PC inside of source renaming. And renaming is the project name. Okay, so that was the name of the project. So that's it for this video. I just wanted to show you that this feature exists, and this is another really cool thing about using an IDE. There are plenty more, but I'm not going to talk about it like that anymore because I think you got the point, right? IDEs are amazing, and especially this one, I really like IntelliJ. I've been using it quite a bit for Android app development as well with Kotlin, so it's really powerful there as well. So that's it for this video. See you in the next one. All right, so I hope you tried to finish the exercise. Let's go ahead and build it. So first of all, let's go ahead and create a new project, and I'm going to call this one Budget Tracker Plus. And I'm going to leave everything else as default, or at least here add sample code. Let's go ahead and create that project. And the next thing that I'm going to do is I'm going to rename the main class here. So refactor, rename, and I'm going to call it Budget Tracker Plus. So now what do we want to do in here? We want to ask the user about a bunch of things. So we want to get the user input about the rent, about the monthly groceries, transportation expenses, entertainment expenses, and the income. So we're going to start with the income. And therefore, I'm going to let the user know that I want to know the income. So here, please enter your monthly income. And I'm going to use dollar here. And by the way, we can use print here. We don't need to use print ln, because the user can then just enter it directly at the point where this dollar sign comes in. And I want to get the user input. So when we want to use user input, we need to use the scanner class. So I'm going to create a scanner, new scanner, and here system.in. Now the cool thing is the IDE automatically added this line for me. So I have this import here at the top where it just says Java util scanner, automatically added for me. Very powerful. Now please enter your monthly income, and then we can use that scanner in order to get the monthly income. And you can do it with an int, that would have been fine, or you can do it with a double. So we can be as precise as on a cent level. So I'm going to say double income is going to be scanner dot next double. Okay. And then we are going to ask for the rent. So I'm going to say, please enter your rent cost. This one will be rent. Then we're going to do the same thing. Please enter your groceries expenses or expense, like so. And I'm going to call this one groceries. Now let's do this again, but this time for transportation. Now you could obviously call the variable transportation expense as well, but that should be fine. So here I'm gonna do the same for the entertainment, and this will be entertainment. So now we have all of the costs. So let's put them all together. So we're gonna say double total expenses, and that will be rent plus groceries plus transportation plus entertainment. So all of those combined will be the total expenses. And now we want to know the percentage of income spent on each category. So how much was spent out of the total income on rent, out of the total income on groceries, and so forth. So I'm going to create a bunch of variables for that. So double rent percentage, which will be the rent divided by income multiplied with 100. Now it's important that I put it together in the right order. So I'm just going to say first calculate this. So rent divided by income and then multiply by 100 because we want to know how many percent it is, right? Percent means per 100. Cent is 100 or centime or cent, whatever, depending on the language, but it comes from Latin. So that's the rent percentage. Now we're going to do the same thing with groceries. And here groceries, then we do that with transportation, and we do that with entertainment. So now let's take the names in here and replace them accordingly. So now we have all of those percentages, and now it's all just about printing it out onto the console. So therefore I'm going to say system.out.println. And here I'm using a \n so that I create a new line, and I'm going to say something like budget summary and a bunch of stars again. So this creates a break in the visual, so to speak, so that we are saying, okay, now comes the interesting part. All right. And at this point, I'm going to use system.out.printf because I want to use formatted printing. So here I'm going to say monthly income is going to be $, then .2f. So we want 2 digits after the decimal point and another line break. And then we're displaying the income. And now we're going to do the same thing for the expenses, monthly or total expenses. So total expenses. Then we're going to say system.out.printf remaining budget is $, and here I forgot the percent sign. There we are. That's why I had this error. Percent sign .2f with another / for another row. Here I want to use the remaining budget. Let me see. Did we create the variable for that? I think we didn't. We have the total expenses, so let's create a double for that. Double remaining budget, which will be income minus total expenses. So that will be our remaining budget. This one here. We mustn't forget the semicolon at the end. And then let's have another system.out. This time print line. And I'm going to say expenses breakdown. Just looks a little nicer. And then we can go over the percentage of rent percent, grocery percent, transportation percentage, and so forth. So system.out.println, and we're going to say rent is going to make up a percentage. And actually println is not the way to go, it's printf. So percentage dot 2f, 2 decimal points, is going to be the percentage dot 2f percentage of income. And then I'm using \n here for a line break. So What's going on here? This one is a little tricky. So here we're just saying, okay, this is the total rent amount. And here we're saying this is the amount in terms of percent. Okay. So we can go and say rent and rent percentage like so. And now let's do the same thing for groceries are so and so. And this one is here going to be groceries and groceries percent. Now do it again for transportation. This one will be of transportation and, oh, wait a second, of income, but here it says transportation. And this one should be transportation percentage. And now finally, once again, this one will be entertainment of income and entertainment, as well as this variable here, we will replace with entertainment percentage. And with that, we should be able to run it. If we see any errors, we can fix them. So let's run it. Please enter your monthly income. So let's say, well, so go down here. So let's say 5,000 USD. Please enter your rent. Let's say it's 2,000 USD. Please enter your groceries. Let's say 800. Transportation, 400. Entertainment, another 400. And let's see what we have here. It says monthly income 5K, total expenses 3,600, remaining budget $1,400. Expenses breakdown 2,000 rent, 40% of income. Groceries are 16% of income. Transportation is 8% of income, and entertainment is 8% of income. And hello world. So yeah, we can get rid of this hello world line here at the bottom. But yeah, I think you get the gist, and I hope you were successful in building this. And I believe breakdown, yeah, I had this M in there, not so nice. So that's it for this video. And now you should get a feeling for how to use the IDE and how to use print statements, how to use variables, all of that good stuff. So that's it for today, basically, and see you tomorrow. So nice work today again. You have learned how to set up your Java development environment. You installed IntelliJ and explored some of its key features. Now you're ready to write and run more advanced programs with ease. Tomorrow, we'll be diving into control statements, starting with if, else, and ternary operators. These are fundamental to controlling the flow of your programs. So come back tomorrow and become a pro at if statements. Welcome back. Today we'll be covering one of the most important topics in programming, control statements. We'll start with the if statement and gradually work our way through more complex forms, like nested if-else and the if-else-if ladder. You'll also learn how to use logical operators to make your conditions more precise. Later, we'll introduce ternary operators, which allow you to simplify certain conditional expressions. We'll have an exciting exercise today, the Galaxy Weather Advisor, where you'll use control statements to forecast the weather for planets in our solar system. By the end of today, you'll have a solid understanding of how control statements work and how they can help you make decisions in your programs. Let's get started. All right, so finally we're going to start with real programming. Everything so far has been basically just setting up variables and using the console, but now we're going to add conditions to the mix. So we're going to look at conditional statement operators. And conditional statements are programming constructs that allow the execution of certain code blocks based on the evaluation of Boolean expressions. So if something is true, the code will be executed. If false, then not. So what's important is they enable decision making in code, allowing different actions based on different conditions. So if a user is logged in, show them their feed. But if they're not logged in, show them the login page. So that's something that you would achieve with an if statement. Now, common usage scenarios are, for example, user input validation, decision-making processes, control flow management, and the types of conditional statements in Java are if statements, if-else statements, an if-else-if ladder, and switch statements. And we're going to look at them step by step. Every single one of them will be a separate demo, and we're going to go into detail with them. So the if statement works like this. So you have this if keyword, then you have parentheses, and within those parentheses, you have your condition, which needs to result in either true or false. And then within the curly brackets, that's where you add the code that should be executed if the condition is true. If it's not true, it will just go to the end of the statement and just keep on going with the next line of code. Then the code block execution is basically the block of code inside of the if statement. It is executed only if the condition evaluates to true. Then there are if-else control statements. So if-else control statements allow you to execute one block of code if a condition is true and another block of code if the condition is false. This provides a way to handle two possible outcomes. And then there are also nested if-else control statements. So nested if-else statements allow you to check multiple conditions by placing if-else statements inside other if-else statements. This is useful for situations where you need to make a series of decisions. And don't worry if you don't fully get what's going on here, we're going to practice this quite a bit, so you will become a pro at this by the end of the day. And then there is the if-else-if letter. The if-else-if letter allows you to check multiple conditions in sequence. When a condition evaluates to true, its corresponding block of code is executed, and the rest of the letter is skipped. If none of the conditions are true, the final else block is executed. And this is a very, very important and useful feature of if-else statements. So the if-else-if letter. So if we look at the syntax here, if condition 1 is true, then this code will be executed. If condition 2 is true, then this code will be executed. And otherwise, this code will be executed. Now, you're not limited to one else if. You can have as many else if as you want. And we're going to see that as well. So in this particular example, we can see int score is 85. And we check, is the score greater equal 90? That is not true, so the person will not get a grade A. Then we go to the else if check. We're checking, is score greater equal 80? And we see, yes, it is greater equal 80. It's actually 5 greater than 80. And this means that the person, well, we will display grade B on the console. Now you might say, well, if this is true, will this also be executed? Well, actually, no. So this else block will then not be executed. So in this case, we will only see grade B on the console. We will not see grade F and neither grade A. And that's really the cool thing about if-else-if letters. So then there is the ternary operator. And I'm just going over all of the things that we're going to build throughout today. So don't worry about it if you are overwhelmed a little bit. That's totally fine, as this is really just to give you an overview, okay? So just see it as an overview. So ternary operators is shorthand for simple if-else statement in Java. It is particularly useful for making quick decisions in your code, allowing you to condense an if-else statement into a single line. This can make your code more concise and readable, especially when dealing with straightforward conditions. So if it's something very simple, we can use ternary operators. Very simply, you could say, we're checking age less than 80. So if this is true, then do this. If it's false, then do this. Okay, so in this case, by do this, we're assigning a value to this double variable called discount. And then we're displaying whatever the discount is times 100 in percent. All right. So basically what we're doing is we're giving people a discount based on their age. If they are less than 18 years old, so this person is 16, then we will give them a discount of 10%. And if they are 18 and older, then they get this discount. Okay, just 5%. So we're going to see that in action, obviously. So don't worry about it. And the syntax is very simple. We say condition, question mark, expression 1, colon, expression 2, semicolon. So that's what a ternary operator looks like. But we're going to build a few of those. So with that, I'd say thank you very much for watching and see you in the next video where we're going to get into practice with if statements. In this video, we're going to get started with if statements. So let's go ahead and create a if statement and get a feel for it. So we use this if keyword and then parentheses, and within those parentheses, that's where we have our condition. And this condition needs to result in true or false. So it means it can be a Boolean or it can be a Boolean expression. So here, whenever this if condition here is true, then the code that is inside of those curly brackets will be executed. So we can just go ahead and create a Boolean and let's say is sunny. And I'm going to say it's true because today is in fact sunny. So I'm going to say if is sunny, then let's print out something onto the console. And let's say such a lovely day, such a lovely day. Okay. So this will now execute system out print line, such a lovely day. That's because is sunny is in fact true. So let's run this and we will see it says such a lovely day. Now, you see it's underlined in yellow where it says unwrap if statement because it just says is sunny is always true. Well, yes, that's because I designed it this way. But let's say we ask the user if it's sunny or not, then we would have to convert that from a string into a Boolean. But basically, then this would not always be true. So here we use a Boolean directly. However, we can also have situations where we don't use a Boolean directly, but we create a Boolean expression. So something that results in a Boolean output. So let's say we have int a is equal to 5. And then what we check here is if a is greater 0, then we know that we have a positive number. So we have a positive number. So now let's run this and we will see the system will say we have a positive number. So then, by the way, let's also add another system statement here outside of any conditions. So this will be executed regardless, right? So this code here will be executed no matter if this if statement is true or false. So this condition here is true or false. So let's run it again and see it. And it says we have a positive number outside of any conditions. So now let's go ahead and make this a negative number just to see what's going to happen. So then it's going to say outside of any conditions. So there is no saying we have a negative number or anything like that. That's where we would need the else for. But it's really just about this condition for now, where we are just checking if a certain condition is true, then execute whatever is in here. And in this case, I'm really just printing something out. So then what we can do is we can also compare values with each other. So let's say we have string name, and we're going to set that to Dennis. All right. And we're going to say if name equal Dennis, then we're going to have the statement hi Dennis. All right, let's run this. And it says hi Dennis, and then it says outside of any condition. So we see this is one way of getting a Boolean expression. However, it really tells me I should rather use equals here. So replace equal sign with equals. So we're saying name equals Dennis. However, then it says this is always true. So condition name equals Dennis is always true. Well, because it just reads the code and understands that it is always true. However, if this is a user entry, so let's use the scanner for that. Scanner equals new scanner system.in. And you see the scanner was imported for me. And let's also make sure that we close the scanner at the end. So now if I don't use Dennis as the name, but I use scanner dot next line, then it's a different story. So you see this warning goes away because now we don't know what the name will be. So it could be Dennis, but it could also be anything else that we're entering. So let's run this and we can enter something here. So I'm going to say Frank, and it says outside of any condition because Frank is not equal Dennis. So let's run it again and enter Dennis because that's my name. So here I'm going to say Dennis, and it says hi Dennis. That's because the name variable was exactly the same as Dennis. And that's why we got this output. So you saw a few different examples as to what a condition can look like. Obviously, there are a bunch more options, but this is just a very simple one where we have seen either directly using the Boolean or comparing ints with a certain value. So an int variable with a certain value. And we saw how we can compare strings as well using the double equal sign or equals. Okay, so that's it for this video. See you in the next one. In this video, we're going to look at nested if statements. And therefore, let's go ahead and create a variable a that I'm going to set to 5 and a variable b that I'm going to set to 10. And what I'm going to check is if a is greater than 0, and then within the curly brackets, there I am checking if b is greater than a. And if that's the case, then I'm going to say system.out.println, and I'm going to state that b is greater than a. So with this comparison that we have here, we're first checking if this is a positive number, and then we're checking if b is greater than a. So you could say, okay, obviously both of them are always true. That's why I get these warnings here directly in the IDE. But generally, the idea here is to show you that only if both conditions are met, then I will get this output here. So let's run this and we will see it says B is greater than A. Now what if B was 4? Now let's run it again and we see no output is there. Now we can add an output in general. We could say here system out after if statement, for example, and let's run this and we will see after if statement is printed, but none of this is printed because while this condition is true, so A is in fact a positive number, this here is not true. So B is not greater than A because 4 is less than 5. So in this case, we get into the situation where one of the two statements is not true and the code that is executed within the nested if statement here within this one will not be executed. So this code block will just not run. So we don't get it on our console. And this is a very simple example of nested if statements. So with that, you've seen how that works. So let's look at if and else statements. Welcome back. In this video, we're going to look at logical operators because they are very important when it comes to if statements. Because the cool thing is we can use them to combine multiple conditions or have two conditions that either of those can be true, and then we can execute something based on the whole condition being true. So let's look at that in action to get a better feel for it, because it is something that we started touching on day 3, I believe, but we didn't go too deep into it. So let's look at it here. So I have two booleans. One is A, which I set to true, and one is B that I set to false. And then I'm going to have another boolean, which I'm going to call result. And what that will be is A and B. So here I'm using a double ampersand. So this ampersand will allow me to say this entire statement here is only going to be true if A and B are true. So in this case, it will be false. So this result will be false because both of them have to be true. So A and B have to be true for result to be true because I'm using the ampersand here, which means I'm using the logical AND. So logical AND. So I'm saying A and B. So A true and B true is in this case not the case because A true and B not true. So this entire statement is untrue. So how it works with AND is you have only one condition. If you are looking at two variables, you have only one condition in which it is true. So it's only true A and B are true. Only then the result of the logical AND will be true. Okay? So in all other cases, so A false, B true, result is false. A false, B false, result is false. And A true, B false, result is also false. Okay, so in either of those cases, we get into a situation where we get a false, but if A and B are true, then we get true. So when we're using the logical AND, which we are doing here. Now, if we were to compare this, so let's say result is equal to A, and we use the double pipe, this will result in true, because this is the logical OR operator. So this means that either A or B have to be true. And in this case, it is true because A is true. So if none of those two variants were true, so neither A nor B were true, in that case, this statement would be false. But in all other cases, either A being true or B being true or both being true, this statement here becomes true. So A or B true equals true. So this is something I think you learn in math in 8th grade or something like that. But yeah, I just wanted to repeat that and show you how that works in a coding context. In this context, something that is also important is the not operator. Okay, so we have seen the not operator before. I just wanted to show you once again. So let's say result not A or B. And here we are checking the opposite of A. So if A is true, this statement here with the exclamation mark becomes false. If A is false, this statement becomes true. So we can just see that with system.out.println, and we're just going to say A is plus A plus, and exclamation mark A is, and we just say plus exclamation mark A. Okay, so let's just see that in action. Let's run this and we will see what I mean. So A is true and exclamation mark A is false. Okay, so these are the things that you will need for the next exercise, because we are comparing multiple things to each other and we want to have multiple different conditions that we are checking at once. So if we take that for an if statement, so let's go ahead and use this for an if statement. And in this situation, let's go ahead and just use two variables, int a equals 5 and int b equals 10. And then I'm checking if, let's say, a greater than 0 and b greater than a, then I'm going to say system.out.println b is greater than a. Okay, so in case that a is negative, I don't want to do that. So I'm just saying, okay, if a is negative, then I don't even want to compare if b is greater than a. This is called a short circuit logical operator. What this means is that it checks this condition first, and only if this condition is true, it will also check this condition. So only if a is greater than 0, it's even going to check if b is greater than a, because otherwise it's just going to save the processing power. Okay, so it's not going to use the processing power. It's just going to know, okay, well, I'm using a double ampersand here, so I am comparing two conditions. And if the first one is false, I don't even need to check the second one. All right. So with that out of the way, you should be ready for the next exercise, which is going to use this, but with strings. So I wish you best of luck and a lot of fun doing it. Try to figure it out by yourself. Do some research if you need to, and then see you in the next video where I'm going to show you the solution. Welcome back. So I believe at this point, every single one of us knows chatbots, right? We know something like ChatGPT or Gemini or Copilot or whatever other tools are out there. So in this video, we're going to build a chatbot, but our chatbot is not going to be super smart. It's really just going to take a very small thing into consideration and, well, a few texts, and then it will reply based on what we entered as a user. So let's go ahead and build it step by step. And this was the exercise. So if you didn't do the exercise, I would really recommend that you pause the video and try to do it by yourself, because then you are going to learn. When you are struggling and you're finding the solution, it's a great feeling, I can tell you. And it is really important as a developer to go through this, because otherwise you will not become a developer. Okay, unless you're giga smart. Maybe you are, and then congratulations, but most of us aren't. So we need to practice and go through struggling in order to really learn something. And sometimes it's a little uncomfortable, but that is fine. That is what it is about. Sometimes you need to search for a solution to an error, and it really takes a while. But once you figured it out, it will stick. So let's get started. So create a scanner object to read input from the user. All right, we know how to do that. Scanner equals new scanner with system.in, and we need to import scanner, so we can either press Alt Enter or we can add this line manually ourselves as well. Import java.util.scanner. That's great. Prompt the user to enter their input. Okay, so we can just say something like system.out.println, and we're going to say enter your prompt. Okay, let's just call it prompt, and then read the user's input and store it in a variable user input. Okay, let's go ahead and do that. Then we're going to say string user input is going to be scanner dot next line. So we take the user input. Then we're going to check if the user entered hello or hi. So we're going to say if user input is equals to hi, then, or let's say hello first, hello, or double pipe here, user input equals hi, then we're going to display a relevant response. So whatever that is. So we're going to say system out println hi there. How are you? Something like that. All right. Now, by the way, if you wanted to make sure that you ignore case, you can also use the equals ignore case method here. So equals ignore case with hello, and here as well, equals ignore case. So At this point, what would make sense is to test our application. So obviously, you can go through this entire code without testing, but I would recommend to test it. So I'm going to run it and see what's up. So enter your prompt. I'm going to say hi, and it says, hi there, how are you? Perfect, that works. So let's run it again, but this time with hello, but with a capital H. And it says, hi there, how are you? Now let's enter something different. What's up? And it's gonna do nothing. So there will be no code executed or displayed. So that is the first part. Now check if the user's input is an inquiry about well-being. So something like, how are you? How's it going? So let's do the same thing. Let's check for the user input, where we're going to say, how are you? Or how's it going? How is it? Or how's it going? Okay, something like that. And in this case, we're going to say something like, well, let's say chatbot. So we didn't do that before. We could add that here as well, chatbot colon. And if somebody asks about the well-being of the chatbot, we could say something like, I'm just a robot and have no feelings. Something like that. You probably hear that from ChatGPT whenever you ask it, something like that. So that would be a relevant response. Now here, you could have entered anything here, and it's really up to you, okay? Then check if the user input is about the weather. All right, let's do that. So we're going to check that here. Is it about the weather? So let's say we have the word weather in there, or we have the word, what's the weather like? The sentence, it's not the word, but let's put that in here. So what's the weather like? And then we're going to say, chatbot, it's a sunny day. Even though this might be a lie, and you probably have seen that with ChatGPT too. Sometimes it just lies. So then check if the user input is something about farewell or is a farewell. So let's just copy this piece right here. And we're saying something like bye, and or something like goodbye, like so. And the response of the chatbot would be bye, have a great day. All right. So then if the user input doesn't match any of the predefined options, respond with a default message. So this is a tricky one. How do we do that? Well, we need to compare all of those. So we're going to say if user input dot equal ignore case is the first one, then the second one, and so forth. So we just need to take all of these. So I'm going to take those, copy them in here. So if it's the first or the second or the third or the fourth, so I'm going to check all of those as well. So let me copy that, paste it in here. So let me just put that into a next row and also add the curly brackets here so that the error disappears. So I'm going to have the next comparison. I need to add the pipes here. We can also have them at the beginning, but that's fine either way. So we had, hello, how are you? I think the weather one we still need to add. So let's copy that piece here. So then we add the last one. So again, I have pipes here because after every single one of those, I need a pipe, okay? Or like I need double pipes. So let me copy this part here as well with the pipe by variant. Let's put that in here as well and finalize the statement. So let's look at it. So I'm going to put them one after the other so that we can see all of them properly in one screen, I'd say. And here, just need to add this pipe here like so. So now at this point, if that is the case, and we also need to make sure that we are closing the right amount of brackets, and I believe we are missing one. We're going to see in a bit if it crashes. So we're saying if either of those is true, then do something. However, we want to do the opposite. So we want to say if neither of those is true. So there are multiple ways how we can achieve that. Either we can say that we add an exclamation mark in front of every single one of those statements. So if all of those are not true, then we will say something like, I'm sorry, I don't understand that. So system.out.println, the chatbot says, chatbot, sorry, I didn't get that. So at this point, I can either put this entire statement here into another bracket, into another rounded bracket here, and I can just say the opposite of that. So I add this exclamation mark here at the front. So what I'm saying is if none of those ors is true, then run something. So here we can just say something like system.out.println, and we could say something like chatbot, sorry, I didn't get that. So now let's run this and enter our prompt. Let's say by or BS, BYS. You see, if I enter something incorrect, it says, sorry, I didn't get that. Let's enter something correct. Let's say bye, and it says bye, have a great day. So now this is one way of doing it, right? This is one solution where I put the entire statement into brackets and negate it. An alternative way would have been, let me show you that. So I'm not going to type it out. I'm just going to copy it now. Would have been this here. So we prepared this alternative route where we are saying neither this and neither that and let me actually just put those into new lines each time. Maybe it's a little more readable then. So in this variant, I'm just saying that this cannot be true and this cannot be true and this cannot be true. So all of the variants that we have covered, none of those can be true. And only then do we display something like, sorry, I didn't understand or don't understand that. So both variants are fine. I have just used this one because I just had it ready. But yeah, either way works. So with that out of the way, I hope you enjoyed this exercise and I hope you finished it by yourself. And by the way, I forgot something here. Just making sure that the scanner is closed as well. It doesn't crash our software, but it's just good practice to free up the resources. And we just close our scanner. So if we now run this and we enter our prompt and we say hi, then it says hi there, how are you? Great. So thank you very much for watching and see you in the next one. Welcome back. In this video, we're going to look at if-else control statements. So far we had been limited to just if. So the condition, if it was met, then some code was executed. But now we're going to look at the variant where we can execute something if the condition is not met. So if the condition is false, and that is the if-else statement. So let's have a look at it. So we have this if condition. So everything up to here is the same. What we're checking is the condition true. If it's true, execute the code that is inside of those curly brackets, right? So if condition is false, then the else block will be executed. And that's the whole point of the if-else statement. So now we can just say, okay, well, if the condition is true, run this code. If the condition is false, run this code. All right, so now let's just put that into an example that makes a little more sense. So let's say we have a number. So int number, and let's say I set that to 10, for example. So what I'm going to check as the condition, I want to see if the number is an odd number or an even number. How can I check that? Think about it for a second. Well, you can check that using the modulo operator. Do you recall how that works? So now that you know that it is the modulo operator, can you set up the condition to check if a number is even? I hope you tried it. So basically what we need to do is we just need to say number modulo 2 equals 0. So with this statement, we're checking, can we divide number by 2 and will there be no remainder? Because if you recall, the modulo operator just returns the remainder. So it gives us the remainder of a division. So in this case, 10 divided by 2 is 5, remainder 0. So with number 10, so if with int number equal 10, the if condition that we have here is true. So this code would be executed. So we can just say something like system.out.println, and we say number is even. Okay. And now in the other case, we can say number is odd. Okay. So let's run this and just see it in action. And we see it says number is even. So that's cool. How about we change the number? Let's say we set it to 5. Now let's run it again and we will see number is odd. So now we have a very simple program that can check if a number is even or odd. So this is just one example where this can be useful, but this can be used for all kinds of situations. where if a condition is met, you do one thing. If the condition is not met, you do another thing. So let's say it's raining. If it's raining, take the umbrella. If it's not raining, don't take the umbrella. Something like that. Or if it's below 20 degrees Celsius, put on a sweater. If it's warmer than 20 or higher than 20 degrees Celsius, don't do it. All right? Or just leave the shirt on. Just chill with a t-shirt or something like that. All right. So next, let's look at if-else control statements that are nested. Welcome back. In this video, we're going to use nested if-else control statements. And we're going to use a very simple example. We're going to check a number and see if the number is positive. And if it isn't positive, we're going to check if it is negative or 0. Because these are the three variants or three categories in which you could put a number. So let's go ahead and do that. Int number is going to be -5, for example, and we check if number is greater than 0. And if that's the case, then we're going to say system out print line number is positive. All right. So then in the else block, we're just going to say if number is less than 0, then we know that number is negative. So we're just going to say number is negative. And in this else block, we're just going to say number is 0, because we know that if the number is neither positive nor negative, it has to be 0. So that's what this else block says. So what we're using here is a nested if-else control statement. So it's nested because we have an if-else statement within an if or an else. So within the code that will be executed in either the if or the else. Now you can nest it even further. So you could go even further and say, all right, if the number is less than 0, then do this and that. If the number is less than 20, then write number is less than 20 or something like that. So we could go even further with this using nested if-else control statements. And sometimes the conditions are just so complex that you just need it. And if you look at a chatbot, for example, some people argue that the chatbot like ChatGPT is just a bunch of if-else statements all crammed together, and then comes out this chatbot. Even though I don't think that's true. With all those neural networks and stuff, it's a different system. So it's not exactly the same. But yeah, in the past, chatbots were pretty much achieved with a bunch of if and else if statements, without all of the neural nets and without the generative AI. So with that out of the way, let's go ahead and look at if, else if, and else statements. So see you in the next video. Welcome back. In this video, we're going to look at if, else statements, or if, else, if ladder. So the idea here really is that you could have situations where it's not just an either or, but you could have either or another or another or another. And if neither of those, then something else. Okay. So if we look at that, we can see that if we're checking if condition 1, if that is met, then run some code. If condition 1 is not true, and only if condition 1 is not true, then we're checking if condition 2 is true. So if condition 1 is true, condition 2 will never be checked. So this else if would never be executed. That's something that you need to understand. It's really important, okay? And if that is also not true, so if both of those are not true, only then will I execute this. And if neither of those three conditions is true, only then will I execute the else block. Now, you could have more than 3 conditions. You could go else if, else if, else if. You could go further as much as you want. You could have hundreds of these else ifs. However, it's not really nice practice to do it this way. You very often should just find a better solution then, but that's out of the scope of for now. So let's just use this in order to put together an example that is more real life centered. Okay, so let's say we have a score. So int score, and let's say it's 85. Now we could check, is the score greater than 90 or greater equal 90 even? If that's the case, then we're going to give a grade of an A. So grade is A, and it should be like this, okay? So then we're checking if the score is above equal 85, Then we're going to say grade is B. And then we're going to check if score is greater or equal 70, or I think is it 85? Let's just do 80 here. If score is above 70, then we're going to give a grade of C. And then let's do another one. So let's take this else if block here. Let's put it together like this. If it's above 60, then it's going to be a D. If it's above 50, then it's going to be an E. And otherwise, it's going to be an F. Okay. So here I'm just going to put this one and say grade is F. Okay. So here, in this case, we are checking this first. We're checking first, is score, this variable, does it have a value of 90 or higher? And it's false. So this piece of code will not be executed. It will directly jump to this piece of code. And then it will check, is the score above equal 80? And yes, in fact, it is. So the score is 85 in this case. So this code will be executed. And then neither this code, nor that code, nor that code, and nor that code will be executed. All right. So let's run this and see this in action. So we see grade is B. And that is because 85 is not greater or equal 90, but it is greater or equal 80. So if we were to have a value of, let's say 49, then we would get an F. Grade is F. So we failed. So it just jumps through all of those. It checks, is 49 greater 90? No. Greater 80? No. Greater 70? No. Greater 60? No. Greater 50? No. And because it's neither of those others, it has to be that. So it just goes and executes this. So even if the score was negative, so if the score was minus 49, for example, it would still just be an F. It would just still just execute this piece here. So this is how you can use if and else ifs. And you can't just use them with numbers. You can use them with all kinds of conditions. The condition just has to, in the end, return either true or false. So it can either be a comparison of two strings, it can be a comparison of numbers or checking a value and so forth. So everything is possible here. All right. So with that, I want to show you a little thing, and that is breakpoints. And breakpoints you can achieve by clicking the number on the left-hand side here in your IDE. So for example, I can click on this 3, then this turns red, and it just shows me that it will check this line and it will stop the execution of our program, but only if we are in debug mode. So only if we click on this little bug here at the top. But let's look at this in the next video because this one is already long enough. So see you there. Okay, so in this video, I want to show you debugging, but not too deep yet. Just the idea of using breakpoints and understanding the flow of our software. So let's execute this with the breakpoint that I was talking about in the last video. So just click on the number here next to in score. So in this case, it's line 3 in my case. So whatever that line is for you. If this turns red, so this filled out bright red, then you know that you have a line break or breakpoint here. So then let's click on this bug icon here at the top. This will run the app, but it will also pause it at our breakpoint. So we can then see args. Well, this is the variable. We can see all of the variables that are evaluated at this point. It says we are in line 3. So what we can do is we can either just resume the program, we can step over, step into, or step out. So I'm not going to go too much into depth here, but I'm just going to step into, which just sends us to the next line. So I'm going to step into, and it just says score equals minus 49. So if we hover over this statement here and we add that to watches, we can see that it just says false. So score greater or equal 90 is false. So then if I go ahead and step into again, it just goes to the next line of code that will be executed. So it checks here again, score greater or equal 80. That is neither true. So it just jumps to the next line, and it jumps to the next line and to the next. So you see, it always just jumps over these system out statements. And then let's jump to the next one, the else. So it doesn't even jump to this else. It just directly jumps into the code right here where it's line 19 for me. And it says system out println grade is F. So if I press into once again, it just goes to the end of the code, so to speak, to the last statement. And we can go over to the console and see what it says. The console says here, grade is F. And we can go back to threads and variables, and we can click it one more time. And this will send us to the console straight away. But what's interesting as well, that it just finishes the execution. So we see, okay, at this point, the app is done, or the program that we have here is done. So how can we use that to understand what's going on a little better? Well, I believe if we change this number to something else, it will make a lot more sense. So you saw, because the number is less than any of the else ifs, it just jumped all the way to the else, right? So how if the number actually jumps out at one point? So let's say the number is 85. So let's have a look at that. Let's debug again, use the debugger here, and we see the score is 85, and it's still trying to find the local variable that I created earlier to watch it. But don't worry about the watching part. Let's just step into here again, click on this arrow further down. Here it's comparing, and then suddenly the one that we were watching for, so score greater or equal 90, is false. So this comparison is checked. So then as this is false, it just jumps to the next else if statement. It checks, is score greater or equal 80? And score is 85. So this statement will be true, which means that this code will be executed. So the system out print line grade is B will be executed. So let's run into it, and we can see, or step into it, and we can see system out print ln is in fact jumped into. So we saw here it wasn't checked in, well, jumped into, but here it is. That's because this else if statement is true. Now let's step into it once again, or go to the next line, and you see it jumps all the way to the end of our program, which means that it ignored everything else. So it ignored this here, it ignored that here, and it ignored this part as well as this part of our code. So it directly jumped to the end of our entire if else if block. So all the code that we had, this entire ladder that we had, it ignored everything after it because it is all one combined block. So to make this even more visible, let's just add another if statement here. So I'm going to check if int number, and I'm going to set that to 5, and I'm just going to say if number modulo 2 is 0. Let's make this, or is equal 0. Then we're going to say system out number is even. Okay, so just to show you that this if statement here is not connected to this if statement here. So no matter what happens in here, it will still execute this piece here. So after whatever we have with this else if, it will just jump to this int number 5 and execute that code. I wanted to make clear that you understand that as well. So let's debug again, and I still have this breakpoint here, right? So I'm stepping into again, and this is the condition that is met. So I step into that condition and it executes this piece of code. And then you see it directly jumps to line 21, where it says int number equals 5. So we are declaring a new variable and initializing it. And then it goes to the next line where it's comparing, okay, or checking, is the number modulo 2, is it equal to 0? And well, this will be false, so it will not execute the next line. It will directly jump to the end of our code. So this is how you can check the condition of your program and follow the flow and see what is going on in which order. So in which order will the code be executed? And this is relevant for the first time because we have code that can actually be jumped over and ignored based on conditions because we're using else if statements. So that's it for this video. Thanks for watching and see you in the next one. Welcome back. In this video, we're going to look at the ternary operator. And the ternary operator allows us to use a very, very simple if-else execution here. So just in one line. And you can even go as far as using it with if, else if, else if, else if, else. So let's have a look at how that works. So we have our condition, then we have a question mark, then we have the first expression and colon, and afterwards the second expression. So with expression, we basically just mean we are executing either this or that based on this condition. So if this condition is true, we execute this. If this condition is false, we execute this. Okay, so let's see that in action. So I'm just going to have an int h, and I'm going to have a double, which will be the discount. And I'm just going to say, based on the age, I will give a discount. So I'm going to have a condition here. So age less than 18. So for minors, so somebody younger than 18 years old, for those, I will give a discount of 10%. So I'm going to set this double variable. So the double variable called discount, I'm going to set that to 0.10. And in the other case, so expression 2, I'm going to set that to 0.05. So everyone that is younger than 18 years old will get a discount of 10%. Everyone who's 18 or older will get a discount of 5%. So with that, we can go ahead and say system out.println and display the discount. So the discount is, and then we can just display whatever the discount times 100 is, because this will just look nicer because, well, we say discounts usually in whole numbers and not in decimal numbers, right? So we say 10% discount, something like that. So the discount is 10. Well, maybe we add the percent in here as well so that it looks a little nicer. So let's run this and we will see that it will in fact be 10%. So the discount is 10%. Now, if we were 21 and we ran it, the discount were 5%. So this is a very simple ternary operator that we are using here. It works like this. You have a condition and you see I'm using brackets here. Then you have the question mark and you have the 2 and you have what should be executed if it's true. And then after the colon, what should be executed if it's false. So in this case, we're just using a number and we're assigning it to a variable. And it is very often just used for assigning a value based on a condition. So this is an example of how that works. Now, if we take our scoring system from earlier, so we had the score equals 85, and we were to make it a little more complicated. So let's say we have a character that we want to assign based on the score, so a grade. And there we would check if score greater or equal 90, for example. And if that is the case, then we were to say it's going to be A. So this character grade will be A. Then colon, and here we can really make it more complex. So we can just say, basically, we're checking here as well. So we're saying score, or again in parentheses, score greater or equal 80, question mark. Then we're saying it will be B, colon, and so forth. So we can extend that. So let's say, let's do it like this so it's a little more readable. So we have all the different variants. So we have C, we have D, we have E, and finally we have F, like so. And you could put it in a separate line as well. So this is similar to what we had earlier, right? Where we had the if-else-if conditions. But this is just a different way to do it using ternary operators. So if we were to display the grade, so system.out.println, we could go ahead and just say the grade is plus grade and semicolon. So let's run this and we should see the grade is B. Okay, because the score is 85, so it's greater than 80 but less than 90. So that's why the grade turns out to be B. So this is just a more complex way of using a ternary operator. However, you don't need to do that. I rarely use it myself in this fashion. I just wanted to show it to you for completion's sake. However, otherwise, you can just really use it for very simple ternary operators where it's an either or. There it really is very useful, and especially when assigning a value to a variable. So that's it for this video. See you in the next one. And that's it for today. You've learned how to control the flow of your program with if-else and ternary operators and worked through the Galaxy Weather Advisor exercise. Tomorrow, we'll continue with control flow by introducing switch statements and enums. These will help you handle multiple cases and make your code more efficient. I'm really looking forward to it. So, see you tomorrow. Quick reminder, what you're watching here is just a small portion of our complete premium Java Masterclass. In the full course, you'll get deep into every aspect of Java, from beginner topics to advanced concepts, and have access to extra materials like cheat sheets and quizzes, and hands-on projects as well. You can find the link to enroll in the description below. So if you're serious about mastering Java, make sure to check it out. Welcome back. Today we'll focus on switch statements and enums. We'll start with the basics of switch statements, how it works, and when to use it compared to the if-else statement. You'll learn how to handle different data types in a switch case, you will avoid common mistakes, and how to prevent fall-through errors. We'll also explore enums, which allow you to handle a fixed set of constants in a clean, readable way. By the end of the day, you'll have a clear understanding of how to use switch statements and enums to simplify your code. We will also end today with a fun project, the ultimate adventure game, to practice what you have learned. So let's get started. Alright, so let's get started with the switch control statements in Java. We have seen how if statements work in the last day, and today we're going to really dive deeper into switch statements. And they're really cool because they're just a nicer way to do decision making if you have a variable that can have multiple different values and you want to do something different based on those values. So the switch statement provides an alternative to the if-else-if letter, making the code more readable and easier to maintain when dealing with multiple conditions based on a single variable, as I just said. So here you can see the syntax, and we're going to dive deeper into the syntax while we're coding in the IDE. But for now, let's just look at the main concepts that are used, or keywords that are used here. So we have this switch keyword, and then within parentheses, the expression. And the expression is the variable or expression you want to evaluate. Then we have cases. So each case statement defines a possible value for the expression and the code to execute if the expression matches that value. And then we have the break keyword, and this break statement terminates the current case and prevents the execution from falling through to the next case. Now, this is a little theoretical, but we're going to see what that means in practice. And then you have the default keyword, and the default block executes if none of the cases match the expression. So that's pretty much similar to the else keyword in the if-else-if letter. Now, what's the difference between the two? How do they compare? Well, the if statement is used when you need to evaluate complex conditions that involve more than just comparing a single variable to constant values. They are ideal for conditions that include inequalities like less than, less than equal, greater than equal, or logical operators like the double ampersand or the double pipe, or even more complex expressions. And then there is flexibility. So if statements offer great flexibility as they can handle a wide range of conditions, allowing for more nuanced and detailed decision making in your code. Now, the use case for switch statements are the following. When you need to compare a single variable against multiple constant values. This is particularly useful when you have a variable that can take on a limited set of specific values and you want to execute different code blocks based on those values. And that would be, for example, Monday, Tuesday, Wednesday, and so forth. So the days of the week would be a great example where the switch statement would be perfect. Then there is readability. So switch statements enhance the code readability by clearly outlining the different possible values for a variable and the corresponding actions. This makes the code easier to understand and maintain, especially when dealing with multiple distinct cases. Now, in this context, we're also going to look at enums. And enums are short for enumerations, and they are a special type in Java that allows you to define a fixed set of constants, so values that don't change. Enums are useful when you have a variable that can only take one out of a small set of possible values. For example, the days of the week, months of the year, or directions such as north, south, east, west. They're all good candidates for enums. And the switch statements are a type of control statement that allow you to execute different parts of code based on the value of a variable. When combined with enums, switch statements can make your code more readable and easier to maintain. Now, in summary, we have used the keyword enums, and enums in Java allow you to define a fixed set of constants. Then we have talked about switch statements, and switch statements can be used with enums to execute different blocks of code based on the enum value. And by combining enums with switch statements, you can write more readable and maintainable code. And we're going to dive deeper into how these work step by step. So don't worry if this was a little bit too much for you for now. In an earlier slide, we saw this break keyword. So why do we need it? And what does this fall through mean? So the break statement is used to exit the switch statement once a matching case is found and its code block is executed. Without the break statement, the program will continue to execute the subsequent cases, even if they don't match the expression. This is known as fall through. Here's an example of how to use it. You have this break semicolon just at the end of your individual case. And then you go over to the next case or to the default case. So in order to understand the fall through, we need to understand the following. When fall through occurs, all statements after the matching case will be executed until a break statement is encountered or the switch statement ends. This can lead to unexpected behavior if not handled properly. Now to conclude, understanding switch case fall through is crucial for writing clear and predictable code. By using the break statement appropriately, you can control the flow of your program and avoid unexpected behavior. Practice with different examples to get a good grasp of how switch statements work and how to prevent fall through. Now let's look at some common mistakes that can occur when you're using switch statements. Number one would be forgetting the break statement. One of the most common mistakes is forgetting to include the break statement at the end of each case. Without a break, the execution will continue to the next case, regardless of whether its condition is met. So this is known as fall through and can lead to unexpected behavior. And the best practice here would be to always include a break statement at the end of each case, unless intentional fall through is desired, which can also be the case. And another common mistake is using incompatible types for the switch expression and the case values. The types must match for the switch statement to work correctly. The best practices to ensure the expression and case values are of compatible types, typically int, char, byte, short, string, or enum types. The switch expression should also be kept simple and straightforward. Complex expression can make the switch statement difficult to read and understand, defeating its purpose of enhancing code clarity. The best practice is to use simple expressions in your switch statements to maintain readability and ease of understanding. And then a default case should always be included to handle any unexpected or undefined values. This ensures that the program can gracefully handle the cases that don't match any of the specified cases that we have. And the best practice is just to always include a default case to manage unexpected values and improve the robustness of your code. Welcome back. In this video, we're going to build our first switch statement. So write the code for it and let's have a look at the general structure of such a switch statement. We saw it in the presentation before, but now let's look at it in the demo as well as use it in order to build our own. So here you see we use this switch keyword. Then we have the parentheses and in here we have our expression. So this is the variable or expression that we're comparing. And then based on the value of that expression, we can have multiple different cases. So we have case value 1, we have case value 2, then we could have case value 3 and 4 and so forth. And then we can have a default case. And each of those cases, as well as the default case, are inside of those curly brackets. So it starts up here and goes all the way down here. All right. So this is just an example of a switch statement which has two values based on an expression. And you can see that we always have the break statement so that we don't have a fall through. But we're going to see what that means once we're getting started. So this is just the general structure that you need to memorize in order to use the switch case statement or the switch statement. So let's build one from scratch using the days of the week. So I'm going to have an int that will have the day. And for example, it's 3. And then I'm going to have a string, which will be the day name. So for example, if day is 1, then I would take Monday. If day is 2, I would take Tuesday, and so forth. So let's go ahead and do that with our switch statement. So we're going to assign a value to day name based on the number that we are given. So let's use the switch keyword, and you can see once I do that, I get the brackets here if I press the tab. So in those brackets or in those parentheses, I need to say which variable I want to check. We were using the word expression before, but it can also just be a variable, right? So we can just have a variable here where we are saying, okay, based on the day, I want to do something. So whatever the variable they will have, I want you to do something based on that. So in the case that the day is 1, I want to assign the day name a value of Monday. And then I need to break. Then there is the case that I have a value of 2. So in case the day is 2, I'm going to have the day name of, let's say, Tuesday. All right. Again, we end everything with a semicolon here, not the case where we just have the colon, but then we end the statement with a semicolon, then we have the break statement or keyword, and then we do the same thing here. So we need to use the break keyword. And now let's say in all other cases, so in the default case, I'm just going to say day name would be an A, so not available, and we break out of it. And that would be a basic switch statement. Now let's go ahead and display whatever the day name is. So system out.println, and I'm just going to say today is and the day name, like so. All right. So now let's run this, and we will see today is an A, because we have not defined what should happen for the case 3, because our day is 3 right now. So what if the day was 1? Well, let's have a look. Let's set day to 1. Let's run again, and we will see today is Monday. Now you could argue, well, we are missing all of the other cases. Well, that's true. So let's go ahead and add those other cases. And I would like you to pause the video and try this for yourself. Okay, so let's go ahead and do that a few more times. So we will have case 3. And by the way, you see if you have the same case twice, you get an error here. So it says duplicate label 2. So we need to use a different label each time. So 3, 4, 5, 6, and 7 is missing. So let's add 7. And now let's change the days. So on 3, we would say it's Wednesday. So Wednesday. On 4, it's Thursday. On 5, it would be Friday. On 6, it would be Saturday. And on 7, it would be Sunday. So now, obviously, depending on where you live, you would count these otherwise. So for us in Germany, for example, we start our week on Monday, or in the calendar, the week starts on Monday. In the US, I believe it starts on Sunday. So day 1 would be Sunday, day 2 would be Monday, and so forth. But I'm just using what is comfortable to me or what is known to me. So then we can see we have the switch case statement with all the days of the week. So now, depending on the int number that we have, day, we're going to assign a different value to our variable day name, which is a string. So now for 5, we should get Friday. So it says today is Friday. And with that, you have seen how a very simple basic switch statement looks like. The structure is always the same. We use the switch keyword. We have our expression, which could also just be a variable. Then we have the different cases. And that is great for such an example as we have here, where it's days of the week or months of the year or directions or something similar. Now there's one thing, if you hover over switch, it says it could be replaced with an enhanced switch statement. So if I were to use that, you can see it simplifies the code and makes it look even cleaner. But for now, let's just stay with what we have started with and look at that enhanced version later on. So that's it for this video. See you in the next one. So in this video, I want to talk about the default case a little more, because if we look at it, we can see that we still have a break statement, even though it's technically not necessary. Because what the break statement does is it sends us out of the switch case statement. So in this case, what it would do is it would send us out of this default case and go directly to after the curly brackets. So it would send us to the system out print statement here, right? So technically, after this semicolon, we automatically get to this point here and go to this line. So this break statement would not be necessary. However, it's common practice to just leave it in there for readability. And also in case you modify your code later on and add more cases, and then maybe you don't notice. And that's why it's just good practice to just leave the break statement in here. All right. So the default statement, so this default keyword is really required. So without it, the switch statement cannot work. And what's also important to know is that no matter what you do with your int day, so no matter which number it will be, as long as it's none of those cases, it will jump to the default case and will execute it. So it will check, is day 1? No, it's not. So let's say it's 12 here. Is day 1? No, it's not. Is it 2? No, it's not. Is it 3? No, it's not. 4? No. 5? No. 6? No. 7? No. And then it will say, all right, it's none of those other cases. So I'm going to jump to the default case and I'm going to execute whatever comes after this colon here. So then it will just execute this line of code and whatever other pieces of code we have here. So it could be multiple lines, and then it just breaks out of it. So it just goes to whatever the next line is. So with that out of the way, you now know that you could leave it out. It would work the same. And actually just let it run. But you should put it in there for consistency. All right. So if day is 12, then the day name is an A, because that's what we set up in the default block. So that's it for this video. See you in the next one. All right. So now let's look at the break keyword a little more and understand better what fall through means. And therefore, what I'm going to do is I'm going to take this system out print line statement, and I'm going to change our tool to be a day planner. Okay. So I'm going to have the different days. However, I'm not going to use the day name here, but I'm just going to print something out based on the day. So let's say Monday, I'm going to work on projects. Okay. So here I'm going to say work on project A, and like so. All right. On Monday, I'm going to work on project A. Then on Tuesday, I'm going to work on project B. On Wednesday, I'm going to have a meeting. So let's say Wednesday here, write proposal or have meeting. Well, let's write a proposal on Wednesday. And Thursday would be meeting day. So Thursday meetings all day. What a hard day, tough day. On Friday, I would go ahead and submit a report, and that would be Friday. Then we have Saturday, and on Saturday I would just relax. So Saturday, relax, and Sunday I'd also relax. Sunday, relax. Now let's add Monday and Tuesday here still. Okay, so here it's going to be Tuesday, and now the default case is going to be invalid day. All right, so here I'm going to say invalid day. So now, based on the day that I enter, I'm going to know what I have to do. All right, so if it's day 5, then I know it's going to be Friday and I need to submit my report. So I still have an error here down there, so I'm going to get rid of the system print out statement. So I only have my switch case statements here. So let's run this and see what's going to come from it. And it says submit a report. That's great. So now let's say it's day 4, just to test it, and we will see it's going to say Thursday meetings all day. So that is all good and well. But what about fall through? Well, that is if we forget to use a break statement. So let's say I don't have a break statement after Saturday and neither after case 7. Okay, so neither after Sunday. And now let's say it is in fact Saturday. and I'm going to run it, we will see that we get Saturday relax, Sunday relax, and invalid day. So all three of them were printed. Why is that? That's because of fall through. So how does it work? Well, basically, we know it's case 6 because that's what we entered here, right? Day is 6. So this case will be true. So it executes this piece of code, and then there is no break statement. So then it executes this piece of code, and then still there is no break statement. Then it executes this piece of code, and then there is a break statement. So let's say we have this break in here, all right? And we have this break in here. But let's say we just forgot the break after day 5. So now let's assume it is day 5 and we run it again. All right. So we will see that day 5 is Friday. So we need to submit a report, but it's also sending us the information about Saturday where it says relax. And it does not do that for Sunday. Why do we not see Sunday now? Can you think of the reason? Well, it's because we do have a break statement after Saturday. So it sends us out of these cases and goes over to the final piece of the switch statement, which is this closing curly bracket. So it executes whatever comes after. And in this case, we have the situation where we're not breaking out of a given case and we're falling through to the next case until there is actually a break. So after case 6, we have our break, and that's why we don't see case 7, even if we had case 5 here. So that's why you need to use your break unless it is intended. So unless you want to display two cases that are linked after another. And in some situations, this might be useful, but it's just important for you to be aware of it and always use break unless you really want to actively have this behavior. Okay, so that's it for this video. See you in the next one. In this video, I want to show you a little bit of a comparison between an if statement and a switch statement. So we saw if else if letters before with the score, for example, right? Where we had the grades that we want to print out. Now, how could we make this a switch statement? The thing is, switch statements are not designed to handle comparisons. Switch statements are always just there to look at a value and see, is that value a specific number or a specific string or a specific char? If it is, then do something, like execute some code. If it isn't, check the other cases. And if none of the cases are true, go to the default case. If statements, however, they do allow these comparisons and they do allow the double ampersand and the double pipes, so the logical Boolean operators. However, switches don't do that. So how could we convert this into a switch statement? Well, therefore, what we can do is we can still have our score, and we could go ahead and say something like string grade, and we use this switch keyword here, switch, and we're comparing score divided by 10, and then we're checking the different cases. All right, so we're, for example, saying, so case, it is 10. Let's say it goes all the way to 100, then we would just say the grade is A, okay? And we could have made the grade a char, but I'm just going to use a string in this case. So then we have the case 9, and then we can set the grade to A again. Now, did you notice that I missed something in my switch statement? Well, I forgot the break, all right? So it's really important that I have my break statement here, break. Now, another thing that you can do straight away whenever you're creating a switch case statement is that you use the default straight away. So you add the default. So you add this break, then you say default, and you set the default value, whatever that is. So let's say grade is an F. So in case we don't have an A or B or whatever, we're going to have an F and use the break here. And now let's add the other cases that we want. So for example, case 8. Then we could have the grade to be B and we break. Then let's say we have case 7. In that case, grade would be C. So what is case 7? 7 means anything above 70, but less than 80, because 80 is already covered here. Then 70 is covered because score divided by 10 will result in a whole number that is going to be either 10, 9, 8, 7, 6, and so forth. Okay? So let's look at 85, for example. 85 divided by 10 is 8.5. However, as we are using this with an int, this expression here will become an int. So it will not be 8.5. It will just be 8, as we learned, right? Because 8 dot something is always going to be 8 if it is stored as an int. And as the calculation is between ints, the result will be an int. So score is an int, 10 is an int, the result will be an int. So whatever we have as a calculation will end up being an int. We could have put that into a variable as well. We could have said result, so int result is equal to score divided by 10, and we're going to say result is the expression or the variable that we are comparing. So either way would have been fine. Maybe this is a little more readable and easier to understand. So this results in an int, whole number. All right. And because of that, we can just go ahead and use whole numbers here. We can just say, okay, in case 10, so 100 points, or the score is 100, we have a grade A. In case of 9, so let's say 95, 91, 92, any of those, grade will be an A, and so forth. So let's have the final two cases still in here. So that would be 6 and 5. So 6 would be a D, and 5 would be an E, and everything else would be an F. So let's use this and then actually display it in the console. So system print out, and we're gonna say the grade is, and then we add the grade here. Now let's run this and we will get to results. So we see the grade is B, which is this one here, and it says grade B, which comes from here, from this if else if. So you see that there are different ways around it, and the switch statement is just very easy to read, very simple. However, if you really want to make proper comparisons, or if you want to use the Boolean operators such as double AND or pipes, then you should use if statements. Okay, we cannot do comparisons directly inside of our switch case statements. They're not designed for it. So that's it for this video. See you in the next one. All right, so we have seen how to use a switch case statement with integers. How about we use it with a character data type? Well, we can do that as well. So therefore, let's use the same example that we have here, but change it a little bit. So we're going to get rid of all the code here, and we're gonna just go ahead and say we have this char, which will be the grade, and we're going to set it to default by being B. Okay, now we are going to have this switch statement, and we're going to check the grade. And based on whatever the grade is, we want to display something like, hey, excellent, good job, well done, and so forth. So something like, let's say case is A, then we want to do something and break. And then while we're at it, let's also add the default case already and break out of it. And here I'm going to say system.out.println grade doesn't exist. So what would we write if somebody gets an A? Well, let's say something like excellent. And then what other cases could we have? Well, we could have the case of the grade being a B. So if that's the case, we're going to say good job. In case the grade is a C, we could say something like well done, even though it obviously depends on your background. For some people, a C is well done. For others, it's a very bad grade. So then for 4, you would say, or for D, we would say passed. And for an E, we could say better luck next time. And finally, for the F case, we could say you failed, try better next time. Okay, so you see, so based on whatever the grade here is, which is a char data type, we're going to run different code. In this case, we have very simple code, right? It's just a system out println statement, but it could be more complex code if we wanted it to. So let's run this and see what we're going to get. And we just get good job, obviously. Well, because our grade is B. Now let's try D and we see we passed. Now let's try something like H. Then it says grade doesn't exist. Okay. So, well, somebody was so bad they got an H. Or let's say we get an A, then it's going to say excellent. So there we are. That's the general idea of switch statements applied on using a char. So using the data type character. And you see, it works exactly the same as it did with ints, where we are really comparing one particular value. Well, the case is always just one value of the possible variance. So case A, case B, case C, and so forth. So it's not like case A or B, case A or C. No, we're just saying in case A, run something. In case B, run something else. In case C, again, run some other code. So that's really how switch statements work. Very simple, right? And we apply it the same way every single time, no matter if it's an int, a double, a string, a char, or whatever data type you want to use. All right, now that we have seen how to use switch statements with ints and with char, let's have a look at how it works with strings, just to get an even better feeling for them. So I'm going to have this string, which I'm going to call season. And I'm going to assign a value. Let's say it's summer, right? Right now it's summer in my case. And what I'm going to do is I'm going to use the switch statement to display a text on the console based on the season. So I'm going to check for the season. And how do we do that? Well, we check, is it, for example, spring? And then we break out of it after we did something with it. By the way, how I get my tab back. So here I go one tab back by using shift tab. Okay, so this is forward tab and this is backward tab. In order to get a backward tab, you need to use the shift key or hold it while clicking on the tabulator key. So here I'm going to add the default case straight away and I'm going to break out of it. So just so that I have it. Now, what do we want to execute if there is spring or if the season is spring? Well, we could just say system out dot println. And we're going to say, the flowers are blooming. How nice. Okay, so that's the spring case. Now let's add the other three cases. So we can have spring, we can have summer, we can have fall or autumn, and we can have the case of winter. So in case of summer, we're going to say it's sunny and hot. Time for the beach. Or in case it's fall, we're going to say the leaves are falling and it's windy, right? And then during winter, cold and snowy, let's build a snowman. Okay. So now you could go ahead and add another case for fall where you could say it is autumn. Autumn. I think it's written like this, right? So I think this is the British English variant and this is the American English variant. So in case of autumn, the leaves are also falling and it's windy. In case of fall, the same thing. Okay, so now based on the season, we're going to have different statements here. And now obviously this could be all kinds of code, right? This doesn't have to be a console statement. We're just using that because that's something where we can see something on the screen, but it could be something much more complex, right? Like a real application where you display something based on the weather. So let's say it is winter, then the wallpaper on your phone could turn to be a winter wallpaper with snowboarding and Iceman or like snowman and so forth, right? So now if it is default, what do we want to say? In the default case, I'm going to say, I have never heard of this season before. Now we could obviously go ahead and ask for the season by the user, not just use a predefined season. So how do we do that? Do you recall? Well, we need to use the scanner class, right? Scanner, new scanner, and system in, and then we use that scanner dot next line like so, and we store that inside of season. Okay, now obviously we need to have the variable before we use it, so we're going to have string season summer as a default value. However, then we are overwriting it with whatever the user entered. So we could have also not initialized the season from the get-go. We could have done it this way. So then let's tell the user that we are expecting an entry. So let's use system.out.println, and we're going to say, what season is it? And then the user needs to enter something. So let's put that before we actually ask the scanner next line, because this will block our console and this will be displayed before we block our console and let it wait for us to enter something. Okay. Now we could give some additional information. We could say enter spring, enter summer, and so forth. And maybe what we also do is we change that from uppercase to lowercase, because not everyone is going to enter it accordingly, and we could go further, modifying it even further. But I'm just going to really just keep it simple and reduce those to lowercase. And now, as we know, when we're using the scanner, let's close it at the end when we're not needing it anymore. And then also check if you have this import statement, because otherwise it won't work, right? So now let's run it. Let's see. What season is it? Okay, so let's say it's learning season. And then it says, I have never heard of this season before, because it jumps into the default case, right? We have never set up the season for learning. That's why it doesn't exist in this context. And that's why it jumps to the default case. And in that case, it just executes this system out statement. So now let's run it again and enter one of the real seasons. So let's say we are American and it's fall, and we're saying, well, it's fall. Well, the leaves are falling and it's windy. Now let's run it again and enter summer. It's sunny and hot, time for the beach. So there we are. Now you know how to use strings, chars, and ints with switch statements. Okay. With that out of the way, let's go over and look at enums, because we could have stored those in an enum and that would have made it a little easier potentially. So see you in the next video. In this video, we're going to look at enums, and enum stands for enumeration, which is just a special type in Java, and it allows us to define a fixed set of constants, so values that don't change. So let's have a look at how this works in Java. So I'm going to create an enum inside of my class, but outside of my method. Okay, so inside of these curly brackets, but before this p, that's where I'm going to create a new public enum, and then I give it a name, for example, day. And then within the curly brackets, that's where I am adding the different values that I want to have, the different constants that I want to have for day. How many days are there in the week? So you could call this weekday or day, however you want. So for example, there is Monday, or there is Tuesday. Then there is Wednesday and Thursday, as well as Friday and Saturday, and finally Sunday. Okay, so all of these are the different values or constants that exist within a day. All right, so that's the general structure as to how an enum looks like. Let's use this for a new example, and that is, let's say, for coffee. So let's say we have a coffee shop and we are selling coffee, but we're selling different sizes of cups of coffee. So therefore, let's go ahead and create an enum that has the different sizes. So enum, and I'm going to call this one coffee size. So coffee size, and then I'm going to say there is small, there is medium, there is a large, and there is venti. All right. I think that's what they call it in Starbucks or whatever. I rarely go there, so that's why I don't know. But that's the enum that we're now going to use for our switch statement in order to say what the price should be based on the coffee size. So how can I now use it? Well, first of all, I will have this coffee size variable. So coffee size now is an enum, which is its own type, right? And we're using it now. So we're saying we're using this coffee size and we're giving it a name. So we're gonna use the coffee size, for example, .large as the value for it. So coffee size .large, and if you hover over it, you will see large has this enum constant ordinal of 2. What does that mean? Well, the thing is that we are using words here, but technically what happens is that these words are stored as numbers or are connected to a number. So for the number 0 on coffee size, I now have small. For number 1, I have medium. For number 2, I have large. For number 3, I have venti. So now what I'm going to do is I'm going to have a price that I want to display to my user, and I'm going to not assign a value to it yet. I'm going to use a switch statement for it. So I'm going to say, based on the size, I want to assign the price. So let's say we have the case of small, then I want to set the price to be, let's say, $2.50. And now I'm not going to use this fancy way. I'm just going to use our old-fashioned way, how we saw it before with the colon. And then I need to break out of it. And then let's add the default case. And then the default case, I'm going to say price is going to be $420.69. Okay, pretty high price. And I'm going to break out of it. So what are the other cases that we can have? So we have 4 cases in total. We have the medium case. We have the large case. And you can see the cool thing is it already helps me here as well, because it knows that I'm looking at this size, and size is of type coffee size, and coffee size is this enum that holds all of those different values. So I'm just saying, in case it's large, then I'm going to assign a different price. In case it's venti, I'm going to assign an again different price. So let's say at medium it's going to cost $3, at large it's going to be $3.50, and at venti it's going to be $4. All right, so this here is just our way. So this enum is just a very helpful way to contain predefined values that we can then reuse throughout our software, and it's especially useful when working with switch statements, as we can see here. So we can now compare the size, which is of type coffee size, and where we have all of these different values, small, medium, large, venti. And based on those values, we can assign a price. And the price is what we're going to display to the user. So I'm going to say system.out.println the price for your coffee, colon, and then whatever price is. Okay, so let's run this and see what the large coffee is going to cost. And it should be 3. So now you see I get 3.5. How would I get 3.50? Do you recall? How can we manipulate this string here to display 350? Well, there are 2 different variants. Either we use string.format, so the method, or we are just going to use the %.2f %n, and then we need to use a comma here instead of a plus. And on top of that, we need to say that this print is formatted, so we need to use printf here instead of println. And then we should see the proper price. So there we are. We see the price for your coffee is 3.50. Now we could add a $sign before that so that we see the $sign. So it's going to say $3.50. That looks a little nicer as well. So that's it for this video. Now you've seen enums in action, and you've seen how to combine them with switch statements. So see you in the next video. Okay, now you might wonder, why do we even need enums? Because we could have just used strings here, right? Well, the thing is, with enums, we can make sure that our code is safer, because we're defining which values we want to be accepted. So for example, for coffee size, we're saying, okay, these are the accepted coffee sizes. We're defining them, and if you want to use them, you can just use coffee size dot, and then you will see the different options available to you straight away. So you don't have to guess which kind of values are fine to enter here. You will just get them straight away. So here, if I use coffee size dot, you see I get all of the different options. I get large, medium, small, venti. They appear here straight away, and I can just use them. And this just makes it a lot easier for me to make sure that my code is working flawlessly. So sometimes we're going to get these enums by an external source. So for example, if we want to get the day of the week, we don't have to create this enum called day. There is a enum called day that is in one of the packages that are made available to us by Java itself. The same goes for months, okay? So months of the year, for example. There are enums that are there with exactly that. And very often you will work with external packages, and these packages will offer you enums. And these enums, they will have predefined values that you can then just take and use. And this will just make your code a lot cleaner and more stable and just easier to maintain as well. Okay? So just keep that in mind regarding enums. So you don't need to become a pro at creating your own enums yet. Don't worry about it. We're going to go and use enums later on in more depth and see more about it. This was really not the focus of today. The focus is not to make you an enum pro. It's about making sure that you understand how switch statements work. And enums are just an important aspect of switch statements because they just make switch statements work so much nicer. All right. So that's it for this video. See you in the next one. For today's challenge, you need to understand one thing. And that is that you can have switch statements within switch statements. So let's have a look at that. So therefore, I'm going to create a scanner variable, and I'm going to call this one scanner, and I'm going to say new scanner system.in. And now what I'm going to do is I'm going to close the scanner as well. And let's say we tell the user to enter something. So systemout.println, we're going to say enter A or B. Okay. So then we take the entry. So we're going to say string choice is going to be A or B. So it's going to be scanner dot next line, like so. Now the string should be a capital S. Now, based on the choice, I want to go ahead and use a switch statement. So I'm going to say switch choice, and I'm going to say the two variants, so the two cases are either A, and we can do something, or they're B, and we can do something, or there's the default case as well. So default, and in case it's default, we're just going to break out, and we're going to say something like system.out.println wrong choice, something like that, or the choice doesn't exist or something like that. So now let's say we are in case A. So we chose A. And now we're going to say, now choose 1 or 2. So then we can have another switch statement here. So we're going to say string choice 2 is going to be scanner.nextLine. And we're going to take either 1 or 2. So this means we're going to use a switch statement here with choice 2, where we're going to compare, is choice 2 1 or is it 2? So we're going to say case 1, because we're using strings here, right? Next line is going to give us a string. So I cannot use 1 as a number or as an int. I have to use it as a string. So in case it's 1, I'm going to say system.out.println thanks for choosing 1. And then what is the other case? Well, let's also break out. That's important. And then what is the other case? Well, the other case is 2, right? So what should we do if we are choosing 2? Thanks for choosing 2. Bad choice. Whatever. And then we also need to have a default case, right? So never forget to have a default case, because the user could enter something random. Okay. And in that case, we're going to say you chose wrongly or something like that. So choice doesn't exist or whatever. So you see, you can have multiple layers of switch statements inside of switch statements. So instead of having switch here, we could have all kinds of code. So whatever comes after the colon until the point where we break out of here. So we need to add the break here, because this, let me get rid of this. So this break here is still the one for case A. So it breaks out of case A once this code is executed. And part of this code is also my other switch choice. Okay, so I'm adding another piece of code, which is another switch statement, which is one statement that belongs together, right? So technically, we could have as many lines as we wanted, and then we need to break out of it, obviously. So then we have another case, let's say case B, and I'm going to just say, if the user chose B, we're going to keep it simple. We're going to say system.out.println B is inferior. If that's the right way of writing it, I'm happy. Otherwise, it's fine as well. Let's also make sure that we break out of here as well. So case B, never forget to break out. So then let's run it again, or let's run it and see what we have as options. So let's say we chose A. Then we can choose 1 or 2. Let's choose 1. And it says, thanks for choosing 1. And now let's do it again. Let's choose B, and it's just going to say B is inferior. So no further choices. Now we could have had if statements in here. We could have used methods, which we haven't seen yet, or whatever other code we want. We could have used it inside of this case statement. I just wanted to make sure that you understand that, because this particular example that I'm showing you here with switch statements within switch statements is what we're going to require for our text-based adventure game. Okay, so I hope you will enjoy it. I really recommend that you try to build it yourself based on what you just saw in this video and build a neat little adventure game and have fun with it. Okay, so with that, see you in the next video. All right, so let's have a look at the solution, or one of the possible solutions for the challenge of today. I hope you actually tried to build a really cool adventure game and you saw that it's not that crazy in terms of how much code you need to understand. And it really is just a bunch of switch statements, right? So how do we start? Well, first of all, let's go ahead and introduce the game to the player. So I'll say something like, welcome to the adventure game, or something like that. And as this is a lot of typing, I will just copy in the pieces of code that we have prepared for you, so you don't need to watch me type out so much. I will really only use that for exercises where there's a lot of code involved or a lot of typing involved. Even though the code itself is not complicated, I will still go over every single aspect of it. So let's introduce the ultimate adventure game to the user. So we're going to say, welcome to the ultimate adventure game with a system out println statement. And then we're going to say what the goal of the game is. So the player needs to understand what the goal is. So we're going to say your goal is to find the hidden treasure. Choose wisely. All right, that's going to be the introduction text. And then we are going to introduce the different choices to the player. So we're going to start with, you are at a crossroad. Do you want to go left or right? And then we're going to say exactly what the user needs to do. So we're going to print type left or right with single quotes, so the user knows what he or she has to do. So now, how do we now go ahead and use the choice? Well, we get the choice from the user. Therefore, let's go ahead and let me just get rid of these instructions. So we're going to go ahead and say scanner, and scanner is new scanner system.in, and then we can use that scanner. You can see that it's imported up here. Now let's also make sure that the scanner is closed at the end. It's just good practice. And then we can go ahead and start using that scanner. So I'm going to say string choice1 will be scanner next line, and I'm going to put that to lowercase. So if the user entered left with a capital L or so, it will still be the left choice, and same goes for right. So we're going to store this in the variable choice1. And now we're going to go over and use a switch statement. So that's where switch comes into play. We're going to say we're checking for choice1. And then there are multiple different cases. So in this case, it's really just 2 cases, right? So we're going to say if the choice was left, then we want to execute some code and then break out of it. And then we're going to have the case right here as well. And we're going to break out of it once we're done. And then we're going to have the default case as well. So default, and the default would be, well, let's write it out straight away. It would be invalid choice, you lost, something like that. Okay, so invalid choice, you got lost in the wilderness, game over. And let's break out of that as well. Okay, so now let's look at what happens when we take the left choice. And there are different options available to us, but let's just say, we're going to say, you walk down a dark path and find a mysterious cave. Okay, cool. So then let's say, do you want to enter the cave or walk past it? And then we're going to let the user know which options the user should enter. So we're going to say, type enter or walk. So now we need to take the user's choice again. So we're going to say, choice 2 is going to be scanner next line to lowercase. So whatever the user entered, we're going to take that. And now we need to go ahead and use another switch statement. So we're going to say choice 2 is what we're comparing. And what is it that we want to check as cases? Well, we have the case of enter, we have the case of walk, and we have the default case. So let's break out of the default case, let's break out of the enter case, and let's break out of the walk case as well, like so. What should happen when the user chooses enter? Well, we're going to say, inside the cave, you find a sleeping dragon. Damn. Then we're going to say, do you want to fight the dragon or sneak past it? Now, the two options that the user should enter, so either fight or sneak. And then we need to store the choice of the user once again. So we're going to say choice 3 is going to be scanner.nextLine to lowercase. So at this point, we need another switch case statement. So we're going to check for choice 3. And what are the different options that we have? Well, we have fight, or we have sneak, or we have the default case. Okay, default, and we're going to break out. So what is it that we want to display in the fight case? Well, the scenario is the user is fighting the dragon, and you bravely fight the dragon and you are victorious. The dragon guards the treasure, but you win. All right. So then we're going to break out of this. So don't forget to break at this point. So what happens if we sneak? Well, if we choose sneak, we're going to say, you sneak past the dragon and find the treasure behind it. You win. So you see, in choice 3, regardless of whether we fought or sneaked or snook, I think sneaked, we won. All right. And then in the default case, well, we entered something invalid. So we're going to say, invalid choice, you got caught by the dragon and lost. So that's choice 3. Now what happens if we walk, right? So we had the choice to either enter or we had the choice to walk. So in choice 2, we could enter or walk. You see here, enter, walk. So what should happen when we walk? Well, when we walk, then we're just going to say, you walk past the cave and fall into a hidden trap. Game over. That's it. Very simple. And then what happens in the default case? So if we neither enter or walk, well, then we're just going to say, invalid choice, you got lost in the wilderness, game over. So you see, this is our default situation every single time if we enter some incorrect value. So then what should happen in case at the beginning when we chose right? Okay, so at the very start, we had the choice at the crossroad to either go left or go right. The left variant led us to this cave with the dragon. And where does the right variant leave us or lead us? Well, it says, you walk through a dense forest and find a river. Do you want to swim across or build a raft? Now we have two choices. Either we swim or we enter raft. So these are the two entries that we should do. And then I'm going to store that in choice 2b. We could obviously call it choice 4, but what if we want to go deeper here and we have choice 4 in there where we fought and then we had to make a decision again? Well, in that case, what we're going to say is choice 2b is just going to be swim or raft. And then we need another switch statement here. So we're going to say switch choice 2b. And then what are the variants that we have available or the cases? So one case is going to be swim. Another case is going to be raft. And the final case is going to be default. and I'm just going to break out of it. So let's break out of this one as well as of the raft, so that we don't forget it later on. So let's say we chose swim. We're going to say you swim across the river and encounter a wild bear. And then I'm just going to say, okay, do you want to run away or climb a tree? So we have the two options, run or climb. So again, we're going to store that in a string. We're going to say choice 3b, scanner next line to lowercase. So we're going to read the player's choice to be run or climb. And then we're going to have another switch case. So we're going to say switch choice 3b, and we're going to look at the variants. So we had case run, we had case climb, and we had default. So let's break out of default. So what should happen if we run? Well, I'm just going to say you run away safely and find a hidden path to the treasure, you win. And then we break out of it. Now, what should happen when we climb? Well, we're going to say you climbed the tree, but the bear waits for you. You are stuck. Game over. Damn, the bear is scary. So what should happen in the default case? Well, in the default case, we're going to get out of here and we're going to say system out print line invalid choice. The bear catches you. Game over. All right. Now, what should happen when we chose raft? Well, we're going to say you build a raft, and let me put that accordingly here. You build a raft and safely cross the river. You find a treasure on the other side, you win. And in the default case, we're going to say again something like invalid choice. You got swept away by the river, game over. And then finally, we have the last default. Well, actually, we already had that with the invalid choice here. So now I added all of these break statements, right, after the default. And this will teach you something about how break works. All right, so at this point, let's run the game and see if it works. Welcome to the ultimate adventure game. Your goal is to find the hidden treasure. Choose wisely. You are at a crossroad. Do you want to go left or right? Type left or right. Let's go left. You walk down a dark path and find a mysterious cave. Do you want to enter the cave or walk past it? Walk past it. So I'm going to say enter. Inside the cave, you find a sleeping dragon. Do you want to fight the dragon or sneak past it? Let's say sneak. You sneak past the dragon and find the treasure behind it. You win. All right, let's run it again. And let's say we go right this time. You walk through a dense forest and find a river. Do you want to swim across or build a raft? I'm going to say let's build a raft. You build a raft and safely cross the river. You find the treasure on the other side. You win. Great. So now let's run into a default case. Let's enter some gibberish. Okay, ASDF. And it says invalid choice. You got lost in the wilderness. Game over. All right. So now we could obviously check all the different cases, and I would recommend that you do that. But overall, I'd say we're good. This is a cool little project that we built. So this is an adventure game. I pasted in the code. I'm sorry for not typing it out for you, but I think it's just a little more convenient and more interesting for you because you weren't supposed to type it out while I was showing it in this lecture or in this video, but you were supposed to build that beforehand. So this was just to show you how I did it. And you see, basically we are using switch case statements within switch case statements and so forth. So thanks a lot for watching. I hope you enjoyed this and I hope you built a really cool project. If you want to share it with us, please feel free to share it in the Q&A, and I wish you a nice day. And that's it for today. You have learned how to use switch statements and enums, explored their advantages over if-else statements, and even created a fun project with a text-based adventure game. Tomorrow, we'll dive into loops, one of the most powerful tools in programming. You will learn how to use loops to repeat tasks efficiently and create more complex logic in your programs. So, see you tomorrow. Welcome back. Today, we'll focus on loops in Java, which allows us to repeat actions efficiently in our programs. We'll start by learning the different types of loops, the for loops, while loops, and do while loops. You'll also learn how to control these loops using keywords like break and continue, and we'll talk about how to avoid or handle infinite loops. We'll practice building a pyramid using nested for loops, and then wrap up with a fun project, creating a simple calculator that continues to run as long as the user wishes, using an infinite loop. So let's get started. Welcome to our loops day. So today we're going to learn about loops, and there are so many different types of loops. Well, it's actually 3, but we're going to learn about them step by step, and we're going to get a feeling for how to use them and when to use them. And the cool thing about loops is that they help us to run a specific piece of code multiple times, where we either define how many times the loop should run, or we make it based on conditions. And what conditions are, we have seen with if statements, right? So if something is true, then go ahead. If something is false, then don't go ahead. And it's similar with loops now. The only difference is that we don't execute the block of code once, but many times, or depending obviously on the situation, multiple times. So I'd say let's jump into the presentation. And after that, we're going to go deeper into different types of loops. So let's get started. So a loop in programming is a control flow statement that repeatedly executes a block of code as long as a specified condition is met. So loops are used to perform repetitive tasks efficiently, eliminating the need to write the same code multiple times. Some benefits of using loops are reduced code redundancy. So loops help avoid duplicate code by executing a block multiple times. Then they help with simplifying complex problems. So they make it easier to handle tasks that require repeated actions, breaking down complex problems into manageable parts. And loops help to enhance code readability and maintainability. By using loops, you create cleaner and more readable code that is easier to maintain and understand. There are different types of loops in Java. There's the for loop, the while loop, and the do while loop. So let's start with the for loop. A for loop repeats a block of code a specific number of times. It is typically used when the number of iterations is known before entering the loop. The syntax is as follows, where the initialization is the part that runs once at the start of the loop. It typically sets a loop control variable. Then we have the condition, and this condition is checked before each iteration. If it evaluates it true, the loop continues. If false, the loop ends. And then there is the iteration. And this part runs after each execution of the loop body. It usually updates the loop control variable. And I would say let's jump into a demo where we see how the for loop works before we look at how the while loop and the do while loop works. So let's get started in the next video. So in this video, we're going to look at the for loop. So let's start with the syntax and get a feeling for it. So the first thing that we're going to do is we're going to use the for keyword. And the cool thing is you can see that the IDE already offers us for I. So I'm just going to hover over that and press the tab key. And you can see that I get this for loop code defined for me. And I need to enter the name that I want to use for my counter variable, which I'm going to leave as I. And then I need to say how often I want this for loop to run. So let's say I want it to run 10 times. So this for loop now will execute the code inside of these curly brackets 10 times. And let's simply use system.out.println and print I. I is our counter variable. And I'm going to go over every single aspect in here in a second. But for now, let's just run this piece of code and see what's going to happen. So we get the numbers starting from 0 all the way to 9. So it is counting and creating a new line each time, starting with 0, 1, 2, 3, and so forth until 9. So how does this happen? Well, the thing is, we're saying, okay, we want to use a for loop where our initialization, which is this part here, before the semicolon, starts with an int I equals 0. So we're saying we create this variable called I, which is going to be our counter variable, which we're going to initialize with the value of 0. And then we have a semicolon. And after the semicolon, we have the condition. So we're saying this condition needs to be met for the for loop to iterate. So for the for loop to execute and run the code inside of the curly brackets. So we're saying as long as I is less than 10, execute the code in those curly brackets. And because 0 is less than 10, it will start executing the code inside of those curly brackets. And once all of that has happened, it will jump to this part here. So after the semicolon, it will jump to the iteration. So once it ran the code once, it will go over here and it will say, all right, so I'm going to increment I by 1. This is using the post increment, right? Do you recall? We saw that earlier where it says I plus plus, which means I will just be 1 higher than it was before. So if it was 0, now I is going to be 1. And then it will do the check again. So it will go through this piece of code and it will say, is 1 less than 10? Well, yeah, it is. So, okay, execute the code and then jump here again. So then go to I and increment it. So we're going to put it to 2. Now it's going to be 2. We're going to say 2 less than 10. So this is the check, our condition. Is 2 less than 10? Well, yes, it is. So let's go ahead and run the code inside of those curly brackets, which is then displaying I to us. So just displaying the counter variable, and it is incremented by 1. All right. So that is basically how this for loop works. It's a very simple for loop, which just counts from 0 to 9. Why just to 9 and not to 10? Well, we are checking and incrementing all the way up, let's say up to 9. So I was incremented as many times where I now is 9. So we're checking 9 less than 10. Well, that's true. So let's run this piece of code. All right. Once we ran this piece of code, we increment I by 1 again. So we're going to say I is now going to be 10. So we're doing the check. 10 less than 10? Well, no, it isn't. So what are we going to do? Well, we're going to not run this code inside of those curly brackets anymore, but we're going to run whatever comes after the loop. So I could just go ahead and say, this is after the loop. Okay. So if we run this, we will see that it will display all the numbers up to 9 in a new line each time. And then it will say, this is after the loop. So now a little challenge for you. Change this loop so that it starts counting at 1 and it counts up to 10. Okay, so I hope you paused the video. So the first thing that we need to do is we need to change the initialization from I equals 0 to I equals 1, right? And then we need to change this check to either I less than equal 10 or less than 11. Both is fine. Both would work flawlessly. So now if we run this, we will get a counter that counts from 1 all the way to 10. Okay. So now there are a few more things that you can modify here. Okay. You could, for example, increment not by 1, but you could increment by 2. And therefore you would say I plus equal 2, for example. Now this will start at I equals 1, and then it will display 3, then it will display 5, and so forth. So let's run it, and you will see 1, 3, 5, 7, 9. So now we just said that after each iteration, we want I to increment by 1. So after each time that this code is executed, we're going to increment I by 2. Okay, so we're saying in the first run, I is 1, in the second run, I is 3, and so forth. All right, with that knowledge now, how would you change this to be a count down, not a count up? So how can we now change this so that it counts from 10 all the way to 0? Okay, I hope you paused the video and tried it and thought about it. So first of all, we're going to start with 10 for I. Secondly, we're going to say I needs to be greater equal 0, and we're going to decrement. So we're going to say I minus minus. So now let's run this, and we will see it started at 10 and it's counted all the way down to 0. So the countdown timer is over. So it's not really a timer because it really runs different. Well, it runs with different speeds based on your machine, basically. But yeah, that's pretty much how for loops work. Very simple, right? And the cool thing is the code that you have in here could be anything. It doesn't just have to be us printing the number I. We could have something like such a great day in here. And this now would be displayed 10 times. You see, such a great day, and so forth. Even if I have a mistake in here, a typo, the U is capitalized, and still, you see, it doesn't care. It will print my mistakes multiple times. So that's it for for loops. We're going to jump into for loops within for loops, so nested for loops, in the next video. So see you there. Welcome back. In this video, we're going to see how we can use nested for loops and how we can build them, because there will be a little exercise for you in the next video or as the next lecture where you're supposed to build a nice little pyramid. But first of all, we need to understand what nested for loops are and how they work. Well, we know what a nested if statement is, right? And the idea is that you have an if statement within an if statement. And nested for loops are the same concept. So we have a for loop within a for loop. So let's just do that and use for I here again. So let the IDE do the work. And you can see that now I becomes J. So let's say I also want it to run 10 times, and then I'll get this code. So I have this outer for loop where the iteration goes over I as the counter, and then we have this inner for loop where J is the counter, okay? Because we cannot use I here again, we have to use a separate letter. And if we were to use another for loop in here, you see it would be K. So that's how the naming of your counter variables in for loops works. Now you could obviously also call this one counter, right? If you wanted, you could call this counter and say counter less than 10, counter plus plus. But that would be additional work that is really not necessary usually. And therefore the I is just the common iteration letter, I for iteration. And J is just the next letter in the alphabet. That's why for inner for loops, J is used as the counter. Okay, so let's go ahead and just use a system.out.println where we're going to say outer loop, and then we display I, okay? And then we're going to do the same thing with the inner loop, and here we're going to display J. And now let's just run this. And here we have 110 iterations, I believe, because we have 100 iterations for the inner for loop and 10 for the outer for loop, because the outer for loop runs 10 times. But for every single one of those times, the inner for loop will run 10 times as well. Okay, so you can see outer loop 0 starts, and then it counts the inner loop 0, inner loop 1, inner loop 2, inner loop 3, 4, 5, 6, 7, 8, 9. And then the outer loop iterates to 1. And then we start again. Inner loop 0, inner loop 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the outer loop goes to 2. So you see, this is the general order at which the code will be executed. Okay, so that's something that is pretty interesting to see. So now let's say we just display I and J, and instead of using println where we create a new line each time, we're just going to say print. So let's run this again. And now we will see 0, 0, 1, 2, 3, 4, 5, and so forth. Then we have 1, and we start at 0 again. And then we have 2, and we start at 0 again. All the way to here. We have 3, we start at 0 again. Okay, so you see how this works. Now we could obviously say that this stays print line. Then each new inner for loop will be in the same row, but each outer for loop will start a new line. Okay, so let's look at it. And there you see, so we have this statement here, and then we have a line break. Okay, so it says I is executed, then we have a line break, and then let's start this for loop. Okay, so it goes through this for loop, then it displays the new outer for loop, so this one here, so this new I, which is 1, and then it starts again from the inside. Okay, so these kind of for loops sometimes are useful because let's say you want to go through a table, right? And you have rows in the table and you have columns in the table. Now the rows would be the outer for loop and the columns would be the inner for loop, okay? And now if we were to not have a line break straight away here, let's say we don't want to have the line break here, but we actually want to have the line break after the iteration. So system out print line. So I'm not going to type anything here. It will just be a line break. We will see that we actually get this behavior. Okay. So each row now is going to be the outer for loop iteration. So this is now going to tell us which row we're at. and this is going to be the column. Now, if you want to have the row and column displayed at the same time, so to speak, what you could do is you could print I plus j. Even though if we run this, we will be surprised. Because what this actually does is it's a mathematical operation. But how could we now display I and j as separate numbers? Well, there are different ways of doing it. So we could either say I plus empty string plus j. So this would separate it straight away, or we could format it. So use printf and then use formatting. But let's just run this. And now we can see for the first row, we get the first entry, we get the second entry, the third entry, and so forth. So the first character is the row and the second character is the column. Now let's make it even more obvious where we have an empty space afterwards, and then we can see it quite well. So you see row, column, row, column, row, column. So each time the first entry is the row and the second entry is the column. So if we wanted now to read through a table and get the values from it, that's where such a double for loop would be very useful, or a nested for loop. All right. So that's pretty much it for this video. In the next one, we have a little challenge for you. So I hope you will enjoy it. It's a pretty cool, neat little project. So see you there. All right, so I hope you tried to do the challenge. Let's have a look at the results before we actually build the code, so to speak. So when I enter 5 levels as the amount of levels that I want my pyramid to have, you can see the following. So first of all, I have 1, 2, 3, 4 empty spaces, and then I have the star. Then in the next row, I have 3 stars, right? So I need 1 plus the row that I'm in. So here I'm in row 0, here I'm in row 1, here I'm in row 2, okay? So 2 times 2 plus 1 is 5, so I need 5 stars. And I need trailing empty spaces. So at the bottom here, this is the 4th row, so this is the 5th row, but row 4. So 4 times 2 plus 1 is 9. So these are 9 stars, and I have no trailing empty spaces. And I need a few preceding empty spaces, right? So here it's 1, here it's 2, then it's 3, and here it's 4. So it's 1 less than the amount of levels that I want to have. And that's the amount of empty spaces that I need. So let's build the code. All right, so let's start with the scanner, because we are going to need the scanner to get the amount of levels that we want to have. And then let's let the user know that we want to have the levels. So println, enter the number of levels, and maybe a colon here as well. And then we're going to use our scanner dot next int, and we're going to store it in a variable called int levels. So now that we have the amount of levels, let's use a for loop. So we're going to say for int I starts at 1, and I is less than the amount of levels, but not just less, but also equal the amount of levels, and we're going to increment. So with that, we're saying that we start counting at 1, and we're going to go as, well, iterate this for loop as long as I is less equal levels, which means basically as long as it's at the levels. So as long as I is 5, and less if I enter 5 for levels, for example. So that means that because it starts at 1, it would iterate 5 times. So that's the exact amount of levels that we want to have. That's why we're using I, and we're using less than equal instead of less than. If you were to use less than, you would have to use levels plus 1, for example. Okay, so that's the amount of rows that we have. Now we need the leading empty spaces. Okay, what are the leading empty spaces gonna be? Well, I'm going to use another for loop. This time it's going to start at 0, and we need the amount of levels minus I as the amount of empty spaces that are trailing, so that are at the start. So systemout.print empty space. And now we need the stars. So another for loop, And this time I'm just going to use k, even though it offers me j, which would have been fine because we're not going to iterate inside of the iteration. So we're not going to use a nested for loop, but a second nested for loop inside of the I for loop. So you could use j here, but I'm just going to use k to make it more readable. And what is the logic here now? Well, it's going to be as long as k is less than 2 times I minus 1. So that's the amount of stars that we want to have. So let's go through it. As long as I is 1, what's that going to be? That's 2 minus 1, which means 1. So we're going to have 1 star in the first row. So in the second row, we're going to have 2 times 2 minus 1. So it's going to be 3. And in the third row, we're going to have 2 times 3, so 6, minus 1, which is 5. So here we're going to just say system out.print, and it's going to be the star, like so. And then we need to go into the next line, and therefore we're going to use system.out.println. So this will now just create a new line or a new level for our pyramid. So enter the amount of levels. Let's do 7, and there we are. So we have 6 trailing empty spaces. Then we have the star. Here we have 5. Then we have 4, 3, 2, 1, none. And here we have our little pyramid. So it is a little bit of a challenge in the sense of thinking of the logic, not so much of the code, right? The code is not so difficult. It's more about, okay, what is the logic here and what is the logic here? So what are the conditions, so to speak, that we need in order for this to run correctly? All right, so even if you didn't manage to get this done, I hope you at least tried it. And it's really just about getting a feeling for loops, not so much about this iteration of the pyramids. This was just a little side project or a little funny little exercise I thought it would be nice to do. And let's go over to the next video where we're going to look at the Fibonacci sequence. Welcome back. In this video, we're going to look at an interview question, and that is to write a for loop that describes the Fibonacci sequence or outputs the Fibonacci sequence. Now, what is the Fibonacci sequence? Well, the Fibonacci sequence is a sequence which starts at 0 and 1, and every following number is the sum of the last 2 numbers. Okay, so if we look at this Fibonacci sequence here, which goes all the way to 13, it starts with 0 and 1, and then the following number is the sum of the first 2 numbers. So it's 1. Now, the following number there is the sum of the last 2 numbers, so 1 and 1. And then the next one is the sum of the last 2 numbers, so 1 plus 2. And this one is 2 plus 3, and this one is 3 plus 5. And this one is 8 plus 5. Okay, so it just goes like this forever. So now we need to write the code that leads to this output. So I want to have a piece of code which, first of all, asks the user for the amount of numbers that we want to output, and then output the Fibonacci sequence accordingly. So how can we do that? Well, we start with a scanner as always. So scanner is new scanner with system.in, and then we're gonna close the scanner. Just to make sure that we close it, we need to make sure we have the import, and then we can start getting user input. But before we do that, we let the user know that we want input. So system out print line, please enter the number of terms. Okay, and then we get the number. So we're going to use scanner.nextInt in order to get the number or the amount of terms that the user wants. So now we need to think about which variables do we need for this. And we need to have the first term, the second term, and the next term. So let's start with first term, and that will be 0 by default, or we set it to 0. And we need the second term, which will be 1, okay? Because that's the rule. So you start with 0 and 1. And afterward, we need to override those first and second terms and next terms and so forth. But first of all, let's take care of edge cases. So what if the user just enters 1? So if n equal 1, then we're just gonna system out print line. So here, and we're gonna say first term. So we just display 0. And else we're going to display first and second term and then all the other terms. So we're going to say system.out.println, and we display the first term plus an empty space plus the second term. So in this case, it would be 0 and 1. But now that's where our loop comes in. So now we're going to have a for loop here, and the for loop will start at 0 and it will go all the way to less than equal n. So whatever the user has entered. So we could have called this one user input, but I'm just going to call it n. So this for loop now is going to start with I being 3 because 1 and 2 we already have. We have the first term and we have the second term. Now we need the third term, and then we need to go from term to term. So here we're checking 3 less than equal n. So if we entered 3 as the user, then we are going to run this for loop. If we entered 2, for example, then this for loop wouldn't even run. If we entered 5, then this for loop would run because 3 is less equal 5. Okay, so with that out of the way, let's look at the variable that we need to calculate. We need to know what the next number will be. So we need to get this number here. Therefore, we can just go ahead and say first term plus second term. So this one here is first term plus second term. And then we can display the next term. So system.print, and actually here we need to make sure that we print and we don't print a new line because we want it to be all in one row. So print or outprint, maybe that's better. So here we're going to say empty space plus next term. And the next part is really where the logic comes in. So that's where the important thing happens. And that is where we are overwriting the first term with the second term and the second term with the next term. So let's think about what's going on here. And let's do it with iterations, okay, step by step. So we have this for loop. We start with I3. Let's say we entered 5. We want to have 5 numbers. So we have 0, 1, 1, 2, and 3. We want to go all the way there. So we start with first term being 0, second term being 1. Okay, so let's look at this for loop. Let's look at what's going on. And actually, let's just go ahead and add a line break and run it. Okay, please enter the amount of terms. Let's say we want to have 6 terms. Press enter and we get into it. So we know n is 6, first term is 0, second term is 1, I is 3. All right, so let's step into. So we have this next term, which we're calculating now. So it will be a new variable, which is 1. So then we're displaying it. We're setting the second term, which was 1, to be first term. So first term in the next iteration will be 1. And then in the next row, we're setting the next term, which currently is 1, as being the second term. So it's going to be 1 as well. So we can see that second term is 1, next term is 1. So we run it again. So we get into the for loop once again. This time we're calculating 1 plus 1. So next term will now be 2. So you see here, next term is equal to, we're displaying the next term, and then we're reassigning again. So now we're saying, so before first term was 1, now it's going to be 1 again, because here second term is still 1. So we're going to assign 1 to first term, and second term in the next run will now become 2. So you see currently it's 1 and second term is 2, but after this iteration, and you can see that down here, second term will turn 2. So if I go to step into, you see second term turns 2. So now let's go into it again. So here first term is 1, second term is 2, and in the next row we're displaying next term, which is 3, and then we're setting first term to be the old second term. So we are setting the value that was 1 to be now 2. And in the next row, we're saying the second term, which was 2, now should be 3. So second term in the next iteration will become 3. So you see now it's 3. And in the next point, it should become 5. I think I entered 5, right? No, I actually entered 6. Good. So we should get this 5 as well. So we're checking, is 5 less than 6? Here, it's true. So let's reiterate once again. So we know first term is 2, second term is 3. So next term will now be 5. So we run it again, we display 5, and then we say, cool, first term was 2, second term was 3, so now first term will be 3, and now let's override second term as well. Second term was 3, but next term is 5, so second term will be 5 now for the next iteration. And yeah, with that, we are done. So let's look at the console, and we see we get our 6 values. So we get 0, 1, 1, 2, 3, 5. So we have the Fibonacci sequence here. Now let's run this again, but without debugging. And let's actually run it with, let's say, 10 numbers. So 10 terms. And there we are. So 0, 1, 1, 2, 3, 5, 8, 13. And 8 plus 13 is 21. 13 plus 21 is 34. So we have our Fibonacci sequence. So this was a little interview exercise. I hope you got the idea behind what the logic was. And sometimes it's really just that. And this trick with overwriting old values for the next iteration is really, really valuable and very important when you are working with loops. So it often comes in handy to have this skill available to you. So now that we have seen that, let's look at other loop types as well. Welcome back. In this video, we are going to look at the while loop. And the while loop is just a different type of loop that we have available in the Java loop arsenal. And the code works like this. So you enter while, and then you have the condition that needs to be met. So here we have the condition. And if the condition is met, this code will be executed. So code to execute. And what's really important is that we somehow need a situation inside of the while loop that leads to the condition to not be met at one point. So something that makes sure we don't end up in a infinite loop or in an infinite loop. So what is an infinite loop? An infinite loop is if we are running some code that runs indefinitely. So here, if I were to say system.out.println, and I'm going to say this is never gonna stop. So this here is an infinite loop because this condition in here will never stop. True is always true because we're never setting it to false. This while loop will run indefinitely. So let's run it. And you see, this is never gonna stop. And it just keeps going and going. And the thing is, that eventually this will lead to a crash. Well, depending on the hardware that you're running it on, it could take forever, but usually this will potentially or eventually lead to a crash. So you see we have like thousands of iterations, or well, depends on the speed of your PC. So this is an infinite loop. You should avoid this at all costs, never do that. So we need a way to make sure that this condition right here can be set to false inside of the curly brackets, so inside of the body of the while loop. A very simple one would be to just create a counter like we did with the for loop. So we can create a counter with a while loop, even though that's not what the while loop is for. But let's just say we want this to count from 1 to 5. So we could say as long as I is less than or less equal 5, then let's go ahead and execute this code where we're going to display I. So we're just going to say I. And now we need to make sure that this at one point is going to be not true. So this condition is not true. How can we make it not true at one point? Well, either we just say I equals 10. And when we do that, this will only run once. So let's run it. And you see it just displays 1. However, if we just increment I, like we would in a for loop, then this will run 5 times. So 1, 2, 3, 4, 5. Okay, so this while loop can be used as like a for loop, but it is a lot more powerful. It has a lot of really cool features to it. Number one being, let's say we're using the scanner. So here, scanner equals new scanner. And we're going to use system in. And the import is happening automatically for me. And then I'm going to use the scanner here to close it. Just good practice. And now let's go ahead and use the scanner to get user input. So let's say scanner.nextInt. And we're going to store this in a variable. So user input. So let's also let the user know what the user is supposed to do. So system.out.println, please enter a number 0 to stop running this program. Okay. So now this would be code that we could execute inside of this while loop, because we want to let the user know to enter a number, and we're going to just display the number afterwards. So what I'm going to do is I'm going to set the user input to -1. And what we're going to say is, as long as user input not equal 0, what we want to do is we're going to run system.out.println. We're going to let the user know, please enter a number. And we're going to override user input with scanner.nextInt. Okay, so now this will now run until we enter 0. Okay. And let's also print out what the user just said. So system.out.println, you entered, and then whatever the user input was. So let's run this. So please enter a number 0 to stop running this program. So let's enter 5. You entered 5. Please enter a number 0 to stop running this program. Okay, let's enter 13. You entered 13. Please enter a number 0 to stop running this program. So let's now enter 0. And you entered 0, and you see processed finished with exit code 0. So we now know how to create a little piece of code that gets user input until the user doesn't want to keep going anymore. So that's what a while loop can really help you with. And I set it up this way by making sure that at one point, this condition that I have here is not true anymore. So we could have done this with strings as well, but I just used whole numbers. You could have done something like stop as the user input. So as long the user input is not stop, just keep going and let the user enter some data. And this data could be data that is then stored inside of a table or in a file or something like that. Even though we haven't touched these topics yet, we don't know how to write something and put it into a file or put it into a table yet, but that's something that we're going to cover later on in the course. So this was just an idea as to how you can use the while loop. Now, obviously you can also have an if loop inside of a while loop. You could have while loops inside of while loops. You could go all kinds of crazy with whatever you want to put inside of these curly brackets. The only thing that you need to make sure, if you want to get started with the while loop doing anything, this condition needs to be met at the start. And we need to make sure that this condition is unmeetable or changeable to the point where it's not met anymore inside of the curly brackets. This can be either done that it happens automatically, or it could be, for example, as soon as the file is fully read, there is no more lines to read from the file, close the program or get out of this while loop, or as we've seen here with user input, telling the user what is the condition that will stop executing this entry, this while loop. And yeah, that's pretty much it for this video. So see you in the next one. Welcome back. In this video, we're going to look at the do while loop, and the do while loop allows us something that the other loop types don't, and that is to execute our code regardless of if the condition is met or not. So let's have a look at how this works. First of all, the syntax. So we have this do keyword, then we have the body of the do while loop. So the code that should be executed at least once, but then potentially multiple times based on the condition of the do while loop. Then we use this while keyword, and then within parentheses, we have the condition followed by a semicolon. Now this condition could be anything that leads to a Boolean result, so either true or false at the end. So let's have a look at a counter. So let's just create a counter here, and I'm just going to create int I is going to be 1, and then I'm going to display system.out.println with I, and I'm going to have the condition I is less than equal 5. So this here would still be an infinite loop because I is 1 and 1 is always less than 5. So because this is always true, this would lead to an infinite loop. So we also have the same rule that we had with the while loop, where we need to make sure that the condition at one point will not be true anymore. So it can be true at the start, but at one point, the code body of the do while loop needs to lead to a situation where the condition is not true anymore. This could either be through user input, this could be through, for example, the amount of rows that you have in a file that you go through, or this could be just a counter as we have it here, where we're just saying I starts with 1, we increment I each time that this code is executed, and then at one point this condition will not be true anymore, and this do while loop will stop running. So let's run this once to get a feeling for it, and we see it says 1, 2, 3, 4, 5. That's good. So now how does it differ to the for loop and the while loop? Well, the cool thing is, even if this condition down here is never true or never met, this code here, so the code body, will always be executed at least once. So let's run this, and we can see it says 7. So it displays the 7, the I, even though this condition isn't true or isn't met, this condition here specifically. So what we're doing is we are saying, you know what, I don't know if the condition is met or not, but I want you to execute this code once and let's see what's up there. Okay, now let's take the example with the user input that we had last time and see how the do while loop would be handy here. So what I'm going to have is I'm going to have a variable int input, and I'm not going to initialize this value. And I'm going to get rid of this int, and I'm going to just say, as long as input is not equal 0, run the code inside of this do while loop. So what are we going to do? We're going to let the user know that the user is supposed to enter a number. Please enter a number 0 to exit. Okay, so that's what the user should see. And then what we're going to do is we're going to use a scanner variable. So scanner equals new scanner system.in. So we're going to use this scanner variable to get the next int. And let's also close the scanner at the end just to keep it clean. So now we're going to get the user input, and let's go ahead and display the user input. So system.out.println, thanks for entering plus input. Okay, so now the cool thing is we never initialized input before we ran the do while loop. We are going to initialize input inside of the do while loop. So we didn't have to ask the user for the input before we even ran the do while loop. We're going to run the do while loop regardless. So then we can just go ahead and run it. So it says, please enter a number 0 to exit. So let's say 5. Thanks for entering 5. Please enter a number 0 to exit 3. Thanks for entering 3. Please enter a number 0 to exit. So let's enter 0 and thanks for entering 0, and then we just close our program. So you see that we could run this without even having to set this variable up beforehand. And that is really the main advantage of it, because sometimes it's just cleaner to do it this way. Okay. All right. That's it for this video. See you in the next one. Welcome back. So in this video, we're going to see how we can alter the flow of loops. And this is working for loops, while loops, and do while loops. And we're going to do that using the break keyword, and then in the next video, the continue keyword. So the break keyword allows us to break out of the current loop, whether that's the for loop, a while loop, or a do while loop. So let's look at how this works. So we have this for loop here, right? And it just counts from 1 to 5, right? Very simple loop, 1, 2, 3, 4, 5. And now what we can do is we can have a check here where we say, if I is equal to 3, then let's break out of it. So break, like so. Okay, so let's have a look at what this is going to do. Let's run it. And we see it just displays 1 and 2. So this break keyword just said, okay, you know what? Stop this for loop altogether. So let me write some text here after the for loop. Let's run it again, but this time without this if statement. So you see, after the for loop comes after 1, 2, 3, 4, 5. Now if we add it back in, it will just go to 1, 2, and then it says after the for loop. So why is that? Well, that's because this break keyword has one role, and that is to get out of the current context. And the current context in this case is the loop that we're at. So it just says, okay, let me break out of the for loop that I'm in. And we saw that with break, or this break keyword, in the switch statement as well, right? So we are using break in order to get out of a switch statement, or we're using break in order to get out of the for loop here as well. And the same goes for do and while loops. So why would you use this? Because this is really like, this doesn't make sense. Why wouldn't we just say, okay, I up to 2 if we know that? Well, the thing is, in this example, we know exactly what's going on. We have all the information. But let's say we are going through a file and we want to read all the Excel sheets table information, such as all rows and columns. So let's say we have this file, and in row 20 and column 10, we have this value that we have been searching for, and we don't want it to go through any other rows and columns anymore. So we're just going to take that value. We're going to have an output. So we could just say here, system.out println, we gotcha. So we got the value and we can get out of the whole loop. We don't need to iterate through the rest of the file, which could take forever, right? You never know how long this file is that the user is uploading, for example. And then we're going to say, we got what we wanted. Now let's break out of it. Let's not keep going with the execution of the code of scanning through the file. This is just one real world example that you could think of, but there are plenty more. So we're going to get a feeling for this step by step while building more and more software. So don't worry too much about it. Just memorize, okay, the break keyword gets me out of the current loop. Okay. So with that, let's look at the continue keyword in the next video. All right, so in this video, we're going to look at the continue keyword, which is just another keyword that we can use in Java in order to control the flow of a loop. So let's jump into the example of the last video. So we were printing out something, right? And what we're going to do is we're going to say, instead of break, just continue. So now what is it going to do? Well, the continue keyword is just going to say, you know what? Stop right where you are for the current iteration of the for loop or the loop that you're at, and jump to the next iteration. So in this case, we're saying int I is 1 and we count all the way to 5. However, at the point where I is equal to 3, continue. So it's not going to execute this piece of code, which actually prints out the number for 3. It's only going to do that for 1, 2, 4, and 5. Because at the moment that this continue keyword comes up, it jumps directly to this point in the code, which then increments I by 1. Okay, let's look at it. Let's run it and see what's going to happen. So we see 1, 2, 4, 5 after the loop. So what we could do here is we could say system.out.println, we ignore this one. Okay, so what it does is it just ignores whatever we wanted to do at this point with each of the numbers. We're ignoring it for that particular number. Okay, so let's run it again. And we see 1, 2, we ignore this one, 4, 5 after the loop. So this could be useful, again, looking at the file example. Let's say that there are certain keywords that you want to ignore when you are copying from one file to another. Or there are certain conditions. If those are met, you don't want to copy something from the file to another. And these conditions could be anything. It could be a certain row in the file. It could be a certain keyword that is in the file inside of a certain row or whatever. Okay, so these are just some examples where the continue keyword comes in. But now you know how it technically works, right? Technically, the only thing that it does is it just says, you know what? I'm going to stop the execution for the current iteration of my for loop, and I'm going to go to the next iteration of the for loop. Now, there is one thing that you can test just to see that this is actually going to happen. You see, if you put some code after the continue code or this keyword, you see you get an error because it just says this is unreachable code. So delete unreachable statement. So this is not reachable because it just says, you know what? You're saying continue, so I'm just going to jump to this part. So whatever you have after continue will never be executed. So why doesn't it bother about this line here? Well, because this line will be executed. It will only not be executed in this if case scenario. All right, so that's it for this video. Now you've seen another way of controlling your loops, and see you in the next video. In this video, we're going to look at labels. And the cool thing is you can label your loops. So let's have a look at this example here. So I have a for loop which loops to 3. And then I have an inner for loop which also loops to 3. And then I have this if statement here where it says if I equals 2 and j equals 2, then break. Okay? So what will this break do? Will it break out of this for loop or will it break out of this for loop? Let's have a look. So let's run this and we're going to see something printed out. So that's what this statement does here. It says system out print line I and j. Okay, so we see here 1 1 1 2 1 3 2 1 and then no further 2's, right? It jumps directly to 3 3 1 3 2 3 3. So what this break did is it broke out of the inner for loop. So how can I now break out of the outer for loop with this break? Well, I can achieve that by using labels. So labels work like this. So you give it a name. So let's say this is the outer loop and you use the colon. So now we are labeling this for loop here, the outer for loop, as the outer loop. So this is the name of it. So this is a label. And now this inner here, I'm going to say this is the inner loop. Okay, I'm going to label that as well. This is another label. And now I can use this break statement here to break out of the outer loop because we saw by default it broke out of the inner loop. Now at this point it will break out of the outer loop. Okay, let's run it again. And you see it says 1 1 1 2 1 3 2 1 and then it stops right there. So it breaks out of the outer loop entirely instead of just out of the inner loop. So that's really the idea behind the labels. So we can also use the same thing for the continue keyword. So let's say we have the continue keyword here instead. By default, it would continue out of the inner loop. So you can even see that when you hover over continue, you can see that 4 is marked. So 4 it has this background here, right? It indicates that this continue will go for this for loop. So now if we hover over continue with outer loop labeling, you can see that suddenly this outer for loop is now underlined with this color or has this colored background. Okay, so that's the cool thing about the indication that we get from our IDE. Now let's test this without the outer loop keywords. And we will see we have 2 1 but no 2 2. We directly jump to 2 3. Now if we have the outer loop now, we're going to see we jump from 2 1 directly to 3 1. So we didn't go to 2 3. We directly jumped to 3 1. That's because we jumped out of the inner for loop directly to the outer for loop. That's what this continue keyword did with the label in combination. So that's pretty much how labels work with for loops. Pretty cool tool. And this really answers the question as to where does a break out of if we're using inner loops and maybe even more nested loops, right? Multiple dimensions of nesting. So triple nesting or quadruple nesting or something like that. What does the break do? Well, it breaks out of the closest context of the closest loop. And if you want to have more control over it, you need to use labels. So that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at how we can answer the job interview question about the Devin number or the Harshad number. So it basically is really just the sum of the digits of a number, whether that is divisible through the number itself. So for example, 156 in total, the result of the digits, so the sum of the digits is 12, and 156 is divisible through 12, which is why 156 is a Harshad number. 300 is the same story. So 300 in total has the sum of digits 3. Is 300 divisible through 3? Yes, it is. So let's have a look at how we can build this. So first we need the scanner, right? Scanner equals new scanner, and system in, because we want to get the user input. The user should enter a number, and then our program should tell the user whether it is a Harshad number or not. So next we need a number that I'm going to call user input num, okay? And we're going to tell the user to enter a number. So please enter a number. And entere is not what we want to enter. And then we're going to say user input num is going to be scanner.nextInt. So we get the number of the user. So now what we're going to do is we're going to store this number that the user entered as the original number, because we need to then separate it or manipulate it to compare it later on. So I'm going to create a variable which I'm going to call original number, and that will be our user input num. And then I need a variable which will hold the sum of digits, and I'm going to initialize that with 0 as well. So now the next thing, that's where the while loop will come in. We're going to say while the user input num is greater than 0, let's get rid of the last digit of a given number. So let's say we have 156. How can we get rid of this 6? Well, by dividing 156 through 10 and taking the remainder. So that's where modulo comes in, right? So 156 divided by 10 is 15, remainder 6. So there we have our 6. And how do we get it? We get it by using our good old friend, the modulo operators. So we get the user input modulo 10. So this will now give us the user input num divided by 10, but then it's remainder, and it's going to add that to sum of digits. So it's going to add it to the old sum of digits. So in the first iteration, it's going to add 6. In this example, 156. In the second iteration, it's going to add the 5. And in the last iteration, it's going to add the 1. So at this point, we need to, however, make sure that we divide the user input num by 10 at this point. Okay, and there you see we are manipulating user input num, which is why we stored it in a separate integer so that we still know what the original number was. Okay, and at this point, we just have to do a simple check. We can compare if the original number modulo sum of digits is equal 0. So if there's no remainder left, then we know that this number can be divided by the other number. So we know that the original number 156 is divisible through 12 if the remainder is 0. And if that's the case, then we know we have a Harshad number. So system out, the print line, the number is a Harshad number. Okay, and Harshad is a good old friend, so we write his name with a capital H. And otherwise, we're going to say the number is not a Harshad number. The number isn't, so isn't a Harshad number. So let's test this out. Let's enter 156, because 156 is 12, so the sum of the digits, and 156 divided by 12 is a remainder 0, so it is divisible. So the number is a Harshad number. Let's run it again, this time with 300. The number is a Harshad number. Let's try it with 301. And it says the number isn't a Harshad number. Now let's take 1. And 1 is a Harshad number because 1 is divisible through 1. Okay, so this is another little exercise for you. So now you're ready for another job interview question. Okay, now the idea obviously was that you thought about this yourself and took all the skills that you had at this point and put them together. And really the biggest challenge, in my opinion, when thinking about it, was to think of modulo and create this while loop with this plus equal sign. Okay, So I hope you enjoyed this challenge and you were able to do it by yourself. If not, really try to understand it in its fullest, and see you in the next video. Great job! We covered for, while, and do while loops and learned how to control loop execution with break, continue, and labels. You also built a pyramid and a calculator with loops. Tomorrow we'll shift gears and get into arrays, learning how to store and manipulate collections of data efficiently. So, see you tomorrow. Welcome back. Today we'll be getting into arrays, which allows us to store multiple values of the same type in a single variable. We'll start by learning how to declare, initialize, access, and modify arrays. Then we'll explore using for loops and enhanced for loops to iterate over arrays. We'll also cover key array operations like finding the sum, minimum, and maximum values, and rearranging array elements. We'll also look at some helpful methods from the arrays class, like toString, sort, and binary search. To wrap up, you'll complete a fun array shuffle exercise to put what you have learned into practice. So let's get started. All right, welcome to the Arrays and Array Lists Day. So today we're going to dive deeper into arrays and array lists, which are just a data type that allows us to store multiple pieces of data in one variable. And this is super useful. So we're going to see how that works, how we can manipulate those arrays, how we can use array lists, how they differ, and a lot more. So let's get started. So what is an array? Well, an array in Java is a data structure that allows you to store multiple values of the same type, that's really important, in a single variable. Think of an array as a collection of variables that are accessed with an index number. Arrays are useful for storing data that can be processed in a loop or accessed randomly using their index. In order to declare an array, you need to specify the type of elements it will hold and the array name followed by square brackets. This declaration doesn't create the array itself, it only declares a reference to it. To initialize an array, you need to allocate memory for it using the new keyword and specify the size of the array. Imagine reserving a specific place in a storage for holding values of the same type. You can also declare and initialize an array in a single line. You can initialize an array with values at the time of declaration too. This allows you to set up the array with a specific set of values from the start. But you don't have to, so it is optional. In order to access array elements, you need to use their index, which starts from 0. So you can retrieve and modify elements using their index. A common way to process each element in an array is by using loops. The for loop and the enhanced for each loop are commonly used. So if you want to use a for loop, you need to iterate over the array elements by using an index counter. We're going to see how that works. But then there is also the for each loop, which is another array traversing technique that was introduced in Java 5. It simplifies the process of iterating over the array by automatically handling the indexing. And the indexing is something, if you are not careful, can lead to errors, right? It can crash your program basically. So that's where this for each loop, which is a different type of loop, is very helpful. Now there are some common array operations. One of them would be, for example, to get the length of an array. So if you want to get the length of an array, you can use the .length attribute, which returns the number of elements in the array. Now we are going to look at what attributes are when we are going to look at object-oriented programming in a later day, within a week or so. But for now, just think of it as a way to get the length of an array, which just means the amount of elements that you have in there. Later on, we're going to see how to create our own attributes and how to work with them. So then, in summary, you could say arrays in Java are essential for storing and managing multiple values of the same type. By declaring, initializing, accessing, and looping through arrays, you can effectively handle and process collections of data in a structured and efficient manner. And with that, I would say, let's jump into a demo and see arrays in action, because otherwise it would be a little bit too much theory before actually seeing any of that in practice. So let's get started. Welcome back. So in this video, we're going to declare and initialize arrays, as well as see how we can modify arrays values and how we can get the value out of an array. So let's get started. The first thing is you need to define the data type you want to use for that array. So an array can only hold data of one data type. So if you decided that the array will hold integers, it cannot hold, for example, strings or doubles or anything else anymore. It can only hold ints. Then you need to use the squared brackets indicating that this is an array. So this is going to be a variable that will hold multiple items. And then you can give it a name. And it's common practice to just use a plural name. So for example, numbers. So instead of number, we're going to use numbers, indicating that it is a plural. Well, it is an array, so to speak. So then you can either say, okay, that's it, that's the declaration, or you can also initialize it straight away. You can, however, also initialize it later in the sense that you can set up space inside of the memory for it. So here at this point, we are declaring it, but not yet associating space for it. So not yet taking space, okay? It will only take space / take memory once we have used the new keyword or we have otherwise created the array, okay? So here I can say new int and then define how many values I want to have inside of this numbers array. So this is one way of initializing it. However, you can also initialize it directly after declaration. So you can do that by using the curly brackets here and then just assigning a few values straight away, like so. So this is declaring and initializing at once in one line, so to speak. So now how can I access an item of that array? Well, you can do that by using, let's say we want to store one of the values of that array in a normal variable, so in a normal int variable, so a non-array variable. We would just say int first num, for example. And if we want to get the first number of our numbers2 array, for example, we need to use the squared brackets here and we need to use the index number here. So this now here will not give us this 1, it will actually give us this 2. Why is that? Because indexing in programming starts at 0. Humans start counting, usually in most cultures, start counting like this: 1, 2, 3, 4, 5. All right. But developers or languages, programming languages, they start counting at 0. So it's 0, 1, 2, 3, 4. So these are the index numbers. Let's check this out and see this in action. Okay, so system.out.println, and we're going to display the first num. So let's run this and see what's up. And you see, I get the 2. So I get this value. So this is not actually the first number. If I wanted the first number, I would have to use 0 here. So let's run it again and actually get the first number. And we see the first number is 1, and it is inside of our numbers2 array. Our numbers array doesn't yet have any values. It just has allocated space, but there are no values defined for it yet. All right. So with that, we now have an array. We can access its values and we know how we can then, well, display them using the variable. Obviously, we could have also just used this here directly as well. Numbers2 at index 0 will still give us this 1. Okay. So basically an array has it like this. Okay. So index 0, index 1, index 2, index 3, and so forth. Okay. These indices are not necessarily the values that are in there, as we can see here, right? So the values could be anything. Let's modify it actually. Let's change the first number before we get the first number and display it. So let's change numbers2 at index 0. All right. In order to do that, we need to say numbers2 at the squared brackets position at the index, let's say 0, should now be 420. Okay. So now let's run it again and we should see 420. There we are. Why is that? Well, what we're doing is we're creating this array here. So we're declaring it and initializing it. So we are giving it values directly as well. Then we are modifying the first entry of that array. So the first entry is at index 0. We're changing it to being 420 instead of 1. And then we are using that index 0 of our numbers to store it in a different variable. And at that point, we're then displaying that variable. And that's why we're getting this 420. Now, this is really just to show you how it works technically. Obviously, this code is useless, but it's more about the idea as to how you can access an array and how you can modify the values of an array as well. So I would say with that, it's good enough. Let's see how we can iterate through a loop. And there are two different ways. So we're going to see how to do it with a normal loop, and then we're going to see how to do it with a for each loop later on as well. So see you in the next video. Welcome back. In this video, we're going to learn how to iterate through an array, which means how to get through every single item within an array and do something with it if we want to. All right. So how would we do that? Well, there are two different ways. One is the for loop and the other one is using the for each loop. So we're going to start using the for loop because we know that one already. So let's get started. Therefore, what we're going to do is we're going to use a normal for loop. However, we need to define how often we want to iterate through numbers. So how often we want to actually do what we want to do. So in this case, there are 5 items inside of numbers. And we know that because we have it available straight away, right? However, we're going to see that this can cause problems in a second. So let's say we just want to go through it up to I less than 5. So we're starting at 0 and we're going to go up to I less than 5, which means up to I being 4. Okay. So if we're looking at indexes, that's perfect for us because that's index 0, index 1, index 2, index 3, and index 4. So we're going to go through every single index. So we have seen how we can access an item of an array. Do you recall? We would use numbers and then squared brackets and the index that we want to use. So for example, 0. This would give us the first entry of an array. So let's just see how that works. System.out.println, and let's just use numbers at index 0. So this is how we can get the first entry. So how could we get all entries by iterating through it? Well, let's just do one simple thing and replace 0 with I, because I is going to be 0, then it's going to be 1, then it's going to be 2, 3, and 4. Okay, we've seen that before. So now let's run this and we will see that we will basically go through our entire array. Now let's change the numbers up a little bit so that it doesn't look like we're just running a normal for loop that just counts the numbers up, right? So let's do it again. And we see we actually get the numbers from the array. All right, that's cool. But then there is a problem with what we're doing right here because we cannot do that in case the array that we want to go through has less than the amount that we're using here. So what do I mean with this? Well, let's actually use 6 here instead. Even though we only have 5 items, now we're going to iterate through this for loop 6 times. And this will crash our program. So let's run it. And there we are. So it goes all the way until it crashes. So then it crashes at line 7, which is this line here, system out print line, and it says array index out of bounds exception. So if you ever get this error, this means that you're trying to access an item of your array that does not exist. Okay, array index out of bounds exception. So if your array only has 5 items in it and you're trying to access position 20, you will get this error. If you're trying to access index 5, you will still get that error because index 5 is the 6th position within a 5-length array. So let's fix that and actually see it without this for loop because we can run into this problem without the for loop either. So let's go ahead. So here I'm going to access position 6 manually. You can even see the IDE is already telling me, hey, you're doing something wrong here. Array index is out of bounds. So let's run it. And we are going to see that it crashes straight away. So it says index out of bounds exception. So it can't even handle that line because we're trying to access something that doesn't exist. So how can we get our way around this? Well, I said it in the presentation. There is this one attribute that we can use for arrays that gives us access to the length of the array. So the amount of items in the array. And that is the .length attribute. So this here will give us a number, okay? It will display a number and you can see that by hovering over length. And you see here. So public final int length. So this public final, we're not going to go into for now. What's interesting is this int, which means it will give us an int back. So if we're using numbers length, we will get an int. Okay, so let's now use this and display it on the console. Let's just see how long our array is. And I'm going to comment this out. This for loop is not going to do anything. And now I'm going to just say array length is, and then plus numbers length. All right, so let's run this. And we see the array length, and I think I misspelled it, I always do, and it is 5. So let's change it. Let's add another item in here. Let's say another number in here. So now the length will be 6, because there are 6 items in here. 1, 2, 3, 4, 5, and 6. So that's what this length attribute does for you. So how can we now combine this knowledge with the knowledge of how we can iterate through an array with the for loop? How can we combine that? Well, we can use it up here, because that's the amount of times we want to iterate through it. And we saw if we have 6 items in the list and we go less than 6, it will run 6 times if it starts at 0. So that was a long sentence, but let's just try it out, okay? So instead of using less than 5, let's just use numbers.length. And then let's use this system out println statement with numbers at the I position. Now let's run this code, and we're going to see we don't get into an error, and it will always iterate the exact amount of times that we have items inside of our array. Okay, so it says array length is 6, and we get 1, 2, 3, 4, 5, 6 iterations. So with that, you now know how you can access items inside of your array using a for loop. So get access all items of your array. So now, how about we multiply every single item in the array before we display it? Okay, so there are different ways. You can pause the video and try this. I would really recommend it. So basically what I'm going to say, we're going to say numbers at position I is going to be numbers at position I times 2. Okay, so now this will just give us the number itself. So here we are accessing the number in order to multiply it, and here we are overwriting it with the result of this multiplication, and then we're displaying it. So you could have said, well, we could say, well, Dennis, yeah, you're modifying an item and then you're displaying the result before you're modifying all items and then displaying the result. Well, yes, we could have done the second as well by using a second for loop here that will only take care of displaying the for loop that will come out of this. But here what we're doing is we are actually doing both things at once. So let's see this in action. So we see we get 2, 24, 66, 90, 10, 14. And I think that's pretty much double of what we had here. So after this point, so at this point here, numbers, all of the numbers in the numbers array will have doubled. So they are now going to be double for the rest of the program, so to speak, unless you obviously modify them again. Okay, so with that, I would say we are ready to look at a for each loop. Okay, and when I modify this code out, you see it says for loop can be replaced with enhanced for loop, which is a for each loop in other programming languages. So let's look at that in the next video. Welcome back. So in this video, we're going to look at the enhanced for loop or the for each loop. Both ways are fine calling this thing. And in Java, however, officially in the documentation, it's called the enhanced for loop. So let's look at it. Therefore, let's hover over this for keyword here, and let's just see what the syntax is for an enhanced for loop by clicking on this little icon here. And there you are. It just says int number in numbers. So what's going on here? Well, the thing is, numbers is what we want to iterate through, right? We want to go through every single item of numbers and do something with it. Now, what this enhanced for loop does is it says, okay, I'm going to iterate through every single item in this array called numbers. And then we have the colon separating it from how it's going to handle every single item. So what it's going to call it and what the data type is going to be. So numbers is an int array. So every single item inside of an int array is an int. So now it just gives it the name of number, saying that every single time that I'm going to refer to the items inside of your array, I'm going to call them number. Okay? So this number here in the first iteration of this for loop, so this enhanced for loop, will be 1. In the second iteration, it will be 12. In the third iteration, it will be 33, and so forth. Okay? So that's what this enhanced for loop does. And you can even check it out. You could even have a counter. So int counter equals 0. And you could just say system out print line. Counter is at, and then plus counter plus plus. So what this will do is it will display the counter, and then it will increment it for the next iteration. So let's run it, and we will see it says counter is at 0, 1. Counter is at 1, 12. Counter is at 2, 33, and so forth. Okay? So that's what happens inside of it technically. So let's test it out again, but this time let's use another for loop, because I think this might be a little bit overboard with just moving from our normal for loop to the enhanced for loop without an additional example. Okay, so now let's look at another example to get a better feeling for this. Therefore, I'm going to create a string array, right? So string, then again, we use the squared brackets. After that, I give it a name. So I'm going to call this one friends. And in here, I'm going to put my friends, my list of friends, which I'm going to do like so. So I'm going to have Nasrin in there, which is my wife. She's my best friend. Then we have Yannick, for example. Then we have Osama. We have Jens, and so forth. Okay, so these are just a few of my friends. And now I'm going to take those friends and I want to welcome them, or I want to invite them to my party or whatever. Okay, and how would I now use a enhanced for loop for that? Let's try it out. So let's use the for keyword, and then let's use the colon friends already. Okay, so we know that we want to iterate through my friends. Now, what is the data type of friends? It's a string array. It's not a string, it's string array. But what is the data type of every individual item inside of my string array? It is a string. So what I'm going to do is I'm going to use the string keyword here. So now I give this a name. So what would be a good name for an individual friend? Well, friends singular. Well, it would be friend. So now I'm going to go through every single friend and going to invite them. So I'm going to say system.out.println welcome to my party, and then plus friend. Okay. Now let's run through this and see this in action. And we see, welcome to my party, Nasrin. Welcome to my party, Yannick. Welcome to my party, Osama. Welcome to my party, Jens. You see, it just goes through all of them and now invites all of them, or welcomes them to the party. Now, obviously, we could have invited them first. So let's invite them first. So I'm going to put that in here. I'm going to say, please come to my party. Come to my party, friend. So let's run this again. Obviously, we could have used different for each loops for that. So we're going to say, please come to my party, Nasrin. And then she comes and we're going to say, hey, welcome to my party, Nasrin. Obviously, it would be better if we had invited them first in a separate for each loop or enhanced for loop, and then welcomed them to the party. Because right now, how it currently works is I asked one person to come and welcome the person. Then I asked the next person to come and welcome that person. So maybe I should ask everyone to come before I welcome them individually. However, you get the idea of what for each loops look like. And now you've also seen how to create an array of type string and how to store information, or like how to initialize that array. All right, so in the next video, we're going to look at some cool things we can do with arrays as well. So see you there. Welcome back. In this video, we're going to calculate the sum of an array as well as see what the minimum and maximum value are. So you can try this by yourself. You should be able to do that with what you have learned so far. You will need to think about it a little bit, however, but let's just get started. And I'm just going to use an enhanced for loop here. So for int number in numbers.
So you could read it like this: for int number in numbers, what we're going to do is we're going to build the sum. So let's go ahead and create a sum variable. And then let's just say sum is going to be number, and we're going to add number to the existing sum. So plus equal sum. Therefore, however, we need to initialize sum to 0. Otherwise, this doesn't work because, well, it doesn't know what it should add to. There's nothing. So you can't add something to nothing in the coding sense. Okay, that's why 0 is not nothing. It is actually the starting point, so to speak. Okay, so this will now give us the sum of all of those numbers inside of the array. And let's print it out. So system.out.println, and sum is, and then the sum. Okay, let's see what's that gonna be. And it's 103. So it's 1 plus 12 plus 33 plus 45 plus 5 plus 7. So now how could we find out the maximum number or the minimum number? Well, in order to find out the maximum number, so let's go ahead and create an int max, which will be numbers at index 0. So we're just assuming that the first number is the highest number. And then we're assuming at the same time that the first number is also the lowest number. That's just an assumption. Now with our for each loop, or our enhanced for loop, we're going to iterate through numbers. And what we can do is we can just say, you know what? The new maximum will be the next number if it's bigger than the current maximum. So we can just say if the number is greater than max, then max will be number. Okay, that's pretty much it. That's the logic already. And then we can do the same thing for the min. So if number is less than min, then min will be number. Because in the case that number is less than the old minimum number, the number that we're looking at has to be the new minimum number. And we do that because we're going through the for loop here. We'll do that again and again and again until we get to the final point where we know, okay, we've checked all items, and every time there was an item that was smaller or lower than the item that I looked at before and I considered being the lowest, I know that I have figured out my lowest number. And now I'm getting a warning here. That's just because the first entry is in fact the lowest number. So it already knows that numbers 0, so numbers at index 0 is the lowest number. So let me just add another one that is lower, 0. And you see suddenly the warning disappears. It was just to tell me, you know what, this doesn't do anything because you all have already figured out that there was a minimum number. So with that, we already know the min and the max number. Okay, so let's just display it. Min is plus min and max is plus max. All right, now let's run it. And we see the min number is 0 and the max number is 45. Okay, so we look at it, we can see, yeah, it is in fact true. Now you could say, that's all fine and dandy, but I can already tell by just looking at the numbers here what the maximum and the minimum numbers are. I don't need code for that. Well, the thing is, we know this because we created this array. However, sometimes we get an array from either a database or a file or a different class or based on a calculation or something like that. And suddenly we don't know that anymore. At least we cannot look at it and know it straight away. For example, if you noticed, we already do get a string array here. It's called args. So this args, we get it from the outside. So we can actually even modify it when we run our program, but I'm not going to go into that right now. And we could use args. However, we don't know anything about args. We don't know how many entries there are. We don't know the length about it and so forth. We could find that out, however, right? We could say args.length, and then we would know the length of the args. So however many arguments were given to our main method. And I believe it should be 0. So let me actually just see that in action. So let's say args length. And let's call this one args length is, so let's run it. And we see the args length is 0. That's because we are not sending any arguments when running our program. But however, we could do that. We could modify it. We saw it at the very start when we were using our console the first time, but I'm not going to go into that now. We can look at that later on. Okay, for now, we're really focusing on arrays. But that's it for this video. See you in the next one. Welcome back. So I hope you finished the exercise that was about rearranging an array. And it wasn't easy, but it's also something that you should be capable of doing. So if you haven't tried it yet, make sure that you give it at least, let's say 15-minute session or so to figure it out. All right. So now let's get started. So the first thing that we have is we have this array nums with 2, 5, 1, 3, 4, 7. And we want to rearrange it where at the end it's going to look like this: 2, 3, 5, 4, 1, 7. How does that work? Well, we're saying we have an array of 6 items and we want the first item to be followed by the half next item. So half of the amount of items is 3 plus 1. So we want this item to be next. Then after that, we want to have this item and we want to have the next position after the 3, so to speak. So this one. Okay, and then we want to have this and then we want to have that. So how do we get that? Well, first of all, let's get n, which is going to be the nums.length divided by 2. So we will just know, okay, we have a length of 6 items and we're going to divide this by 2. Now this obviously only works properly if you actually have an array that is, well, a even number, right, of items. So now that we have that, we have the length, we can create an array that will hold our rearranged list of our array of items. So let's just create a new int array, which will have nums.length as the amount of items, because it needs to be the same amount of items, right? So it also needs to have 6 item slots. Now let's use a for loop here where we say int I equals 0 and I less than n, and we go ahead and say I plus plus. Okay, so this is a for loop here that will now iterate 3 times because n is 3. As num's length is 6 divided by 2 is 3. So n is 3, so we're iterating through this 3 times. And what we want to do is we want to modify the items or set the items of rearranged. So at which position do we start? We start at 2 times I. We set the value of nums at value I. So the first item should be this one. So we can just think it through, right? So we start with I being 0. So 2 times 0 is 0. So we're saying whatever rearrange should have is going to be at the 0th position. So it will be 2. And that's correct with what we wanted to achieve, right? So then we do the same thing at the position I times 2 plus 1. So the next item in the list should be nums I plus n. So we're saying that it should be whatever item we had at I plus half of the array length, which is our n. And at this point, half of the array length is 3. And if it's 0, that is I, we know we want to have what is at nums 3 at the position nums at the position of rearranged 1. So we want to have this 3, which is this here at the first iteration, to be this here. Which would you get? It's because this here is going to be index 1 and this is index 3 because 0 plus 3 is 3. So that's the first iteration. And then in the second iteration, I is going to be 1. So we're going to say at index 2, because we already have index 0 and index 1, at index 2, we want to have the item at index 1 because I is 1. So we take 5 and we put that at index 2. And then we say at index 3, because 2 times 1 is 2 plus 1 is 3. So at index 3 for rearranged, we want to have the item of 1 plus 3. So what is 1 plus 3? That's 4. So what is at index 4? It is our 4 because this is index 0, index 1, index 2, index 3, index 4. And then in the last iteration, we have I being 2. So 2 times 2 is 4. So at index 4, which is this one, we want to have item at index 2. So this one. And then in the next one, we say 2 times 2 is 4 plus 1 is 5. So at index 5, which is the last position out of our 6th spot array, we want to have 2 plus 3. So index 2 plus 3 of nums, which is our last entry, which is 7. So with this, we are rearranging our entire array. So this is the logic that we wanted to design. And this was the difficult part of this challenge. So now let's go ahead and just print it out. So system out, print line, and we're going to say rearranged array. And then let's just use a enhanced for loop for int I in rearranged. Let's just go ahead and use system.out.println and print I. And maybe not print ln, but just print, because then it will just print it out in one row. With that, we can see our rearranged array is 235417. So it's what we designed here. So now let's extend this. Let's say we have another value here and another value there. Let's run it again. And we see we get 2, 4, 5, 7, 1, 3, 3, 8. So 2, 4. So 4 is after the middle point. So this here is the middle point, right? So what we want is we want this item, then we want this item, then we want this item, then we want that item. This, that, this, that. And what is it that we get? We get 2, then we get 4. We get 5, so here, then we get 7. So our logic works. And the good thing is that often enough, these theoretical challenges are made so much easier if you just take one example and you work it out with that one example, and you test it with that one example, and then you test it with general approaches. So with general numbers that are not the one example that you looked at, and you see if it works for other numbers as well, like I just tested here. Okay, so that's it for this video. See you in the next one. So in this video and the next few videos, we're going to look at the array class a little bit. And we have seen the string class just a tiny bit because it had a few methods that we could use, right? And we're going to see how we can do that with the array class. Before, in a few days, we're going to dive into methods in depth. We're going to really go deep into how to create our own methods, how do they work, which kind of types of methods are there, and so forth. But for now, let's look at the array class, which offers a really cool set of features that we can use in order to modify our arrays or do something with them. So let's get started. So the first thing is that the array class in Java is a utility class provided by the Java util package. It offers a range of static methods that make array manipulation easier and more efficient. And in this section, we're going to go through some of the most commonly used methods of the array class, providing detailed explanations and also some examples to enhance your understanding. So before you can utilize the array class, you need to import it into your program. This is done with the following line of code. So you need to import Java util arrays. This import statement allows you to access the various helpful methods provided by this class. And we're going to check the most commonly used methods out. The first one is arrays.toString. So this method is invaluable when you need to print the contents of an array. It converts the array into a readable string format, making it easier to display and debug your arrays. Then there is the sort method. Sorting an array can be a common task, and the sort method simplifies this process by arranging the elements of the array in ascending order. This method is efficient and saves you from writing your own sorting algorithms, as we have more or less done in the last video. It wasn't really sorting, but rearranging, yet you saw how much thought needed to go into it. So then there is binary search, and searching for a specific value within a sorted array is made easy with this binary search method. It returns the index of the specified value if found. So if the value is not present, it returns a negative number that indicates the point at which the value could be inserted to maintain sorted order. Then there is copy of. So you can create a copy of an array, and this is needed in various situations. So the copy of method allows you to do this very efficiently. It lets you specify the new length of the array, truncating or padding with default values as needed. So maybe your new array should copy an old array, but you need the new array to be even longer or shorter. Then you can do that with the copy of method very efficiently. So now you need to understand that truncating an array means trimming some elements from the and assigning back the new value of the truncated array to the actual array. So we're going to see this in action, so it makes a little more sense then. And then there is the fill method, which is particularly useful when you need to initialize or reset an array. It assigns the specified value to every element in the array, ensuring all elements have the same value. And finally, we have the equals method. And this one is very useful to compare two arrays to see if they are identical. So it checks whether both arrays contain the same elements in the same order, making it easier to verify data integrity. So it's not going to check if it's literally the same array, but it's going to check if they have the exact same values in the same order. So with that, let's actually see this in action because, well, this was a lot to manage, right? A lot of different methods, and we haven't even seen them live yet. So let's go into practice mode in the next video. All right, so let's get started using some really cool methods that the arrays class offers us. So therefore, let's go over and import java.util.arrays. Okay, this one right here. And then I have this array here that we used in the last video. It's just a bunch of numbers. And let's start with the toString method. So therefore, I'm going to use system.out.println, and I'm going to say nums.toString. So this nums.toString, you see, is using Java util arrays toString. So we can wrap it with the Java util arrays toString expression. So let's do that. And you see, it changes it to arrays.toString nums. So this is how you have to do it. But you saw it was just a lot easier to let the IDE do the magic. So you use the arrays keyword dot toString, and then inside of the brackets, that's where you put the array that you want to be converted into a string. And now, beautifully enough, println is great at displaying strings. So let's run this and see what's going to happen. And there you are. You see that it displays the array in this format, where it starts with a square bracket. It shows you all the values separated with a comma and an empty space, and then it ends with a squared bracket. So this is our array that we have up here. So there we are with this toString method. Now, if we were to use a string array, let's say we have Frank, then we have Tank, and we have Crank. Okay, a bunch of really cool guys. I don't know if that's names, but let's just run it. Frank, Ted, Tank. And now let's use the same technique and convert that names array also to strings. And you see that it will do the same thing. It will surround these items with squared brackets. So Frank, Tank, and Crank. Okay, so that's the toString method. Now let's look at the sort method. And the sort method allows us to sort an array accordingly. So let's test it with both. All right, and now let's sort our nums array. Okay, we can do that by using arrays.sort, and then we just pass in the array that we wanted sorted. So it will now modify our nums array and sort it. So it will basically change the order, and then it will store it inside of nums. And we can see that by displaying nums again. So this was pre-sorting, and here post-sorting. And let's add an empty space here. Pre-sorting. Now let's run this and see what the ordering did. So it sorted it to 1, 2, 3, 4, 5, 7, 8. Okay, so you see, that's how simple sorting works. Now let's see how sorting works for text, right? For string arrays. So arrays sort, but this time we're going to sort names. And let's display names post sorting. Let's run this. And you see, it sorted it alphabetically. So C, F, T. And before it was F, T, C. So there we are. You know how sorting works, and you know how displaying an array as a string, or making a string out of the array items and basically displaying it in a very nice format works. So that's it for this video. Let's look at a few more methods in the next one. In this video, we're going to look at the binary search method that the arrays class offers to us. So therefore, we need to make sure that we have import Java util arrays here. And then we need an array that needs to be sorted. So let's just see what the method declaration has to offer to us. So how can I get the method declaration? Well, let's use arrays and use binary search. That's the one that I want to have. Now, if you hover over binary search, it will give you a bunch of options as to how you can use this binary search. So what it wants is it wants the array, and then it wants the value that you're searching for. So if I'm saying I want to check nums and I want to know the position of, let's say, the value of 7, then I can do it like this. I can just say check through nums and give me the 7 if there is one. So now let's look at what binary search has to tell about how it works. So what it does is it searches the specified array of ints for the specified value using the binary search algorithm. The array must be sorted as by the sort int method prior to making this call. Okay, interesting. So we didn't sort yet, so we need to sort it. If it is not sorted, the results are undefined. If the array contains multiple elements with a specified value, there's no guarantee which one will be found. Interesting. So let's test it out. Let's go ahead and first of all sort nums, because otherwise it won't work, right? So we need to say arrays dot sort, and we pass nums. So this will now sort the array. So sorts nums array. And now we're going to search for a 7 inside of that sorted array. And then we can put that into an int. So int index, and let's get the binary search. So here what we're going to do is we're going to say system.out.println, and I just want to say index of 7 is at, and then plus index. Okay, so now it will not give us the result of the array that we looked at. It will need to be sorted first. So it will just give us a new sorted array. So let's actually also display this new array. So system.out.println, and let's say nums.toString. So I want it to be displayed. Well, actually it's arrays.toString nums. Okay, so the IDE is correcting me there. So this is the ordered array, and then it says 7 is at index 6. So index 0, 1, 2, 3, 4, 5, 6. Okay, so it did do that. Unfortunately, it doesn't really help if you want to know where it is in an unsorted array, because if you wanted to know where it is in this array, it's hit and miss. So it's undefined, which can sometimes work and sometimes won't work. But now we know that we have the 3 in there twice. So what is it going to do? Let's try 3 and let's run it again. And we will see that it says it's at index 3. Well, it also is at index 2. So interestingly enough, it didn't give us the first entry where it found it. It just gave us a random entry where it found it. So if there were 15 threes, it would just give us a random 3. Let's run this again and see if it stays consistent. So it always gives us the third 3. It never really thinks about giving us the second 3. So this one here, index 2. So you see it's a little hit and miss, and in some cases it is valuable. However, if you just want to know if this thing exists or doesn't exist. So if you wanted to know if, let's say, the 9 exists inside of this array, so let's test this as well, then you will see that it says index of 9 is -9. So this -9 is actually the index position at which the 9 could be positioned if you wanted to. However, let's try this with a different number. Let's try it with 6. Okay, so let's run it again. And it says the index of 6 is at -7. So that means that the 6 does not exist. This minus just means that the 6 is not inside of the array that is testing. But what does it mean then? Well, if you want to know more about what this -7 is, you can hover over the binary search method like so and hold the mouse over it, and it will display the information to you. So it says it returns the index of the search key if it is contained in the array. But if not, so otherwise, it says insertion point -1. So the insertion point is defined as the point at which the key would be inserted into the array. So let's say our 6 should fit at index 6, but we're getting -7 here because, well, that's the -1 that we have here. So -6 -1 is -7, which is the index of the first element greater than the key. All right. So with that, let's look at the next point, which is where we are going to make sure to make a copy of an item before we are sorting it. Okay. So see you in the next video. Okay, so in this video, I want to show you why copy off is such an important method. So let's look at the following. So we have an array, this int nums, and then let's say I create another array, which I'm gonna say backup of nums, and that will just be nums, okay? So in this case, I'm just saying, okay, you know what? I'm going to create this other variable and I'm going to store all the values that are in nums. I'm going to store them in backup of nums, because what I'm doing after that is I'm sorting nums, because I want to maintain the order of the nums somewhere, because maybe I just need this array order later on again. Well, doing what I just did here does not do the trick. How do I know that? Well, let's actually just try it out. So let's display nums. And let's display backup of nums. And also let's display nums before we sort it. So let's run this and we will see this is before we sorted it. This is the sorted version. And this here is backup of nums. Let's actually add that so that we know it, okay, here. So let's just say here it's going to be backup of nums plus the array. And here it's just going to be nums. And then at the start, it's just going to be nums as well. So nums, okay? So let's see what that's gonna be. We see nums, okay? This is the unordered or unsorted list. Then we have the sorted list of nums. And then we have the backup of nums, which also is sorted. So what is going on here? Well, the thing is, what we're doing here is we are not actually copying nums, but we are referring to the same array in memory. This is by reference, not by value. So there are two different ways how you can assign something further in coding. So one is by value and one is by reference. So either you're passing the value and then the other thing has the value. So if you modify nums and you pass the value to backup of nums, then the changes that you do to nums afterwards do not have an impact of backup of nums. But that's not what's happening here, right? Because it is by reference. So inside of the memory, there is this spot where the array information is stored. And now our nums variable is pointing at that memory slot, and backup of nums is also just pointing at that slot. So if something changes at that slot, then backup of nums still just refers to that changed version. So how can I now make sure that backup of nums is actually a backup of nums? Well, I can do that by using the copy of method. So this was by reference. Now let's call this one not really a backup of nums. And then let's create this new one, which is actually going to be backup of nums. Okay. And therefore, we're going to use arrays.copyof.nums. So this by itself is, however, not enough, because if you hover over a copy of, you will see that it says t-int. Well, t are generics. We're going to go into that later, a lot later. But it just says, okay, if you want to copy an int, you need to give me the amount of items you want to have. So the second one is the amount of items that you want to copy. And I want to copy all of them. How can I copy all items? Well, by using nums.length. So this will give me all items that are inside of nums. I could have also just said, I want to copy the first 4 or the first 7 or whatever, but this will copy all of them. Okay, so this will create a backup. So let's run this. And you see that our backup of nums, which is now the actual backup of nums, not really version, which we're never using. This is the one by reference, and this is the one by value. So now this one is actually still maintaining the initial order that we had with nums. And now whenever we're modifying nums, this backup of nums is not impacted because we copied it before it was sorted, before we changed the order. So that is quite something to wrap your head around. Don't worry about this by reference and by value too much. Just know it for this particular situation already. We're going to see other situations later on where this becomes a lot more important, and that will be with methods. But for now, just memorize. If you want to maintain the order of an array, and you still want to change that array, make a copy of it by using the copyof method. Now let's look at the copyof method in a different way. Let's create another array, and this one will just be small nums or less nums, okay? And we're going to still use the same method, still going to use the copyof method. However, we're not going to copy the entire array. I'm just going to copy 5. So we're creating a new length. You see, I get this information where it says new length. So less nums is going to be nums now, but only 5 entries. So only the first 5 entries. So let's actually print out the nums. That is this less nums. Okay, so less nums is going to be less nums. And let's see that in action. So we're displaying nums, and then we're displaying less nums. Okay, so less nums is, well, we're making the copy before we're sorting nums, right? So let me actually get rid of the sorting. It makes it a little more complicated. So let's run it again. So you see, this is the initial nums that we had, 2, 5, 1, 3, 4, and then we had 7, 3, 8. But this new copy just takes 5 entries. So it just takes the first 5 entries of our nums array. However, what happens if we, let's say, enter 15? So we know that our nums isn't as long. It doesn't have 15 entries. So let's run this, and you see it just fills it up with a bunch of zeros. So what we saw before was truncating. So it's truncated, so it cut off the rest, so to speak. And what we have now is it fills it up. So we can hover over this copyof method to see what it says. So it says copies the specified array, truncating or padding with zeros if necessary. So what it just did is it padded it with zeros. So the copy has the specified length. So now our copy has in fact 15 items. However, it only really copied the amount of items from nums that there were. So that nums had, which is, I think, 8 items, right? So that's a cool thing about our IDE. So you see, this IntelliJ has basically a whole documentation for us while we're coding, and we can learn more about every single thing that we're doing by hovering over it. And most of the times, it will give us some valuable information. Sometimes, not so much. But yeah, sometimes it's also overwhelming. So what is this @ not null, and what is this @ sign in general? What are these underscores? Like, it's a little more to it than I just said, but generally speaking, it can be very useful. If you are reading through it and it makes sense, then it's cool. Otherwise, it's maybe just too early for you to understand everything that's going on. But I think this one is a rather good explanation. Okay, good. That's it for copyof. So see you in the next video. In this video, we're going to look at 2 more methods that are very useful when it comes to arrays. Number 1 is the fill method, and the other one is going to be the equals method. So therefore, let's say I have this situation where I'm creating an array of ints, and I'm going to call this nums. And I'm just saying that it should be an array of 5 integers. However, I'm not specifying the values that I want to store inside of this array. However, I still would like it to have values. So I can either manually assign them, or I can use the fill method. So we can use arrays.fill, and then we can just use our nums array and say what kind of value we want to be in there. So let's say I want 10 to be in there. So let's now display this array by using arrays.toString and use our nums array. So at this point, we modified our nums array, and now we're displaying the nums array. Okay, so let's run this. And we see now the array is actually filled with values. Before it wasn't. So this fill method now filled the entire nums array with 10s. All right, so that's one way of using the fill method. Another one is by using multiple details that we pass to the fill method. So here we just said, okay, fill nums entirely with 10s. However, we could have said fill nums with 10s from 0 to 3. So by doing this, you can see it says from index to index val 10. So let's run this again, and we will see that it filled the first 3 entries with 10s, and afterwards it didn't. So it just says from the index 0 to the index 3 excluded, right? Because otherwise 4 values would have been filled with 10s, but 3 excluded, fill it with 10s. That's what happened, right? So if we display our nums before we did any modification, we will see it's full of zeros. Now that we did the filling, you see we have a bunch of tens and then we have zeros. Now with this, you could go ahead and fill the rest up with another number. So please go ahead and try that. Fill the rest of the array with other values. Okay, I hope you tried it. So I'm going to say fill from index 3 all the way to index 5 and fill it with 11s. So let's run it again. And we see we filled the first ones with 10s and then the second ones with 11. However, what if I try to access an index that doesn't exist? Then I'm getting an array index out of bounds exception. So here you have to be careful. So this to index is non-inclusive. So it means that the 5 that I use here is not going to be included in the modification anymore. So it modifies 3 and 4, but not 5, because I have 5 here. So sometimes it is like that, sometimes it's not. Well, sometimes it is included, sometimes it isn't. So you really need to memorize it by use case or test it by use case. Okay, so that's it for the fill method. Now let's look at the equals method. So let's say now we have this nums array, and we know that the nums array has 3 times 10 and twice 11 inside of it. So now let's create another array. Now this one I'm going to create manually. So my nums, and this one will be like so. I'm going to specify the values that I want to have in there. So 10, 10, and then 11, 11. So now I want to compare nums to my nums. So if I want to compare them, I can use this equals method. So I'm going to say system out print line. So just to see what's up. And then I'm going to use arrays equals, and then within the brackets, I need to enter the two arrays that I want to compare with each other. So I'm going to compare nums with my nums. So let's see what it's going to tell us. And it should tell us true, because both of them are the same, right? So we know that nums is 10, 10, 10, 11, 11, and our my nums is the same. So let's actually print it out to see the comparison better. So my nums, and now let's run it again. And we see they are in fact the same, right? So they're the same in terms of values. They're not pointing at the same location necessarily. So now let's modify this. Let's say this one now has 10, 10, 10, 11, 12. So let's run it again, and you see we get false because those two arrays don't have the same length and the same order as well as the same values. So even if they are the same values, but they don't have the same order, so let's say I have 3 10s and 2 11s, they would still not be considered the same. They're still false, so they're not equal. And that's really where the equals method is really powerful. So use cases would be, for example, you get an array from an external source and you want to compare it with your internal information that you have about that array. So maybe the array has been modified by that external source, and if that's the case, you might not accept it. So for example, you have it's all about security in your software, and you need to make sure that whoever sends you data hasn't modified the data in a way that is not acceptable and could break your code or could basically be a security threat. Then you can compare the array that was delivered to the array that you had as a security array or like as a backup array. And if they're not the same, then you know, hey, somebody was tinkering with your array or with your code. Okay, so this is just an example. There are obviously a bunch more, but this will give you a little bit of an idea as to why this is such a cool method. Okay, so that's it for this video. See you in the next one.
Great work. Today you learned how to declare and manipulate arrays. You used for loops to iterate through them and worked with methods from the array class. You also tackled the array shuffle challenge. Tomorrow we'll take it further by working with 2D arrays and learning how to manage multiple dimensional data. So see you there. Quick reminder, what you're watching here is just a small portion of our complete premium Java Masterclass. In the full course, you'll get deep into every aspect of Java, from beginner topics to advanced concepts, and have access to extra materials like cheat sheets and quizzes, and hands-on projects as well. You can find the link to enroll in the description below. So if you're serious about mastering Java, make sure to check it out. Welcome back. Today we'll be working with 2D arrays, which are arrays of arrays. Perfect for representing data in a grid or table format. We'll start by learning how to declare, initialize, and iterate through 2D arrays. We'll also cover operations like finding the largest number in a 2D array and calculating the sum of all elements. Next, we'll introduce array lists, a flexible data structure in Java, and learn how to work with their various methods. To wrap up, you'll complete a fun exercise, a space travel simulator, where you'll apply 2D arrays and array lists to make a fun little project. All right, so let's get started. Welcome back. So now that we know how arrays work, let's look at two-dimensional arrays. And they are sometimes used for interview questions, so you need to understand how they work. So today we're going to dive deeper into multi-dimensional arrays as well as look at array lists. So let's get started. So first of all, what is a two-dimensional array? Well, a two-dimensional array is essentially an array of arrays. It can be visualized as a table or grid with rows and columns. Each element in a 2D array is accessed using two indices, one for the row and one for the column. The structure is particularly useful for representing matrices, tables, and other grid-like data structures. In order to create a 2D array in Java, you specify the number of rows and columns it will have. This involves declaring the array type and using square brackets to denote the dimensions. Initialization involves allocating memory and possibly assigning initial values to each element, ensuring the array is ready for use. So if you want to iterate through a two-dimensional array, this involves using nested loops. The outer loop iterates over the rows, while the inner loop iterates over the columns. This nested structure allows for accessing or manipulating each element individually, making it possible to perform operations on all elements systematically. So in basic iterations, nested loops are used to traverse through all elements of the 2D array. The outer loop runs through each row and the inner loop processes each column within the current row. This method is effective for accessing or modifying array elements in a structured manner, as we will see in a practical example as well. So Java also has the enhanced for loop that we have seen. And it's also known as the for each loop. So it really simplifies array traversal. For 2D arrays, it really is super useful. So the outer enhanced loop iterates through each row, and the inner enhanced loop processes each element within the current row. This approach enhances readability and reduces the complexity of managing loop encounters. And if you want to initialize a 2D array directly, you can do so as well. So you can use array literals, which means you can specify the values at the time of declaration. This method simplifies the setup process and makes the code cleaner and more concise, especially when dealing with predefined values. Elements in a 2D array are accessed and modified using their row and column indices. This allows for precise control over each element. Accessing retrieves the value stored at the specific indices, while modifying allows you to update the value at those indices. And at this point, I would say, let's look at all of that in practice and also have a little exercise along the way. So see you in the next video. Welcome back. In this video, we're going to create a 2D array, we're going to initialize it, and then we're going to iterate through it. So in order to create a two-dimensional array, you just need an additional dimension as an array. So here you need just an additional squared brackets. So once you have that, you can give it a name. So you could call it my array, for example, or my 2D array if you wanted it to be two-dimensional. And then we need to assign some space for it in the memory. So we're going to say new int with double squared brackets. And we need to tell how many rows we want to use or have for this array, as well as how many columns. And then we can finish that with a semicolon. So this here now will give us the array. However, if we want to assign values or initialize it with values, there are different ways of doing it. So one would be to use my array and then say at which position I want to have which value. So for example, at the position 0, 0, I want to have the value 1. And now let's go through the other values as well. So this is row 0, column 0. So if we were to look at an array with values, right, we would have value 0, 0, 0, 1, 0, 2. Then we have 1, 0, 1, 1, 1, 2. And then we have 2, 0,
2, 1, 2, 2. Okay, so this is a two-dimensional array with 3 rows and 3 columns, right? So if we want to access the item at the top left, we need to use 0, 0. If we want to access the item in the center, it would be 1, 1. And now if we want to assign values to all of them, we need to make sure that we do it either step by step, where we add every single item, or we could use a loop that just assigns values, or we could also directly initialize values to the array. We're going to see how that works as well. I just wanted to show you this entirely, okay? So we start with, let's say, value 1, and then we go in the second spot, we have value 2, and so forth. So now let's just do that a few times, in total 9 times. So this one will be 3, then 1, 0 will be 4, 1, 1 will be 5, 1, 2 will be 6, and 2, 0, 7, and 2, 1, 8, and finally 2, 2 will be 9. Okay, so now at this point, I have added a value to each position inside of my array. So it will now look like this, right? It will be an array literal. It's going to be 1, 2, then 3, and it's going to go like this for the additional rows as well. So here, this one will be 4, 5, 6, 7, 8, 9. Okay, so if we compare that to what we had here, these are the indices, right? And these are now the values that I have inside of my array. Okay, now how can we iterate through the array? Well, we saw it in the presentation, right? We can use a for loop within a for loop. So we could use for I equals 0, where I is less than my 2D array dot length. And then we have another for loop, and this one uses j. And again, we're going to use my 2D array. And here it's interesting. We need to say I dot length. Okay, so this will give us the length of the columns, so how many columns we have, and this one will give us the amount of rows that we have. So we can check that out. So let's use system.out.println and check my 2D array.length. So we're gonna say my 2D array length plus my 2D array length. So let's run this, and it says my 2D array length is 3. Now at this point, we don't know whether that's the column or the row. So how would we know that? Well, we can just modify that to 4. So let's see if it now will be 4 or not. You see, now it's 4 because I defined that this will be 4 rows now. However, I go back to 3 because that's the only amount of items that I have created. Okay, so by using array name.length, you are getting the amount of rows. So if you want to get the columns, you can use, well, this approach here, for example, where we say, okay, well, now for the amount of I, so for any given row, give me the amount of columns that you have, because it's not necessarily required for it to be a quadratic array. So it doesn't have to be 3 times 3. It could also be 3 times 2, or some rows could have more information than others. So how about we just iterate through it and display it? So system out println, we just display our array at position I and position j. So add row I and column j. And then let's just add a little bit of space after each output. And let me just do it with print. Okay, so then we're going to say after each row, we're going to print the next line. So system out print line like that. This will just be an empty line break after we displayed the entire row. So let's run this, and we see we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So the array length is 3, and we have 3 columns. So this here is a column, and this here is a column, right? As well as this also is a column, or within the same column. So now you have seen how you can use two-dimensional arrays, how you can create them, assign values to them, and how you can iterate through them. All right, and that's it for this video. See you in the next one. So in the last video, we saw how we can initialize an array and add a bunch of values to the specific positions. And this is an awful lot of code, right? How can we initialize at the same time as we are declaring a variable? And well, we can do that by using a slightly different approach. So instead of using new int and defining how many rows and columns we want to have, we can also directly use this approach where we are opening with curly brackets and then we are using curly brackets again for each of the rows. So let me type it out and then it will make a lot more sense. So 1, 2, 3, and then we have 4, 5, 6, and then we have another separation here, 7, 8, 9. So now if we put it differently, it's going to be a lot easier to read. For example, like so. So at this point, we are creating this array, my2d array, and we're initializing it with the values 1, 2, 3 for the first row, and 4, 5, 6 in the second row, and then 7, 8, 9 for the third row. So each of those curly brackets is creating a new row, so to speak. And each item within the curly brackets is creating a separate row. So you see, it's a significantly easier way to do the work that we did earlier. So let's run it and see if we still get the right output or the same output, and we do. So it works the same. Now, what if we change one of the rows to have more columns? Now let's run it and see. And we see it works the same way. At this time, we basically defined a row to have a different amount of columns than other rows. So for example, in the first row, we have a column for the fourth entry. So this will be the column with the index 3. However, for the other items, we don't have that. So that's why it was so important to use my2d array I instead of just saying 3, for example, or in this case 4, because we know, well, we have 4 columns. But what if we have a row that doesn't have 4 columns? Well, then we would run into an index out of bounds exception again. So if we, instead of using my2d array I dot length, if we said, okay, all the way up to 4, so this will work for the first row, but then at this point, it will not work anymore. So at the second row, at the last entry, so to speak, at the fourth column, it will run into an array index out of bounds exception. Okay, so that's why it is so useful to use my2d array or the array name and say, however many columns you have, give me the length of that for this particular row. And you know, this outer for loop is for rows. So this one iterates through rows, and this one iterates through columns. So that's it for this video. See you in the next one. Okay, so in this video, I want to show you how we can iterate through it using an enhanced for loop. So the cool thing is the IDE is already helping us with that. So we can just hover over this for loop and you see it changes this for loop into a enhanced for loop. So it just says ints inside of my2d array. And then we can do the same thing for our for loop that we had for the columns. So now it says nint in ints system out print line. So let's try to understand what it does here. So it says, okay, I understand that my2d array is a 2-dimensional array, and I'm going to go through every single row. So what is a single row? It is still an array of ints. So it's just going to call it ints. Now you could call it, for example, rows. That would make sense as well. So let's call it rows. And then the inner enhanced for loop just says, okay, so I'm going to iterate through rows, which is an array of ints. So every single item inside of it is going to be an int, which is why it just calls it an int. We could have called it num, for example, because we know it's a number. So we could just rename it with num and make it a little easier to understand what's up. So this is just how the enhanced for loop really helps us out here. It's just an easier way to type it out and also read it. It's just something that we need to understand how it works, and then it's really saving us some time. But each time that we make a change, let's also test if the change didn't break our code and if it still works. And we see it does in fact still work. So our 2 enhanced for loops still do the job as they were intended. So that's it for this video. See you in the next one. All right, so in this video, we're going to see how we can get the highest number inside of a two-dimensional array. We have seen how it works with a one-dimensional array, and it's pretty much the same principle, right? So we just go ahead and we just create a variable which is going to hold the largest value. And we're just assuming that it's going to be the first entry of the entire array, of the two-dimensional array. And then inside of our enhanced for loop in the inner one, we're just checking if num is greater than largest. Because if that's the case, then we know that largest should now be num. So now largest needs to be overwritten with whatever the number is. Because num is the individual number inside of our two-dimensional array. First it's 1, then it's 2, then it's 3, then it's 4, and so forth. So it goes through all the items inside of our array. And then we can just display the largest number. So largest num is largest. So let's run this. And we will see that the largest number is 13. Now let's look at our array and we can see that it is in fact 13. And if we were to do it the other way around, let's say we also add a 0 here and let's find the lowest int lowest. And we're gonna also assume that it's the first entry. However, it's not going to be the first entry as it is the last one. So we're going to do the same check here, but the other way around. So if num is less than lowest, then we know lowest is going to be num. And then we can do the displaying of the lowest number as well. So lowest num is lowest. Now let's run this and we see lowest number 0. So it went through the entire array and then it found, oh yeah, at the end, actually there is something that is lower than the 1 because every other number was higher, right? That's why I added the 0 here at the end. So you can see, obviously the 2D array doesn't always have to just have numbers that are an increment of the number before. So that's it for this video. See you in the next one. Welcome back. In this video, we're going to look at how we can get the sum of all the items inside of our two-dimensional array. So let's get started. Therefore, I'm going to clean up the code a little bit. I'm going to get rid of the system out statement and in general. And then we just need to think about what do we want to achieve even? Well, we want to get the sum of all of these numbers that are inside of this two-dimensional array. How do we get every single number? Well, we get it here. So inside of this enhanced for loop, the inner one, the inner enhanced for loop, we get the number of every single row, and we also get every single row out of the two-dimensional array for the outer for loop. So after these two for loops have run, we have iterated through every single one of those numbers. So we have gotten the number as num. So now we just need to use this num in order to work with it. And how can we efficiently work with it to get the sum? Well, let's create a sum variable, which we're going to set to 0. And then we're just going to say sum plus equal num. And then we can just display sum. So system out print line sum is, and then plus sum. And now let's run this and see what the sum is. And we see the sum is 49. So let's make it easier to double check if that worked flawlessly. So now it says the sum is 45. And we can just do the formula here, which is as follows to find out what the sum is. So it says first number plus last number, so that's 10. And then we take the amount of numbers divided by 2. So the amount of numbers is 9. 9 divided by 2 is 4.5 multiplied with 1, which is the first number, plus 9 is 45. So that seems to work. So let's test it again. We say n, which is the amount of numbers, 9 divided by 2, which is 4.5, right? Multiplied with 1 plus 9. And that results to 4.5 times 10, which is 45, okay? So if we run our software, we will see that that's exactly what happened, right? We got the result of 45. Cool. So that worked. Now, if we obviously had longer numbers, so let's say we go up to 10, 11, 12, 13. So if we apply the same principle as we have had here, so now we have 4 more numbers. So it's not 9, but it's 13 divided by 2 is 6.5 times 14. So 6.5 times 14, and how much is that? So it's 65 plus 26, which should be 91, I think. So let's run this and see if we get 91, and we do. All right, so the formula works, and now you also have a little bit of additional math under your belt if you didn't know that already. Probably you did, and in that case, good for you. And I'd say that's it for this video. See you in the next one. All right, so I hope you were successful with the exercise. So this video will just be the result, at least one of the possible results for the exercise. And what we needed to do is, first of all, say how many rows and columns we want to have. So enter that. Then we needed to enter every single value. And then we wanted to have the diagonal, so the primary diagonal and the secondary diagonal. So let's get started. So the first thing that I'm going to do is I'm going to set a scanner up that I'm going to need. So new scanner system in, and then I'm going to close the scanner at the end. So let's do that straight away. And then I'm going to tell the user what I want from him. So system.out.println, please enter the amount of rows and columns you want to have. Okay, and then we ask the user for the next int, and we're going to store that inside of a variable. So int n is going to be scanner next in. So now we know that we can go ahead and create a two-dimensional array with n amount of rows and columns. So new int, and by the way, let's give it a name, and I'm just going to call it matrix. So I'm going to say new int with n rows and n columns. So now at this point, let's go ahead and enter values for every single one of those. So we're going to use a for loop here. So for int I, int going all the way to n, another for loop where j is going to n. And now let's set up every single item for that matrix. So we're going to say matrix at I, j should be whatever the user has entered. So scanner dot next int. So now at this point, let's just test it. So please enter the amount of rows and columns you want to have. I want to have 3. And actually, we didn't tell the user what the user is supposed to do. So here I'm going to say system out. I'll copy it from here. Please enter the value for I, empty space, j, like so. Okay. And let's run it again. So we say we want to have 3 columns. For 0, 0, I'm going to say 1, 2, 3, and so forth. So I'm basically creating a matrix that is going to look something like this. So like this one. Okay. So 1, 2, 3, 4, 5, and so forth. So what I want now is I want to know the sum of 1, 5, and 9. Okay. So I want a diagonal sum. How can I get that now? Well, I need to use for loops again. So let's go ahead and do that. So therefore, let's create a sum variable and then get the sum of those values. So for int, well, it's actually for I, let's do the work for us here. For I less than n, let's go ahead and say sum is plus equal our matrix at I. Why is it I? Well, because if we look at it, this is 0, 0, right? So the for loop starts at 0 for I. So it's going to be matrix at 0, 0. Then it's going to be matrix at 1, 1. Then it's going to be matrix at 2, 2. So that's why I'm going to get the diagonal. So this will now give us the sum of the diagonal. So let's test it. System out, println. The sum of the primary diagonal is, and then plus sum. Okay. Let's test it, but this time with a 2 times 2 matrix, very small matrix. So how many columns do I want to have? Just 2. So I'm going to say 1, 2, 3, 4. Okay, so the sum of the primary diagonal is 5. How's that? Well, if we look at what I just entered in terms of what the matrix should look like, I have 1, 2, and then I have 3, 4. So the primary diagonal is 1 and 4. So the sum of the primary diagonal is 5. Now, how do I get 2 plus 3? Well, therefore, I need to create another for loop. So this other for loop will have a very similar calculation. However, we're saying we want to have it at row I and then the last row, so to speak. However, we go down. So how do we go down? So if we take this example again, how do we get this 3? Well, we get it by knowing n is 3, for example, right? Because we have 3 rows and 3 columns. So we know n is 3. So we get the index of this by getting the second indice to be n minus 1. So if we get n minus 1 for this, how do we get this one? Well, it's n minus 1 minus 1. And what is this? It's n minus 1 minus 2. And how do I get this then? How do I get these values if I want to go from n minus 1 minus 0 to n minus 1 minus 1 to n minus 1 minus 2? Well, with a for loop, right? So that's what we are doing here. We're basically saying, I want to go through this n minus 1 minus I. I want this to be the secondary diagonal. Okay, so now that we have the sum of both diagonals, we still have one little problem. And that is that we have an odd sized matrix that the middle point, the center point, will be counted twice. What do I mean with this? Well, if we want to have the sum of the primary diagonal and the secondary diagonal, we would count 1 plus 5 plus 9. Then we would count 3 plus 5 plus 7. But this 5 has been already included. So we don't want to include it twice, right? So if we don't want to include it twice, then we need to add an if statement. So we're just going to add an if statement here, where we're going to say we only want to do this if I isn't equal to n minus 1 minus I. Okay, and with that, let me put that inside of this if statement. So now let's just add a final system out statement where we're going to say the sum of both diagonals is, and now let's run it. So three rows and 3 columns. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, just for simplicity. And we can see the sum of the primary diagonal is 15 and the sum of both diagonals is 25. And if we look at this here, so we see 1 plus 5 plus 9 is 15 and 3 plus 7 is 10. So 10 plus 15 is 25. So our tool seems to work. Perfect. So I hope you enjoyed this challenge. It was a little more complicated, I would say, especially the part with this if statement here, but it really depends on what you wanted to achieve, if you wanted to include it or exclude it. So that's it for this video. See you in the next one. Welcome back. So now that we have a good idea of arrays and 2D arrays, let's look at array list, which is just a different way to store multiple pieces of information or multiple values or variables at once inside of one variable, so to speak. Okay, so it's just a list, but it's called array list because it's very closely linked to an array. So let's look at what that means and how it works and how they differ. So let's get started. So an array list in Java is a resizable array, which is part of the Java util package. Unlike arrays in Java, however, that have a fixed size, an array list can grow and shrink dynamically as elements are added or removed. This makes array lists more dynamic and provides better memory utilization than normal arrays, making it ideal for situations where the size of the array is not determined. So if we look at the syntax, we can see we're using the array list keyword, then the angle brackets, type, then we give it a name, equal sign, new, again the array list keyword, angle brackets, and then the type, the same type that we used here, and then parentheses, and obviously closing it with a semicolon. So to use array lists, you need to import the Java util array list package, and our IDE is usually going to take care of that automatically whenever we use the array list keyword, however. So you can create an array list by declaring and initializing it with a specific data type. So here's an example where we're creating an array list called fruits, which is of type string. So this array list will now hold a bunch of strings, which will probably be fruits, right? And then if you want to add an element, you can use the add method to insert elements into the array list. For example, fruits.add apple will add a fruit, or fruits.add banana will add a banana, or will basically add the banana string keyword to our fruits array list. So if you want to access an element, you can access it using the get method with the index of the element, for example. So fruits.get and then 0 will give you a specific fruit, which is going to be a string because fruits are strings, right, in our case. And this will access the first element as we have seen with arrays as well. So if you want to modify an element, you can use the set method to modify an element at a specific index. So for example, I can say fruits set, and then at position 1, I want to set that to orange. So this will replace banana with orange. So here we're saying the index at which we want to change something, and then we're saying what we want to be there in place of it. Now, if you want to remove an element, you can use the remove method to remove the item at a specific index or specifically the object. So you can either say fruits.remove 0, which will remove the first element, or you can say fruits.remove orange, which will then remove the element that was called orange. So if you want to know the size of an array list, you can just use the size method, which will return an int and will give you the size of the array list. Now, if you want to iterate through an array list, you can use loops to iterate through the elements of an array list using an enhanced for loop, for example. So for string fruit in fruits, we can say system out println fruit, and this will now display all of the fruits that are inside of this fruits array list. And if you want to check if an element exists, you can just use the contains method, which checks if a specific element is present in the array list. So this will return a boolean, so you can store that inside of a boolean variable, saying boolean has apple, for example, and fruits.contains, and then whatever element you want to check if it is inside of fruits. So let's see if we have fruits available. If there is an apple, for example, we can just say fruits.contains apple. And if you want to remove all elements from the array list, you can just use the clear method. So fruits.clear will make it empty, so to speak. So what's the difference between the array list and arrays in Java? Well, first of all, an array is a fixed size data structure that holds elements of the same type. Once created, its size cannot change, making it static in nature. And arrays provide a simple way to store a collection of elements in contiguous memory locations. An array list, however, is part of the Java util package and implements the list interface. We're going to see what an interface is and what the list interface is specifically in the future. For now, just think of it that there are different types of lists that we can have, and array list is just one of those lists. And it is a resizable array, which means it can grow or shrink dynamically as elements are added or removed. This dynamic nature makes array list flexible and easy to use when the number of elements can vary. Now let's look at flexibility. Well, an array is basically fixed. So once you created it, you defined how many items it can hold. An array list, on the other hand, does not require an initial size. It can start empty or with an initial capacity and grow as elements are added. This flexibility makes array lists ideal for scenarios where the number of elements is unknown beforehand. Now, when it comes to performance, you have to consider that arrays are just more performant. So due to their fixed size and contiguous memory allocation, arrays generally offer faster access and modification times. The index-based access allows for very efficient retrieval or updating of elements. Array lists, on the other hand, while they provide dynamic resizing, this can introduce some overhead. Access and modification times are still efficient, but operations that change the size, like adding or removing elements, can be slower because they might involve resizing the internal array and copying elements, which just happens under the hood and we don't even see that, right? So then when it comes to memory efficiency, arrays are more memory efficient because they allocate exactly the amount of memory needed for the specified number of elements. There's no additional overhead for resizing. And for array lists, when it comes to memory efficiency, they may use more memory because it allocates extra space to allow for growth. And this extra space helps to minimize the number of resizing operations, but can lead to some wasted memory if the array list does not use all the allocated space. When it comes to the methods that both of those types of lists allow us to use, arrays offer just a limited set of methods. So they have basic operations such as accessing elements by index, setting values, and getting the length of the array. Arrays do not provide built-in methods for adding, removing, or searching elements. Array lists, on the other hand, have that. The ArrayList class provides a rich set of methods inherited from the list interface. These include add, remove, get, set, size, and many more. These methods make it easier to manipulate the list of elements without having to write additional code for common operations. And then when it comes to multi-dimensional support, well, arrays have direct support for multi-dimensional structures such as 2D or 3D arrays. This makes them suitable for representing matrices, grids, and other complex data structures with multiple dimensions. So to create a multi-dimensional array list, however, you need to use nested array list objects. For example, a 2D array list would be an array list of array lists. While this offers flexibility, it can be more complex to manage and work with compared to multi-dimensional arrays. So when it comes to usage, arrays are preferred for scenarios where the number of elements is fixed and performance is critical. They are ideal for simple data structures such as storing a fixed number of elements where fast access and minimal memory usage are important. Array list is preferred for situations where the collection size may change over time. It is suitable for use cases where you need to frequently add or remove elements and benefit from the built-in methods provided by the list interface. Array lists offer great flexibility at the cost of some performance and memory overhead. And with that, let's jump into looking at how array lists work. So, see you in the next video.
Welcome back. So now let's have a look at array lists and let's see how they work. And in order to use array lists, we can use the array list keyword here. And you will notice that the import automatically is added by our IDE. Otherwise, we would have to manually add that. So import java.util.arraylist, semicolon. So ArrayList is a class inside of this util package inside of Java. And there we can now go ahead and define which type we want this array list to be of. For example, we want it to be a list of strings, an array list of strings. So let's take the example that we had in the presentation, and that's the fruits array list. In order to now initialize this array list, we need to use the new keyword and then use array list again. And here we need to define that this is going to be of type string once again. So this is how we can declare and initialize an array list. So now in order to add items to this fruits array list, we can just use fruits.add. And here we can add strings because we said that this array list will hold a bunch of strings. So let's add one string to it, for example, an apple. And then let's add another fruit here, add, and then banana, for example, and banana, like so. And then let's add another fruit, and this one will be a cherry. Okay, and fruits.add dates, I think that's how they are written. So we see A, B, C, and D. Beautiful fruits. So now that we have added a bunch of items to this list, let's display those items. So in order to iterate through this list, we're going to say for string through fruit in fruits, give me every single fruit. So display every single fruit, system out, print line, and we're going to say fruit. So this will now display each fruit in a new line. Let's try it out. And we will see it says apple, banana, cherry, dates. Very well. How can we now access individual items here? Well, basically we just use fruits dot, and here we can get an item. You see, get index. We can get an item at a given index. So let's say the first item. Now, when you hover over it, now when you get the first item or index 0, it says that there is an alternative method available for it, and that's called get first. So if you always just want to get the first item, you could use this get first method. Otherwise, using the get method is totally fine. So if you want to get the item at index 1, which should be banana, or 2, which would be cherry. So let's just try it with cherry. And we see that it says cherry, and then it shows us the list of the other items, right? Like the ones from fruits here. Good. So now you know how to get items, and let's see how we can find out if there is an item inside of the list or not. Well, we can do that using the contains method. So fruits dot contains, and then we need to say which object we want to check if it contains it. So let's say banana, for example. Now I'm not writing banana with a capital B this time, but with a lower b, and this will return true or false. So true if the list contains the specified element, and otherwise it will return false. So let's store this inside of a boolean, and I'm gonna say has banana here,
And let's check if it has a banana. And we're going to display this as well. System out, print line, and we're going to say has banana. So let's run this, and it will say cherry false. So it is case sensitive, as you can see here. So I wrote banana with a lower b. If I do it with a capital B, I will get true because it says banana is inside of fruits. Okay, good. So this is the contains method. And then another one that is quite relevant, and that is the size of the array list. So we can get the size of an array list by using the array list name dot size. And this will give us the amount of items as an integer. So public int size. So we are going to get a int out of it. So we can see here it says 4. So there are 4 items inside of our fruits array list. So now if we want to remove an item, we can just use the remove method. So fruits.remove, and here we can either say it which index or which object. So here you see int index or object. So we could say delete banana, or we could say fruits.remove at an index. So let's say at index 0. However, there is also the remove first method. If you wanted to remove the first item specifically, you can use that. So let's just keep it at what I just said with the remove method. So then let's run this and we will see that only cherry and dates are left after we removed banana and we removed the first item. And the first item was apple. Okay. So you see that there are a bunch of other methods as well. So you could really just go ahead and use fruits and see which methods there are. There's the add, the remove, the add, contains, get, remove, add all, add first, and so forth. So if you want to add an item at first, this one would be a good idea, right? So let's add an item at first. So add first, and let's add pair at this spot. Okay, and now apple should still be there after we remove the pair, because the pair now is at index 0 and we are deleting index 0, which was in fact pair. So let's not remove index 0 just to see the comparison. Now we should see pair apple. You see, pair apple cherry dates. Now you have seen how to add an item at the beginning, at the very first entry of the array. And there is also this add method where you add an element at an index. So here, this is test one. So I could say add at index 2 the item called plum. Okay, so now let's display it again. And we see we have pear, apple, plum. So plum is at index 2. Index 0 was pear at this point that we added it. Index 1 was apple, and index 2 is then plum. So it positions an item at index 2 and pushes the other item back. So it pushed banana into the third index. So let's get rid of this just to see that. Let's get rid of this remove statement. And we're going to see that it says pear, apple, plum, banana. So now banana, which used to be at index 1, was pushed to index 2 because we added an item at the start, and was pushed to index 3 after we added an item at index 2, which is the plum. All right, so this was a overall overview of what the array list is useful for. And in the next video, we're going to look at an exercise. So see you there. Great job today. We have worked with 2D arrays, explored array lists, and completed the space travel simulator exercise. Tomorrow, we'll shift focus to methods, the core building blocks of organized code. You will learn how to create, call, and use methods, and we'll even get into a fun project to build a word scramble game. So, see you tomorrow. Welcome back. Today, we're getting into methods in Java. A crucial concept that allows us to break our programs into smaller reusable sections of code. We'll start by learning what methods are, how to create and call them,
and the different types of methods like void methods and methods that return values. We'll also explore the difference between passing values by reference versus by value, which is important for tracking changes in variables. And finally, we'll wrap up the day with a word scramble game project to apply what we've learned. So let's get started.
Welcome back. Today we're going to look at one of my favorite parts about programming, and that is methods. So methods are such a cool feature. They allow you to save a lot of time when you are building your code or writing your code, and you just reuse code that you wrote once, and you don't have to write it all again, but you can just call the method as it's called. So let's have a look at how this works, and let's become a pro at creating our own methods. So first of all, we will explore what a method is, and we're going to see how we can create a method and call a method with some simple examples. And generally, methods are fundamental building blocks in Java programming and also in other programming languages. And understanding them is crucial for writing efficient and organized code. So what is a method? Well, think of a method as a recipe in a cookbook. Just like a recipe provides step-by-step instructions on how to prepare a dish, a method provides step-by-step instructions on how to perform a specific task in your program. Methods can help you organize your code into manageable, reusable blocks, making your programs easier to read and maintain. The purpose of methods is code reusability. So imagine you have a piece of code that you need to use multiple times in different parts of your program. Instead of writing the same code over and over, you can write it once in a method and call the method whenever needed. This saves time and reduces errors. And then there's readability. So breaking your code into smaller, well-named methods makes it easier to understand. When you look at a method, you can quickly grasp what it does without getting bogged down by the details of the code inside. And then there's maintainability. When your code is organized into methods, finding and fixing bugs becomes easier. If you need to update the logic, you can do so in one place rather than hunting down multiple copies of the same code scattered through your program. So let's look at the advantages in a quick summary. Methods help you avoid duplication by allowing you to reuse the same block of code. This not only makes your code cleaner, but also reduces the risk of errors. It is easier to debug and modify. So if there is a bug or a need to update the logic, you only need to change it in one place. This makes your code more robust and easier to maintain. And then we have the improved code structure. So organizing your code into methods helps structure it logically. This makes it easier to follow the program flow and understand how different parts of your code interact. So what is the basic syntax of such a method? Well, it is as follows. So you have the access modifier, and we're going to dive deeper into what those are later. Then we have the return type, and we've seen that when we were using a bunch of methods. For example, the equals method, where we saw that we would get the return type Boolean. So if one array was equal to another array, we have received the return type true, and if they weren't, then we received the return value true, and if not, then false. So this return type could be a Boolean, it could be an int, it could be a string, or it could be a more complex data type altogether. Then there is the method name, and within parentheses, you can put your parameters, and you don't have to. So some methods don't need parameters, and also some methods don't need a return type either. We're going to see what that means and how this works in general. And then within the curly brackets, that's where you have your method body. So that's where you have your code that should be executed each time that this method is called. Now, on a very high level, what is an access modifier? Well, this defines the visibility of the method. And we've seen public before, but there are other keywords such as private or protected. And then the return type, this really just specifies the type of value the method returns. If the method does not return any value, we can use the keyword void. And void just means empty or nothing. And then the method name, well, this is just a descriptive name for the method following the camel case naming convention. And it's really important that you give it a name that makes clear what the method's purpose is. And then parameters are really just optional inputs the method can take and define within parentheses. If no parameters are needed, we can leave the parentheses empty. And you could think of it as parameters being the input into your method and the return type or the return value being the output that you get. So we're going to see how that works in detail. And then we have the method body. So generally just all the instructions that the method executes are placed within those curly brackets. So we're going to start with void methods. And void methods are very easy to manage. A void method is a method that does not return any value. Let's see how to create and call a void method with an example. So here we have this say hello method, and this method doesn't take any parameters and simply prints hello world to the console. In the main method, we call the say hello method to execute its code. And I'd say with that, let's jump into demo mode and see how that works and write our first void methods. So see you in the next video. All right, so let's go ahead and create our first own method. And we see that we already have a method here inside of our class main, and that's the main method, right? And we have a bunch of keywords here as well. So we have this public keyword, that's the access modifier. We have this static keyword, which is a very special keyword that for now we need to ignore in the sense of what it means, because it only really makes sense once we know what object-oriented programming is and how it works. But generally, if you really want to know, you can check it out. But generally speaking, it just means that this method can be used or called without having to use it on an object. Okay, so take that for what it's worth. We don't know what objects are yet. We will get into those very soon in a few days, and then we will also understand what the static keyword means. But for now, just accept that you have to use it inside of the main class, and if you want to call something from a static method. So how does that work now? Well, let's go ahead and just create a method and try to run it inside of the main method. Try to call it from there. Okay, so the method that I'm going to create is also going to be a public method, and it will return a nothing. And I will give it the name say hello. So what this should do is it should just say hello on the console. So really nothing too fancy. But this already shows us the general structure of a method, right? The access modifier, the return type, the name, the parameters, which we don't have any, and then the method body. So the code that will be executed if we call the method. So what does calling a method mean? Well, it means that you use the method name at another point of your code in order to execute whatever is inside of say hello. So let's try it out. Let's just use system out println and say hello world from the method say hello. Okay, so that's what this say hello method should do. So now how do we call it? Well, we call it inside of the main method. So let's use say hello from here. Now, for some reason, we get an error. Why do we get an error? Well, this has to do with the static keyword that I was talking about earlier. Because as I said, we can only call static methods from static methods. And as the main method is a static method, so a method that can be called without it being called on an object, we have to make the method say hello also static. Okay, and then suddenly it works to use the say hello method. So just for now, accept that whenever you use a method inside of our main class, add the static keyword just after the access modifier or just before the return data type. So in this case, just before void. And return data type will make a lot more sense once we're using something that is not void, because what is void? Void is empty, right? So it doesn't return anything. So this just means that it will just execute the code and it will not give us anything back. And this will only make sense once we create a method that gives us something back. So let's now run the say hello method. So if I run it, we will see that our code executes hello world from the method say hello. So now we could just go ahead and use this code say hello a bunch of times. And what that will do is it will call this method say hello a bunch of times. So in this case, 5 times, just because I pasted the code in there 5 times. So let's run this and we will see it says hello world from the method say hello 5 times. And that is really the cool part about creating methods. Now, obviously, this method is super simple. It just has one print out statement. But imagine there were 50 lines of code, which is possible. There are methods that are very long. They have a lot of code. So if there were 50 lines of code, then I would have to copy and paste those 50 lines of code every single time and paste them in here to run them each time that I need them. That would make it so bad. So let's say I have this other code, and let's get rid of these hello methods. Let's say I have this other code, and this code that I have is going to be also system out print line, and I'm gonna say hi Frank, for example, right? And for some reason I want to say hi Frank 10 times. Okay, so obviously I could use a loop here, but let's just say, okay, maybe not 10 times, but 6 times. So now I decide, oh damn, I didn't want to say hi Frank, I wanted to say hi Frankie. So now I need to go and modify this code and add Frankie in here and like this Y all the time. Okay, but what if I again need to change it? Well, okay, well, you know what? I'm gonna say hi Missy. Okay, so now I need to use Missy and I need to paste that in here all the time. But imagine I just had this hi Missy code directly in a method. So let's say public static void say hi friend. Okay, so let's just call it hi friend, and I'm just going to print this out, say something like system out print ln hi Missy, and instead of using hi Missy a bunch of times with print ln, I'm just going to say hi friend and call this method like so, and I'm gonna run this a few times. So this will now be a lot more flexible, because if I want to change something about what should happen when I say hi friend, I just do it once. I just change it here. I just say hi Frank again. Okay, so now I can say hi to Frank a bunch of times. Okay, so this is really just to bring home the point that you are saving a lot of time when you're working with methods if you design them properly, and you can just call them wherever you want. So this is just an example as to how I can call a method, but I could, for example, also call the say hello method inside of the say hi friend method. So now at this point, let me get rid of the unnecessary calls. I'm just gonna have one call where I say hi friend, and I'm going to run this, and the main method will now call the say hi friend method, which then says hi Frank and internally then calls the say hello method. Okay, so then it also executes the code of this say hello method. And the say hello method also just has a print out statement, but it could be more complex. Okay, so you can call methods from within methods, and that is not something uncommon. However, you need to always be cautious about what exactly you're trying to achieve with your method, and that is something you will get experience with over time. So don't worry about that for now. All right, so I'd say now we know how to use void methods. Now it's time to look at methods that have parameters, which are still void methods, but at least they have parameters inside of those parentheses. So see you in the next video. Welcome back. So in this video, we're going to look at void methods with parameters. Okay, so let's get rid of a few of the lines of code that we have. And instead of just saying hello, I want to say hello to the person, but I want to be able to modify who I say hello to and what age I believe they are. Okay, so we just have this little guessing game. So we are at a party and everybody has this tendency of saying hello to someone that they think the name of, and then they think their age of. So you just look at somebody and they just look like a Frank, and then just say, Frank, you are 35 years old, or something like that. Okay, so we're going to create this method. So how does that work? How can we use parameters? What are parameters? Well, the thing is, we can use parameters inside of the definition of the method. Okay, so here we need to add that within the parentheses. So how does that work? Well, we say the data type that we want to use. So for example, I can use string as the data type, and then the name that I want to use for that parameter. So I'm going to say this is going to be the name of the person in this case, right? And then I'm going to have another data type, and that will be the age. Now you see that you separate the parameters with a comma. And you can see that you can use all kinds of data types to be used as parameters. So how can we now use name and age? And what's the idea behind those? Well, the idea is that we use them inside of the method body, because those parameters are like variables, but those variables only exist within the method body. They can only be used within the method body. So this name variable that I'm creating here, so this parameter, so to speak, I cannot use here. Name does not exist at this point, okay? But it does exist here. So I can say name is equal Frank, for example, right? So I can do that because this name variable does exist inside of the scope. That's the official name. So inside of the scope of this method, say hello. So inside of the curly brackets of that method. So I could set the name of the variable here, of this parameter, inside of the curly brackets. But that's not the idea behind parameters. The idea behind parameters is that they are input from the outside. So whoever calls the say hello method should now give me the name, okay? But how can I use the name inside of my system out println statement? I can just use it like a normal variable. So I can just say hello, and here instead of saying hello world and all of that stuff, I'm gonna say hello name, you are, and then age, years old, I guess. Okay, so this was this guessing game that I was talking about, right? So now you see, and let me put that into 2 lines. Now you see how to use those parameters. But how can we now use them when we call the method? Because things have changed now, right? So let's say hello, and you see now we get an error because we cannot just use the say hello method as we used to. Now we need to pass a name and an age. So we need to pass a string data type and an int data type. So let me hover over it, and it says expected 2 arguments but found 0. So what are arguments now? Well, the thing is, in the definition of your method, these things are called parameters. But when you are passing them to a method, so when you are handing over the input values, so to speak, then they're called arguments. Okay, it's just programmer speak. The thing is, I will often enough refer to arguments as parameters and to parameters as arguments, because while they are different in a sense, they are not too, it's not that big of a difference in a sense, you know, because it's just the state at which they are that makes them different. So now let's just use the name Frank here and the age for, let's say, 35, as I guessed earlier. So now the say hello method will say hello to Frank and will say that he's 35 years old. So let's try this and run it. And we will see it says, hello Frank, you are 35 years old, I guess. So now let's call this method again, but this time with other names and, well, with another name and another age. So let's say Missy is also on the party or at the party and she's 30 years old. So it's going to say, hello Missy, you are 30 years old, I guess. Well, years old, I guess. So that's also something. I noticed I made a mistake and I only need to fix it once because I use a method, right? So now we know how we can create a method with parameters, and we know how to use arguments when calling the method. So you see, you need these parentheses regardless. If you want to call a method, you need them regardless if you have a method that requires arguments or not. And if you have a method that requires arguments, you need to pass those directly inside of the parentheses. So here we see also that the IDE even tells us what we need to pass here. So we need to pass the name and we need to pass the age. And the cool thing now is that the method has just a general form and it accepts inputs, and based on those inputs, it modifies how the code will behave. So in this case, it one time says Frank and he's 35, and one time it says Missy and she's 30. So we could do that as often as we wanted and each time modify the name, and this one would be Dennis and I'm 36 years old right now, and it's going to work the same way. However, it's going to be slightly different in the sense of how it behaves. Okay, and now you could obviously also have if statements and loops and all of that in here, which could modify how the method behaves drastically based on conditions. So you could say, if it's Frank that you think that this person is, you're not going to say hi to them because you don't like Frank or something like that. Okay, So that's it for this video. See you in the next one. All right, so let's get started to create our first sandwich maker or make sandwich method. So I hope you tried to do that with the exercise. So the first thing that we need is the modifier, and we're just going to use public, and we're going to use other modifiers later, but for now we just keep that static so that we can call it from the main method. And this will return nothing. However, we want to make a sandwich, and that will be the name of this method. Okay, we don't need any parameters, even though we could have parameters such as how many slices we want to have or something like that. So let's go ahead and get started. So the first thing that we're going to tell is something like take 2 slices of bread, and then the next will be spread butter on 1 slice. And you know what? I'm going to copy my results here, so you don't have to watch me type it out all the time. But the general idea is that you have done this by yourself anyways, so you don't need to code along right now, unless you didn't finish the exercise. So spread butter on 1 slice. Then step 3 is to add a slice. Step 4 would be to put 1 slice of bread on top. And finally, our sandwich is gonna be ready. So let's use this make sandwich method inside of our main method. Okay, so we call it with the name and parentheses and a semicolon. So let's run this and we will see it says take 2 slices of bread, spread butter on 1 slice, add a slice of cheese, put the second slice of bread on top. Sandwich ready! Yeehaw! So now it's not part of the exercise, but I want to modify this code a little bit so that we take in an int, and I'm going to call this one pieces of cheese. Okay, so the idea is that when we call this method, we need to define how much cheese we want. So here I'm going to have to add a number. So let's say I want to have 2 pieces of cheese or even 3 pieces of cheese. So how am I going to use these pieces of cheese now? Well, I'm going to use it in here. So I'm going to use a for loop where I'm going to say, as long as I is less than pieces of cheese, I want to add pieces of cheese or slices of cheese. Well, maybe we should call it slices of cheese then. Slices of cheese. Okay, so with that, we now have a sandwich maker, which even takes into consideration how much cheese we would like to have on it. Now, obviously, we could add ham on it as well, or anything else we like lettuce or something like that. And if you did that, good for you. So I hope you made your perfect sandwich, and also are going to make your perfect sandwich after that in real life and not just in coding. And now let's go ahead and run this method, and we will see we have 2 slices of bread. We spread butter on 1 slice, we add cheese, we add cheese, we add cheese, and then we put the second slice of bread on top. So now, obviously, instead of having a fixed number in here, we could also get that from the user. So we could just use scanner, scanner, new scanner, and system in here. And then we're gonna close the scanner. So scanner close. And now we're going to use the user's next int here. So actually we could use it directly in here. So this is something that I want to show you as well. If you are calling a method that results in the same data type as the argument that you need to pass, you can use the method directly. So that was a long sentence and a lot of things going on in that sentence. So let's have a look at what I mean. So if I have slices of cheese 3, and slices of cheese we know is an int type. Okay, so if I look at the scanner.nextInt method, nextInt, we will see that this nextInt method is returning an int. So it gives us an int, which means that I can just use this scanner nextInt directly in here. So I don't need to create a variable. I could obviously have created a variable amount of cheese, for example, right? I could have done it like this and then use this variable as an argument in here, or I could just use nextInt directly in here. Okay, so either way is fine. The other one could be a little more readable, you could say, but I think this is still fine for our example here. So now let's run it again. And well, we don't know what we need to do, but let's just say 4, and we see we add 4 slices of cheese. So maybe it would be good to also let the user know what we want from him. And we could say, how much cheese do you want on your sandwich? Okay. And that will make it a little easier. So how much cheese do you want on your sandwich? 3. Maybe we should be even more precise. How many slices of cheese do you want on your sandwich? Because that makes it clearer that we are looking for a number instead of a text where we could have entered something like, I want 3 pieces or slices of cheese, or 3 cheese, or whatever. So yeah, I hope you enjoyed this little exercise, and also the alternative route that I've shown you with a parameter as well as with a for loop that we have here. And with that, see you in the next video. All right, so in this video, we're going to talk about something that is a little more complicated, but it's still very important for you to understand. And that is the difference between pass by value and pass by reference. So if we are passing a variable, or if we're passing an argument into a method, it can behave differently depending on whether it's passed by value or passed by reference. Now, what are those two? Well, in order to make those clear, I'm going to show you 2 different examples. Okay, one that is passed by value, and then the other one which is passed by reference. So passed by value is used for primitive data types. So if we are using a primitive data type inside of our method declaration, which means as the parameter, what we are going to get is we're going to get a copy of the variable that we're passing. So of the number, for example, that we're passing, we're not going to get the variable itself. So what does that mean? So let's look at this example. I have this method called modify primitive, and it's going to take a number, which is going to be of type int. And I'm taking that number, whatever that variable is, and I'm going to assign 20 to it. And then I'm going to print out the number inside of the method. So I'm going to say inside method number is whatever number is. So I'm taking whatever variable I was given and I'm modifying it. And now the question is the variable that I am passing going to be modified as well? Well, in this case, it won't be, because it is a primitive data type that we are passing. So let's look at when we're calling this method. So we are calling this method with the original number being 10. So int original number 10. And then we call our modify primitive method, and we're passing our original number, this variable, which was 10, right? And then we will run this code. So this method's code will be called and executed. So we will see number is going to be set to 20. Then the system out statement will be run. And then we will return back to this point here and run line number 9, where it's going to say after method call original number, and it will display the original number. Okay, so let's run the code and see what's going to happen. So we see inside method number is 20, but after method call original number is 10, which now means that we did not modify the original number variable. We did not change it. Why did we not change it? Because we passed by value. So we did not pass the reference towards the spot inside of our memory and said, okay, this is where the variable is stored, and now I'm going to give you access to that variable. No, what we did is we said, okay, well, you know what? This variable has the value of 10, and I'm going to give you the value of 10. So I'm not going to give you access to the variable itself. I'm not going to tell you where the variable is. I'm just going to tell you the value of the variable. Okay, so that's pass by value. And pass by value only makes sense to talk about if there is something else. And there is something else. And that is called pass by reference. So if you are passing something more complex than a primitive data type, and again, primitive data types are variables like int types, float types, double types, all of the primitive types that we've seen, right? Booleans, char, those are primitive data types. But non-primitive data types are, for example, arrays or objects of classes that you created yourself, which we are going to do later on as well in a few days. But now let's just look at how this works for arrays. And therefore, I'm going to comment this part out. We saw how it works for pass by value. Now let's look at how it works for pass by reference. So I'm going to uncomment this piece of code. You don't need to code along. Obviously, you can try it out if you want to, but I'm just going to try to explain you the concepts, which is more important. So just try to focus on what's going on the screen. So here we have this other method, which we call modify array. It's a void method, so it doesn't return anything. But what's interesting is it takes an array of ints. So it's not going to be one integer, but it's going to be a bunch of integers. So an array of ints. We've seen arrays, right? We know how they work. And now what I'm going to say is I want to set the value at the array at position 0 to 99. So I'm going to then display system out println inside method array at index 0 is going to be whatever I say array at index 0 is. So now let's look at what we do when we call the method, because we need to pass an array. So you know we can also pass arrays. We cannot just pass simple variables, we also can pass arrays, right? So here we're saying I'm creating this array and it has values at index 0 of 1, at index 1 of 2, at index 2 of 3. And now I'm modifying array. So I'm passing this original array, I'm passing it to this method that we just created, this modify array method. And then I'm just saying system out println method after call original array. Okay, so I just want to know what the original array is at index 0, because I know before it was at 1. So let's run the code and see what we're going to get. And we're going to see that inside the method array at index 0, and we're going to say that inside the method array at index 0 was 9, and after the method call the original array at index 0 was 99 as well. So we could obviously take this one here, this code, and modify or execute it and say before method call and see what the original array was at this point. And we will see that it was originally 1. Then inside of the method, it was modified to 99, but that had impact on the array variable in general. So even outside of the method call. Now let's try it with an even simpler example. So let's quickly create a method, public static void change name, and it will take in a string name. Okay. And I'm going to modify name and say name now is going to be Frank. Okay. So now let's also say what the name was. So system out println, and I'm going to put that in here. I'm going to say name now inside method is plus whatever the name is. Okay. And now let's use our code inside of the main method. And I'm going to create a name and I'm going to call this one Joe. Okay. So the name is going to be Joe. Then I will call change name and I'm going to pass the name. And I'm going to say name before method and name after method. Okay. And now let's run this again. And you will see that name before method is Joe. Name inside method is Frank, and name after method is Joe as well. So for the string data type, that was not changing. So strings are also passed by value. So they're passing the value, so it's passing Joe, but it does not pass the reference to Joe. So it doesn't pass the reference to where the variable called name is stored. It just gives us the value of the name Joe, and then Joe is modified. Now you could obviously say, all right, these methods, they are useless, right? They don't do anything. Well, yes, they are really useless in that sense, but the idea behind those methods is really just to explain you and really display to you that there are these different types of how you can pass a value, so an argument, to a method and how it will behave based on that type. So for reference types such as arrays and objects like that we're going to create later, the pass by reference happens. But for simple data types or primitive data types such as ints, strings, booleans, chars, doubles, and so forth, the pass by value happens. Okay. So you could think of it if it's very simple, if it's a simple data type, pass by value, and if it's more complex, pass by reference. Okay, and pass by reference, if you modify the thing in a method, the thing will be modified. Pass by value, if you modify the thing in a method, it will not be modified. Okay, so the original thing itself will not be modified. This is how you can just memorize it. Okay, and that's it for this video. I know this was a little more complicated. Don't worry about it too much. This is just something that you will need to understand as we keep going and as our examples will be more complicated. And whenever you run into the situation where you are confused as to why something is different than you would have expected, especially when it comes to passing arguments, this is going to be something that you will have on top of your head when it comes to that situation occurring. Okay, so with that, see you in the next video. Welcome back. So in this video, we're going to look at how we can actually create a method that will return something. So what does that mean? Well, it means that we are now going to create a method that can give us an output. So we saw how we can give an input into a method. We saw how the method can work with the input. And now let's create a method that will actually give us something back, that will return the output. So I'm going to create this method, public static void add, and it will do something simple. It will take an int num1 and an int num2, and it will add those two together. So it will do num1 plus num2. So now we need to store that somewhere, or we need to return it directly. So how can we do that? Well, I can create a variable called results, and I can store the result of num1 plus num2. So now I said that this method should return something, but I'm using void. So shouldn't I use something else here? Well, yes, I should use the data type that I want to return. So adding two integers together results in us getting an integer. So I will return an int because that's what this method add should do. So it should take the input of two values and it should give us the output of one value. That is the result of the adding or the addition of those two values. So now I'm getting an error. It says missing return statement. So as soon as you don't use the void keyword here, you get this error here. So you need to have this return statement. So what is the return statement? It's this return keyword, and what's following needs to be of the data type that is defined here. So we need to return an int. So we need to use an int value here, or we need to use a int variable here. So I could just say 5, for example. That would work, but that would be stupid, right? Because now my adder would always return 5. Let's try it out. Let's just say system out print line, and then the value is, and then we're just gonna say, well, let's call the add method, and we could call the add method inside of this print line statement, but let's keep it simple. We're just gonna say int num is going to be add, and let's say 5 and 13 are the two values that I'm going to add together. So now let's use this num and display the num inside of our system print line statement. So now if we run this, it will always say 5. So the value is 5. That's stupid, right? So what we should do instead is we should use result. So now result will give us the result of whatever the addition of those two values is. So 5 plus 13 is 18. So we get that result. So now instead of having those numbers hard-coded, let's ask the user for numbers. So scanner equals new scanner, and we're going to get system in here, and we're going to use the scanner to get the next int, and we're going to let the user know that he's supposed to enter an int. So please enter a whole number. And then we do the same thing. Well, we store this next int in int num1, and then we're going to do the same thing with num2. So we're going to ask for a second number. Please enter a whole number. And we're going to say that we want num1 to be passed as well as num2 to be passed. So now we're passing the two values that we've gotten from the user, and we're going to add those together, and we're going to store that inside of a variable called result. Okay, because num is not very, well, not very descriptive. Okay, so we're going to say the result is a result maybe of addition, of adding the two numbers is, and then it's going to be result. So now at this point, let's run the code and try it out. We will see that it says, please enter a number. So I'm going to add enter 13, and then enter another number, 42, and it says the result of adding the two numbers is 55. So our add method now does the trick of adding two values together. Now it's also returning the value, so it gives us back the value. Now, when you are calling a method that returns a value, it is the same as using the value in your code. So what do I mean by this? I mean by this that if we look at this example here with system print outline statement, so forth, I could have just used add, and then I could have said num1 and num2, because this here in the end, even though it's a method call, in the end will just result in it being an int, so it being a whole number. As we know, we can display whole numbers using print line. We can call a method that will return a whole number, such as an int, directly inside of this print line statement. So that's just something that you have to consider as well, or it's good to know, even though you don't need to do it this way. Okay, it's just a way of making it even shorter, because then we could have gotten rid of this line of code entirely if we just used the method call like so. Okay, like here we just used this here, then we could have gotten rid of this line here. So if you want to make your code shorter, you can do it this way. But if you wanted to make it a little more readable, I would recommend using it this way. And then there is one more thing that I want to talk about, and that is this warning that I'm getting here. This warning says local variable result is redundant. Redundant? Well, we don't need redundant stuff. So let's see what happens if I let the IDE do its magic. So we're going to say inline variable. So what it does now, it just takes this num1 plus num2 and puts it directly after the return statement. Because we saw that in order to, well, use the return statement properly for our int method, it's enough to just return a whole number. And what is num1 plus num2 going to be? It's going to be a whole number. So the result of this statement here will just be a whole number, and then it will just return that whole number, which is why we were saving the line here where it says int result num1 plus num2. So either way is fine. Again, I think in a simple example as that, you don't need to create an extra variable, but it's again up to you. So as you see, the IDE is recommending to use a different approach, and very often using whatever the IDE is recommending to you is the better choice. But as a total beginner, this might be a little overwhelming. However, now that you know how it works, I think you should be fine. Okay, so this was our first little method that had a return value. So this is a big step forward on your journey to becoming a developer. So enjoy playing around with this, and see you in the next video. Welcome back. So in this video, we're going to just do the same thing with the subtract method, and I hope you tried it for yourself. It was a very simple exercise, yet it gives you a little bit of a feeling of how methods that return something works. Okay, so let's get started. The first thing that we're going to need is our public keyword. So public static int, and I'm going to call this one subtract. And it will take int num1 and int num2, and what it will do is it will return num1 minus num2. Cool. So now at this point, let's go ahead and use the subtract method. So we get the two values from the user, and then we're just going to, instead of add, we're going to subtract. So we're going to subtract num1 from num2. And we're going to say the result of subtracting the two numbers is going to be the result. So let's run this, and we enter a number, 125 and 12, and we see the result of subtracting the two numbers is 113. So that's already it. Very simple subtract method, very simple way to get it done, and I hope you enjoyed it. So now let's go ahead and learn some more about methods. For one of the next exercises, we're going to need to know how to create a random number. And it's pretty cool how easy it is in Java. Therefore, you can use the random class. And the random class can be used in a similar fashion as we've seen with the scanner class, for example, right? So let's go ahead and just try it out and get a feeling for it. So the first thing that we're going to use is random. And you see random is inside of Java util, so inside of this package. Now, this random class, we can create an object of or a variable of by just giving it a name. So I'm just going to say random. And then we need to use the new keyword and random once again. So this now creates our random generator. So this random variable is going to be our random generator. And we can now go ahead and use that in order to create, for example, a random int. So I'm going to say my random num here, and I'm going to use this random generator, and you can see that it already gives me a few options. So it says random next int, random int bound, and random int origin and int bound. So let's try all three of those to see what they do. So the first one is going to be random next int. So I'm going to display that system.out.println, and I'm going to say random num is, and then plus my random num. So let's run it. So we get quite a big int number here, right? But what if we wanted to get a random number of a certain value? So let's actually run it again just to see that we get a different value. So you see, it is different. Each time that we run it, we get a different value. It can even be a negative value, as you see. So it takes the entire integer range and just gives us a random number within that range. So now let's say I just want to have a random number that goes all the way to 100 excluded. So bound all the way up to 100. So if I run that, now I'm going to get a random number that goes from 0 to 99. And there we are. It's beautiful. I get a random number every time. And what if I want to get a random number within a certain range? Well, therefore, I can just go ahead and say bound. Well, now it turns into origin, and then bound. So let's say between 5 and 10. I want to get a random number between 5 and 10. And now it's going to be 8. Next time it's going to be 5. Then 8 again, 7, 8, 5. Well, I get the 5 an awful lot amount of times. 7, 8, 9. So you see the 10 doesn't seem to want to appear. It just shows you that the 10 is outside of the range. So it's not included. You can even see that. The upper bound exclusive if you hover over next int for the returned value. So it gives us a value between 5 and 9 because 10 is excluded. Okay, so now you know how you can use a random number. And I believe this is really powerful. This is very cool because it gives you a lot of flexibility and a lot of cool things that you can do with it. And one of them will be our next little project that we're going to build. So see you in the next video. Welcome back. So in this video, we're going to build a word scramble game. And what it will do is it will take a word and it will scramble it. It will mix it up so that it is difficult to read. So for example, welcome to Word Scramble Wizard. Unscramble the magic words to score points. And the scrambled word is gmika. So what is gmika? Gmika could very well be magic, right? So let's enter the guess, magic, and we see you have unscrambled the word. Your current score is 1. Do you want to play again? I'm gonna say yes. Scrambled word is dwazir. So what could be dwazir? It could be wizard. Okay, let's hope that's right. It says correct. You've unscrambled the word. Your current score is 2. Do you want to play again? I'd say yes. So now it's Salem. Salem. What could that be? I have no idea. Let me actually look up the word list that I have. So the word list is alchemy. It could be alchemy, right? Holy smokes. Yes. Let's try alchemy. Yeah, that was right. So I could have entered something wrong. Let's do that for the next try. So cauldron, I think, or something like that. Cauldron, yeah. Let's call this one potion. Okay, no idea. And it says wrong. Attempts remaining 2. So we even have multiple tries. Your guess? Well, let's say cauldron. Your score is 4. Woo! Do you want to play again? I say no. Thank you for playing. Your final score is 4. So we're going to build this little game in this video. So let's get started. And in order to build it, we're going to need the random generator or random number generator. We're going to need methods, control statements, the input output, so the scanner, loops, and we're going to need one method that is a little bit out of what we have touched on yet, but that's something you could have researched if you wanted to try this by yourself. So that is where we're using char letters word to char array. Let me show you what I mean with this. So if you want to try to build this yourself, you could try that. So it's this line here. It says char letters. So it's a array of characters. And we use, let's say we have this word. So string word is equal to hello, for example. And this will now, this method here, this toChar array, will now convert the word into an array of characters. So we're changing the data type from it being a string, which in the end is just a bunch of individual characters, into an actual array of characters. Because we need that in order to scramble the word, okay? And the scrambling the word will be a method. So you see there are already a few things that you see here straight away. So you will need the scanner, you will need the random keyword, you will need the string array list with all the words that you want to be able to scramble. So magic, wizard, spell, potion, alchemy, sorcery, wand, dragon, cauldron, broomstick. So these are the words that I have in my word list. Now, obviously this word list could be a lot longer, but yeah, that's pretty much what we will start with. Oh yeah, and by the way, there's one more thing that you need to use as well, and that is how you can make a string out of a set of characters, okay? So here I can create a new word, for example, by using the new string, and then I use letters in here, okay? So this will take the char array and will make a string out of it. So with this line of code, you can convert this here back into a string. And that's just for your convenience, because your method that you will create needs to return a string. Okay, so with that, I would say enjoy building it if you want to build it by yourself. And even if you just get part of it done, that's already a great step forward. And obviously you can also just follow along if you feel like this is a little bit over your head, and just watch and build it along with me. So see you in the next video. All right, so let's get started building our word scramble game. And it is quite something that we need to build, so let's get started. So the first thing that I'm gonna have is a scanner that gets the user input and a random generator. And then I will also have a list of words. So this is our predefined list of words, and I've shown you this list of words the last time, and you can use the same words, but you can also use your own words. Okay, so the next thing that we're gonna need is a variable that stores the player score. So I'm gonna call this one player score, which will be 0. And then we need to know whether the player is still playing or not. So we're gonna have this keep playing variable, which I'm gonna set to true. So only as long as this is true, we want to create new generated words for the user. And then we're gonna give the user a welcome text. So we're gonna say, welcome to Word Scramble Wizard. And I'm going to copy and paste my code in step by step, at least if it's system out statements, because it's really boring for you to watch me type, right? So then the second text is going to be unscramble the magic words to score points. So it's just an introduction to the game so that the user knows what he or she is supposed to do. So now we come to the important part, and that is the game loop, okay? So the game loop is going to check while keep playing, we want to run our game loop. So this is how long we want the player to play. So there has to be a way for the player to say, I don't want to keep playing anymore. But that's a little bit for later. So what we're gonna say is, we're gonna say we need a word, and we're gonna get this word from the word list. And the word will be a random next int, and based on the word list's length, okay? So we've seen how this works, right? This next int for the random keyword generator, we would enter a value and it would take that as the range. So now we're just saying the range is going to be however many words we have in this word list. So the word list length. And this random number that we're going to get from this, so from this statement here, is going to be put as the index for the word list array. So this is quite a complex line of code. There's a lot going on here, right? So we're basically getting a random word. So this is the word that we want to scramble now. So now in order to scramble the word, we need to write the logic to scramble the word. So let's go ahead and write the scrambling logic. And this logic is going to be to create a method outside of our public main method. So we're going to create a new method, public static string, because this method should return a string, the scrambled string, so to speak. And I'm going to call this one scramble word. Now it needs to have the word that we want to scramble, and it needs to have the random object so that we can randomize the word character order. So here at this point, that's where we're going to need the char letters array, which will be word to char array. Okay, I gave you this line in the last video, so it wouldn't be too hard. And then we're going to use a for loop where I'm going to go through the amount of letters that I have and its length. So here I'm going to say int j is going to be random next int with whatever the length of the letters is. And then I'm going to take a temporary character, which will be my letters at the position I. I is going to be our counter variable. So if let's say we have the word, okay? So in the first iteration, I will be 0, so we're going to take W. In the second iteration, I will be 1, and we're going to take O. Then we're going to take R, and then we're going to take D. So here, this I is going to be 0, 1, 2, 3, which will give us the letters of the word. And we're going to store each letter individually inside of temp. And now what we're going to do is we're going to say letters at the index I is now going to be letters at the index j. So what's going on here? We're randomizing where this letter is going to go. So we're saying we're taking whatever letter is at this random position. So let's say j at one point is 2. So we're taking R and we're putting it at the position of I. And I is 0 in the first iteration. So we're putting R at the position of W. So we're saying temp is going to be W. So temp is W. And for now, the word is now going to be RORD, because I'm taking this R and I'm putting it at the start. However, now what we also want to do is we want to make sure that we have letters J to be temp. So now we're saying at the position of J, which was 2 in my example, we're going to put the W. So now we're mixing R and W. We're like swapping the positions of those two. And that's the logic of what we have in this for loop. And we're going to do that as long as the word has letters. So if it's 4 letters, we're going to do that 4 times. And if it's 5 letters, we're going to do that 5 times. And obviously we could, at some random chance, end up with the word being written exactly as the word is usually going to be spelled. But in most cases, we're going to get a mixed up word. Okay, so that's the logic that we have here for our for loop. So now we just need to return a word, so a new string that will take the letters array. So this now will just create a string variable out of the letters character array. Now that we have the scramble word logic, we can keep going with our game loop here. Okay, so we're saying while keep playing, we take a random word, then we scramble the word. So string scrambled word is going to be scrambled word, where I'm passing the word and random. So our random generator, this one here, which we then use. And then I can let the user know what the scrambled word is. So system out print line, and we're going to say scrambled word, and it will be plus scrambled word. So now at this point, we need to know whether the user has guessed the word or hasn't guessed the word. So we're going to say Boolean word guessed is going to be false. And we also need to know how many attempts the user still has. So I'm going to create a variable that will hold the attempts, and we're going to say the user has 3 attempts. And we're going to say while the user still has attempts. So while attempts greater than 0 and the user hasn't guessed the word yet, so word guessed is not true. For that while, we're going to say, please enter your guess. So system.out.print your guess, colon, and then we ask the user for his guess. So string player guess is going to be scanner, next line. Now, if the player guess equals the word, so we're ignoring the case here, but if it equals the word, then we know that the player guessed right. So we can just tell the user, you guessed right. So you unscrambled the word, okay? And then we know that the user was correct. So we can improve the player score by 1. We can say that the word guessed is now true. And in the else block, we can say that the attempts are reduced, and we let the user know that the user has another try. So please try again. So wrong, attempts remaining, and the amount of attempts. Okay. So then outside of these two, so outside of this while loop here, now at this point, I'm going to say if the user was incorrect, so word guessed was not right, so an exclamation mark at the beginning, then I'm going to let the user know what the right word was. So the correct word was word. And then I'm just going to let the user know about the user's score. So by the way, we're still inside of this keep playing while loop, right? So just in case you're wondering. So it's still in this while keep playing. And then we need to ask the user if the user still wants to play or not. So system, do you want to play again? Yes, no. Okay, then we take the user input and we're going to say string response is going to be scanner dot next line, and we're going to set keep playing to whatever the response is, or let's say if it's equal or ignore case, yes. Okay, so the cool thing is this equal ignore case will now give us a Boolean back. So it will return a Boolean, and that Boolean will be true if the user entered yes, and it's false if the user didn't enter yes. Now, obviously, you could have done that with a if-else case statement and so forth, but this one line does the trick, and it will store a Boolean inside of keep playing, which will be true if the user entered yes, and if the user entered anything else, it will be false. So this keep playing will go to false, and this while loop will stop. So the game loop ends, and then we go outside of the game loop and just let the user know about his final score. We're going to say, thank you for playing. Your final score is whatever the player score is. And at this point, we can go ahead and close the scanner. So scanner, close. So that is the logic for our game. Let's try it out. So welcome to Word Scramble Wizard. Unscramble the magic words to score points. Scramble word 3 sir. So I would say sorcery. Sorcery? Yes. So I've unscrambled the word. Let's enter yes. And Rikoskyomtumba, something like tomb. Let me check. Let me enter something wrong a few times. Okay, it was broomstick. I didn't know that. Do I want to keep playing? I say yes. And this one was alchemy, I think. There we are. Do I want to keep going? And I don't get the word either. So I'm going to enter some random stuff. And here I'm just going to stop playing. And it says I have a score of 2. So with that, our game worked. So I'm quite happy with that. I hope you enjoyed playing this game and also building this game. If you did, and otherwise you could have just followed along. You now have your own little scramble word game. So I hope you enjoyed it and see you in the next video.
Great job today. We have covered methods, learned about their types, and explored passing values by reference and by value. You also build a word scramble game using methods. Tomorrow, we'll get deeper into a special type of method, recursion, and see how it helps us solve problems more efficiently. So, see you then. Congratulations on making it through the entire video. You now know more about Java than 50% of other beginners. Most people give up after the first hour, so well done on sticking with it. Remember, this is only a small part of our complete Java Masterclass. If you enjoyed this and want to keep learning, there's so much more waiting for you in the full course. You'll cover everything from advanced programming concepts and GUI development to working with databases, building REST APIs, and much more. Plus, you'll get access to tons of supplementary materials to help you master Java every step of the way. So if you're really determined to learn Java, visit the link in the description below and start your journey towards becoming a Java expert. Alright, I hope you enjoyed this video. Remember to like it if you did and subscribe if you want to see more videos like this. Thanks a lot again, and I hope to see you in the course.